Hey guys, welcome to yet another video by Scaler. So in this particular video, we'll be looking into the complete career roadmap, right? So in this particular video, what we'll be looking into is various different topics, various different job roles, and how to get into a career in that particular domain. So now before we move on with this particular session, please make sure to subscribe to our channel so that you do not miss our upcoming videos just like this or other technical content. And also leave a like if you enjoy our content. And again, if you have any queries, leave a comment down in the section below and we would be addressing all of your queries. Now, before we move on, let me just list down all the topics which will be covered in this particular roadmap session. So to begin with, we'll start with the software engineering career roadmap. Then we'll be looking into the Android development and then full stack development. And once that is done, we'll be moving on with machine learning, artificial intelligence, and once that is done, we'll look into ethical hacking career roadmap and cloud architect. Once all of that is done, finally we'll look into a complete data science roadmap. So these are the different topics which will be covered in this particular session. So now let's begin with it without any further delays.
Hello everyone. Yeah, so it's my pleasure introducing Anshuman Singh sir to you today. So I have been very much honored to be mentored by him and today hosting him for this webinar. So if you don't know him, he has been twice ICPC World Finalist and was part of the engineering team that built Facebook Messenger and one of the initial people who moved to Facebook London. I think that most of you already know him and want to hear from him more than from me. So I will be handing over to him. Yeah.
Hi guys, thank you so much for the introduction, Naman. Today I want to cover one thing which is on how to be successful as a software developer. There's so many resources around that talk about how do you get really effective at data structures, algorithms, problem solving. But the truth is, like, while that is great, what I learned in my life was that when you move to software engineering, you utilize a lot of that learning, but it's a very different battle that you're fighting. So I wanted to share some of the insights from what I had learned then. Just take it as a feedback on some of the things that you should be doing. The way I usually do things is I prepare a checklist every single day. When I'm ending my work, I just check whether I have done well on all of those checklists. So this is more of creating a checklist for all of you guys, and welcome any kind of feedback, anything that you guys might have seen in your career as well. The way I'm going to structure this is actually, let me see if I can share my screen. So I'm going to just share, I mean, there's just the structure for this. The structure is, I'm going to first talk about what changes from hard skills, technical skills. I was writing code on a single machine. So for example, somebody told me, hey, I just write a code to find the first 100 prime numbers. I was able to write a code for that on a single machine. How does the same problem, or like what else to do with the same problem when you're writing the code in a software engineering job? So the first part is going to focus on that. The second part is more of soft skills. Basically, how do you hack your growth in a company? Right? Like you'll be working with a bunch of different colleagues. What do you do so that you stand ahead of rest of your colleagues? You grow faster at a company. Again, I was fortunate enough to grow significantly fast within Facebook, multiple promotions fairly quickly. And these were the things that I had followed. So might work for you, might not work for you, but I would love to share these things with you guys. All right, so starting with the first part, which is the problems when you're solving it on a single machine and when you're solving it in a distributed environment, they have different solutions. So the first change that you have to do is on how you change the mindset to solve problems when you have the same data on 100 different machines, right? So for example, I'll just take an example here, which is, let's say I told you, hey, there is a list of integers that is given to you and you have to sort it. Now, when you're doing it on a single machine, let's say if you're doing it using your problem solving, it is super easy, right? Like most of you guys would just write a sort function and things are done. In fact, most languages have inbuilt sort. You do a list.sort or sort vector.begin, comma vector.end, and in one single line, your entire array is sorted, which is great. However, think about the case when you have the same list. Let's assume this is a list of a user ID, and every user ID has some score, right? And I have such a popular platform that I have trillions of users. And I mean user not meaning because we don't have population of 1 trillion people, but let's say assume it's an entity, right? So some entity, and every entity has some score, and I have trillions of these entities, right? And that's why like a single machine is not able to fit that data on a single machine. So that's why I had to split it across various 100 machines, right? And now I say, hey, sort this entire list of entities with respect to score. So that means entities with the highest score should come first, and entities with the lowest score should come last. And since it's across machines, so let's say machine 1 has the highest scoring entities, machine 2 like the entities after that, and machine 3 the entities after that, and so forth. Now if you see this problem, I mean, as long as it was sorting within a machine, you can still use a sort function, which you would obviously do. But the problem then becomes, once every single machine has data sorted within them, there is no guarantee that there is an ordering between two machines, right? So then you do some variant of merge sorting, where you pick pairs of machine and then you merge their data. So you pick machine 1 and machine 2. You do a merge between these two because they both have sorted list between them, and then you do a merging with them. Then you might pick machine 3 and machine 4. They will again do merge sort, and then they will be sorted within them. And then that way you build it up. If you search online, you will find this algo, and this again like is not supposed to be a algo teaching class, so I'm not going to go into depth of it. I would love to, but yes, I mean it uses merge sort mechanism to sort it on a distributed environment. But as you can see, like the problem became a very different problem when it was given in a distributed environment. Very similar thing. Like let's take another example. If I say find the median in a stream of integers. Now, as long as that stream of integer fits on a single machine, it's a very standard interview question. You can have a balanced binary tree of the numbers that are coming in, or you can have two different heaps, and then you can derive your median from there. However, when the data doesn't fit in a single machine and it's now split across 100 different machines, then I would leave you guys to do this exercise. It actually becomes a binary search problem. You start binary searching for your median, and those two are again like very different problems and very different solutions. So the first change in mindset is that the code that you are writing on a single machine had a very inherent assumption that everything is going to be on one machine. All of my data is going to fit in my main memory. That might not remain true when you move to a distributed setting. So that's difference number one. Difference number two, all of you here, I can read the chat. So assume that you are working in a company which has this multi-threaded environment, right? So let's say somebody here is working at Amazon. Now Amazon has these Java servers, and it's multi-threaded. There's a code snippet there which is very, very simple. If x is 5, then let's make y as x into 2. What do you think is going to be the output of the following code? Most of you would think that the output of the following code, as in like the value of y after this piece of code executes, is going to be 10, which is true in most cases. However, in a multi-threaded environment, if you have multiple threads doing execution, it is very possible on line number 1, when you checked x was 5, the value of y, I was asking for value of y. On line number 1, when you checked x is equal to 5, and for that thread, the value of x was 5 and you went in. But before you could execute the second statement, which was y is equal to x into 2, there is some other thread that changed the value of x. So for a single threaded, yes, y's value will be 10, which is 5 into 2. But when you have multiple threads, then the value is not guaranteed to be 10. It is possible some other thread just between these two lines change the value of x. So that is another thing, like the code that you read, they might not behave as you would have assumed them to behave in a normal competitive programming scenario, or when writing code on your simple machine, which was always single threaded. So again, like the resolution there is, you can either put a lock there. I'm sure like if some of you might have studied operating systems, and there were mutex locks there. So you can either put that so that you ensure that there is only one thread executing this piece of code at a time. So you can put a lock on X so that nobody else can change the value of X. Or somebody just suggested that make X as constant, so nobody can change the value of X. Well, actually, you can make X as constant only if that is allowed as part of the application, right? Like if your application, in your application, X was supposed to, let's say, denote the number of online users, then it cannot be constant by definition. It has to change as the number of online users change. So yeah, Mohit suggested like we make this segment synchronized, which is very similar to just taking a lock, which that will actually also work. But I'm just telling you, like the transition that happens, right? Like when you were writing code on your single machine, you didn't have to care about that, right? Like if I said you've written this code and you were debugging this code, and like you look at this, you're guaranteed that Y's value will always be 10 at the end of execution of this block. That's not guaranteed in a multi-threaded production environment. So you have to be cautious of those facts as well. Let's look at the next thing. The other thing that you will realize, and this is again from my personal experience, when I was in college, I used to pride myself on writing code that was obfuscated. I would write code that is obfuscated, hard for other people to understand. I would maybe use certain operations which would be more optimized. For example, for taking the maximum greater than question mark equal to, this performs better, slightly better in C++ for taking out the maximum rather than the max function. But just writing the same code in a production environment is not good enough, because in your company, this code is not just for you. It is for you and hundreds of your team members who are also going to maintain this code. So every single code that you write, you have to assume that you might not remain at the company a year from now. There should be other people who should be able to come and read the code and clearly figure out what is happening in the code. That means your variables need to have very descriptive numbers. And in fact, this is what Amazon also tests for in their interviews, because they want this to be sort of built into you. So they optimize for code readability, because they know that like if you have empathy, if you want the other teams to also succeed, you will make your code very readable. So your variable names need to be proper, which denote what they are supposed to do. Your code needs to be readable in the sense that if you look here in the second part, with the equal to operator, there is space before, there is space after. With less than operator, there is space before, space after, so that the other person can very easily understand what is the variable being compared and against what. Even the function name instead of f, which could be anything, now seems to be more descriptive. Instead of writing m greater than question mark equal to, now we are using the max operator. So you have to, as you move from a competitive programming environment into a production environment, you also have to write code that is actually readable, that people can understand quickly. That also means you have to document your code. I'll actually come to that right after this. There's another thing here, which is code duplication. Now, this is something which doesn't come very naturally to us, but I'll actually tell you what happens in actual scenarios. Let's say I had written these two functions. The first function is just checking whether a user has passed the course or not. And let's say hypothetically, a user passes the course if their score is more than 1,000, right? So what I did was I wrote some code to calculate their score. And then I checked if the total score is more than 1,000, let's return true, otherwise return false. At the same time, let's say there was another piece of code somewhere that wanted to calculate user score. So I wrote another function which was find user score, which that did exactly this. So the exact same code has been replicated here, and I'm returning the total score here. Now, hypothetically, let's say I figured out that there was a bug in this code. Now I have to fix that bug at two different places. Imagine if I would have replicated this code 100 times at 100 different places, I would have had to go and change code at those 100 different places. That means if let's say I want to just change this to say that total score now is not absolute, but it's relative. That means I would rank every user. The highest user gets 100. The second highest gets 99 or whatever, and then like so forth. For changing that, I will have to change the logic at each of these places, which is very cumbersome. That means that as you move to production environments, companies try to optimize for reducing duplication of code. So they would rather want that any code that has been duplicated, you create a function for it, and then every single reference point is calling that function. So then when you have to fix that code, you only change that function. So there's only one place where you're changing the code rather than 2 or 3 different places. This again is not very important in a competitive programming, because as long as the code works, as long as it gives the right output, everybody is okay with what you wrote. But as you get into a job, this becomes important, and this is something you should keep in mind. Let's look at the next thing, which is what I was saying in just the slide previous to us, is like the code should be readable. At the same time, you should document your code. Now, this is the mistake that most top programmers make. They believe that documenting the code is a waste of time. Why should I be documenting my code? This is completely non-productive. It's not getting a new feature out. The truth is that you're writing code not just for now, unlike competitive programming or participating in contests or participating in a HackerRank test. You're writing code for the next 5-10 years. If let's say you go and work at Amazon, if you go and work at Microsoft, if you've written really beautiful code and your whatever you worked on is still functional, it will probably be there even 10 years from now, 20 years from now. And that is what you should try. I mean, your whatever code you write is your baby. It's your production, right? You would want that to be with people. Even 10 years from now, people should be able to say and say, for example, that this code was written by Archit or Bhupendra or Arshad or Aditi, right? And you should feel proud about that. So for that reason, it's very important that you document your code well. So even 10 years from now, if somebody comes and reads your code, and they will be able to understand the code fairly well, they look at the structure of your code and they say, person who wrote this code was really had cared about me, because they took this additional effort to help me understand what this code is doing. And that's when nobody changes your code. To succeed in a software engineering job, there are two things that happens, which is unlike what you do in college: code reviews. Whatever code you write, nothing goes into production till somebody has reviewed your code. Somebody will review your code and leave you advices on what mistake you made. Make sure that every single code review that you get is a learning opportunity for you. Ask yourself the question, what did this code review teach me? And you should be willing to give it back as well, right? So become a master at code debugging. In fact, even today, if you're in college, look at code samples from different people, help them debug your code, because this will help you when you go and join a job. Code debugging is important. When you do code reviews, if you're not able to pick out on bugs by reading through the code, it is possible that a buggy code goes into production and it breaks your system. Let's say if you were building Messenger, it would be, and you were the owner for it, you would be really sad if somebody wrote a code and you were not able to figure out the bug there and it went into production and Messenger was down. So you would want to become a master at code debugging. All right, so let's go to the next part, which is now the other thing is, a lot of us judge each other by just the knowledge of data structures and algorithms. I remember, I mean, when we were in 4th year, people would compare each other on who knew how much on data structures and algorithm, or how much research somebody was doing. I mean, those were the two parameters on how we would compare each other. The truth is that while data structures is really good to help you be effective at your job, it is not enough. It is not enough at all. And one of the couple of examples I gave, right? Like one was a multi-threading environment, one was this distributed environment. Then there are other aspects. Like, for example, there is high-level design. And I'll give you an example for that. So let's say somebody told you that build a system which can shorten my URL, which is what you call as tiny URL, right? Like I have this big link. Can somebody shorten it and give it to me so that I can share it at different places? And when people click on that link, then they get redirected to the right big URL. Like the service is very simple, right? Like anytime somebody requests you to just shorten a URL, you generate some random code. you make that tinyurl.com/ that code, and you return that tiny URL. And when somebody tries to access it, you just, since you have stored that, now you also have to store the tiny code to actual URL mapping. Since you have stored that, you can look it up and then you can return the right thing. Now, think about the case when your system has grown so big that all of the mappings that you have, which is your tiny URL to the actual URL, all those mappings cannot be stored on a single machine. Right? So my machine, let's say the laptop that I have, it's a 1 terabyte laptop. I have generated so many entries that now my laptop is full and I cannot store the entries here. So in that case, let's say now I have 2 machines that are storing this data now. Some of the data is on machine 1 and then some of the data is on machine 2. So when somebody asks me, hey, what is the URL corresponding to the tiny URL, let's say XYZ, then I search whether XYZ exists on machine 1 or machine 2. If it exists at either of those places, I look up the corresponding entry and I return it back. Very simple. However, let's say somebody comes and says, please shorten a URL for me. Now, when I shorten the URL, let's say the code that I generate was ABC. Now, before I store it, I want to be sure that ABC has already not been generated before. So I go and check in DB number 1, which is machine number 1, and I go and check in machine number 2. Let's say I did not find ABC. And now I proceed to write ABC in machine number 1. It is very possible at the same time there was another thread on machine number 2 that was doing the exact same thing with ABC. So it also checked machine 1 and machine 2, and it found that there was no ABC in machine 1 or machine 2. And as a corner case, both machines have now an entry for ABC. That becomes a problem, because when somebody comes and now asks you for what is the corresponding URL for tinyurl.com/ABC, now you have 2 conflicting entries. There's one entry on machine 1 and now there is another entry on machine 2. That means there is a consistency problem. So these kind of problems arise when you are working across different kinds of systems. Again, I know I would have loved to go into depth of this case study, but again, this is not really a study on high-level design, so I can't go into depth. But all of this comes as part of system design or high-level design, right? Like you're trying to design systems, design components, so that your system is foolproof against any kind of consistency issues or availability issues. You do it when you're designing large-scale systems. Very similarly, there is an area of study which is called low-level design. This is that once you have figured out your components from high-level design, how do you structure your code so that it is, when you have to add a new feature or when you have to add a new object or a new actor, for example, let's say take Amazon, right? Amazon might have tons of feature today. When they have to add a new feature, how should you design your code so that the additional amount of work to add a new feature is as less as possible? I'll give you an example. And this is again a very rudimentary example, nothing to do with the real world. But assume, let's say somebody said, hey, actually write a code where you design this creature called lion, and lion can eat, drink, walk, and sleep. So you write a code and you sort of define how eat works, how drink works, how walk works, how sleep works. Now tomorrow somebody else comes and says, now I also want to support a dog who can do exact same things: eat, drink, walk, sleep. In your format, you'll have to duplicate the same code for a dog and then redefine those functions. But it is possible dog and lion might have some similarities. Maybe they eat the same thing. The eat function looks exactly the same. So in the current case, you're duplicating code. But if you use OOPS principle, which is object-oriented programming principles, you can probably define a parent class which was animal, and then lion could have been defined there, and a basic eat, drink, walk, and sleep function is defined for animals. So as you add more animals, you probably don't even need to implement certain functions. Those just get carried forward. Right? So your additional effort of adding a new feature or a new actor becomes significantly less. This is a different area of study altogether, which is called low-level design and design patterns. There are a bunch of books on that. We'll actually post links to certain books that you can read on your time on design patterns. Some of the design patterns are builder pattern, which exists in Java. factory pattern. Builder also exists in Python. There are singleton patterns, and so many more features, design patterns, and different design patterns are valid for different use cases. The third thing is, which is also, by the way, checked in interviews as well, is how do you interpret questions? Can you gather requirements? For example, let's take the same example of tiny URL, right? So I say, hey Archit, why don't you build a tiny URL, right? And Archit says, great, very easy. I'll build this service that stores the tiny URL to actual URL mapping in a database, and I will return whenever somebody says, give me the mapping of tinyurl.com/xyz. I look up the mapping and I return the actual URL. Great, all done. Now tomorrow, the person who had actually asked you came and says, hey, I actually want to see statistics. I want to see who is accessing which URL, what location are they accessing it from, what browser are they accessing it from, which age group is going to what kind of URLs. And you say, shit, I haven't built that. I'm not tracking when people are requesting, who is requesting. I'm only tracking tiny URL to actual URL mapping. So you forgot to store it. You lost all of that data. And when you lost your data, then there is no way to recover it, because you can't replay what happened in the last 7 days. So, but if you knew this requirement before, if you knew that statistics was important, you would have designed with that in mind. So when somebody gives you a problem, and in real world, in your job, usually problems are going to be not as well defined as you get in a competitive programming, right? Like competitive programming has everything defined. It gives you limits. It tells you what cases are possible, what cases are not possible. But real world problems are not that well defined. When you're defining Uber like cab service, you don't know, like at what speed cars might move. Maybe the driver goes to sleep. Maybe people are not reachable. There's so many different corner cases that nobody told Uber in the beginning. They had this big scandal that happened in Delhi that was never specified as part of the problem. You have to go and gather all of those requirements. You have to foresee a lot of these corner cases yourself. That is what would make you more effective as a software developer, right? Never jump to solutions. The first part is gather requirements, understand what the end user might want. The other thing is, a lot of us think, and this is just a myth, that CS fundamentals are not important. As long as I have done well with data structures and algorithms, I'm going to do well in my job. The truth can't be farther away. All of what you learn as CS fundamentals in operating systems, networking, databases, everything gets applied. If you do not understand databases well, then you'll not be able to create the right indices. You'll not be able to create the right schema. You'll not be able to make the right choices. If you do not understand operating systems, then, these are very common problems. If your code base is in C++, there's so many times that your application would have some kind of memory leak. Memory leak is basically when you're allocating an object. For example, you can say that A is equal to new int whatever, but you forgot to free A. So free the memory that you allocated for A. So it is very possible you have memory leaks and then you do not understand how to debug those memory leaks. There are these softwares that help you analyze the memory and what kind of objects there are. But those softwares don't tell you like this object is of type this, it was declared on this particular line. That is not what they will give you. You will have to understand how memory is managed, how paging is done to be able to make sense of that information. Java, for example, has garbage collection, right? So Java doesn't care about memory leaks. Java says, hey, actually, I'll maintain references to objects that you create. Whenever an object does not have any more points of code referencing it, my garbage collection will kick in and it will free it. Now, garbage collection would has different kinds of variables, different kinds of lives of variables. So how do you tweak your garbage collection for your application? Because there are different kinds of applications, right? There are certain applications where you want your requests. You have a lot of parallel requests, and in parallel, they are very low on memory footprint, and they get executed quickly. At the same time, you have these requests that might be very heavy, right? For example, I want to fetch my newsfeed in Facebook. Now, fetching a newsfeed for me, if I want, let's say, 100 different items in one go, that is very heavy on memory, right? Because I am getting like 100 different posts along with number of likes, the content, and a bunch of links that might be in those posts. So I mean, even understanding that for my kind of application, how do I need to tweak garbage collection? That also is requires you to understand memory management well. That requires you to understand how is memory managed inside, let's say, a Unix operating system. So again, like CS fundamentals are important. Just busting a myth here. This is, I heard somebody say it, so I wanted to make sure you guys understand that if you have to be successful as a software developer, CS fundamentals are important too. All right, this is the biggest myth that I have seen with people around me. When people move into their new jobs, they believe that writing tests, writing unit tests is beneath them. It is somebody else's job. Somebody else should come and do it. It doesn't help me build a new feature. I should just be writing code, building a new feature. Why should I go and write tests? Problem is, you write tests so that no other person, and you have to assume that there will be people who will not have the same kind of understanding as you do. There will be people who will not test your part of the code. They change something else for their own use, and your part of the code got affected. You want to write tests to make sure your part of the code is not affected. For example, the earlier case that we took, that there was a function that calculated some user's score, right? And let's say for my part of the code, I wanted that the scoring function gets changed a little bit. So I make some tweaks there. But that function could have been called from 99 other places as well. There is no way to guarantee that those 99 other places are not affected and something doesn't break. So you write tests. If you were one of the persons using it from one of those places, you write unit tests so that when this guy changes this function, your unit test immediately starts failing. And somebody comes and tells this guy, hey, dude, what did you do with the code? This unit test is failing. You should go and fix it. So the writing the test helps you with the initial parameter, which I told you, which was make sure your code is written to survive for the next 10 years. Even in 10 years, there are people looking at your code and admiring what you did. If you write tests, that is going to happen. If you do not write tests, then somebody or the other is going to come and break your code, and then somebody or the other is going to come and change your code. So your code will not survive 10 years. All right, so we're done with the hard skills part. I'm going to finish this part quickly, and then I'm going to take questions from all of you guys. Just please take notes about what we are discussing today, and then I'll take questions. Now, software aspects. This is more of how do you hack growth within a company. The most common mistake I see people doing is that they believe that their manager is somehow always judging them, and that is why they don't open up to their manager, and they crib कि my manager, यार मेरा manager ऐसा है, promotion नहीं दे रहा है, यार मेरा promotion हो नहीं पा रहा है, I don't know what is going wrong. Just translating it in English, I mean, they crib that the manager is at fault for not promoting me. My manager hasn't been helping, or like I'm not being promoted. I'm extremely unhappy about that, right? You need to make sure you're talking to your manager very clearly. In fact, the conversation that I used to have with my manager was, look, I want to get promoted as soon as possible. Tell me, what do you expect me to do to be promoted? And the answer there was, in Facebook, there were levels defined. And the answer there was, as long as you're doing what is the duty of the level above me, if I am already doing that, then I can be promoted. So the manager would very clearly outline for me, look, here is what you should be doing if you want to be promoted. Again, I'll give you my personal example. So the first promotion, I joined, and I had asked a very similar question on the second day of my joining my team. And my manager told me, look, here is, I've seen you in the first 2 days, you've been writing code for this particular component. If you start owning this component end to end in the next 6 months, I'll get you promoted. So then I knew what I had to do. My manager was my friend, and he was helping me and sort of helping me draw a path to how do I get promoted. You guys should do something very similar, because your manager's job description is to help you grow. The job of an engineering manager is to help their reportees grow. to help them perform better. The manager is there to help you. They're not there to always judge you and stop your movement upwards. So that's the first thing. Second thing is, the second mistake I see people doing is they demand ownership. They say, I want to work on this component. Please ask the other guy to not work on it. I'll do it and I'll own it, right? For example, let's say there is a service within InterviewBit which is, let's say, takes care of engagement. Engagement, maybe let me take a different example. Let's say there's a part of the InterviewBit that takes care of how mentors function, how the sessions are done, right? Now, if somebody comes and says that I want to do it and please remove the other people who are working on the mentor piece of code today, I want to take ownership, then that usually is not really executable, because if I go and remove the other person who are working on it, what explanation do you give them? The solution there is that if you really are interested in working on something or in owning a component, you start contributing there. You start looking at what is broken there, you start fixing it. Over a period of time, you would have made so many changes to the component, which are again like on the positive side, that people would automatically start seeing you as the owner of the component. They know that nobody knows that component better than you do. And then you automatically become the owner. You don't need to ask anybody. So don't demand ownership, earn ownership. That was lesson number 2 on the softer skill side. And when you do this, like, you start doing better than your peers automatically. You don't really have to go and demand things from people or start a fight because you were unhappy on something. The third mistake that I see people do, and that is on both sides, getting feedback as well as giving feedback. I'll actually address the giving feedback part first. Most of us, when we graduate out of university, we are very raw, right? Like you talk to your friends in a very informal fashion. You even abuse your friend and your friends are okay with that. If something is wrong, you're very okay being very harsh to them, and your friends, being friends, they understand. However, that doesn't work in an office-like scenario. Look, I mean, you might go and join a company. There might be 10 other people that you don't know of who might have joined along with you. And there might be people who are senior to you as well, right? Now, when you see something which is broken, or when you see somebody who has made a mistake, and if you really feel very strongly about what you're building, if somebody made a mistake and, let's say, created a bug in your code, you would feel really bad about it, and you'll go and give a very harsh feedback. You don't know anything. Tumhe kuch nahi aata hai. Kya kar diya tumne mere code ke andar? But the thing is, when you give a feedback like that, that feedback is not constructive. You're not helping the other person understand how not to repeat the same mistake again. And especially when you attack the other person, they then start holding vendetta against you. They rather, instead of improving, they start thinking, ki, how did this person talk in that tone to me? I will show him. I will do something which will hurt him. You don't want that to happen, right? Like the reason why you went and gave feedback to somebody was not to create enemies. So there is a very simple framework of giving feedbacks. This was actually created by McKinsey. So the simple framework is, when you are giving feedback, do not express emotions or opinion. The first part of the feedback should only be facts. For example, I'm going to take an example scenario so that it makes sense. Let's say InterviewBit actually hires problem setters to create some problems for contests or let's say like assignments within Scalar Academy. Now, let's say I have hired a problem setter, and I had asked the person to create a problem for a contest. And it was a very, very important contest. So the person created a problem, did whatever they could from their end. But in the contest, let's say the problem broke. It had wrong test cases. So we fixed it, but like obviously like that was not a very good thing to happen, where like you have this very important contest happening and there was this problem which was broken. Now there are two ways of handling it, right? Like I go to the person and I start saying that, hey, you are so incapable. You couldn't even handle setting a problem for this contest. I had told you this was a very, very important contest. Why couldn't you have tested it properly? And all of that. The person actually gets angry. The person becomes starts holding negative feelings about me in their heart. However, if I go and just tell them fact, if I tell them, hey, person X, you had set a problem called ABC for this contest. That is a fact. The person cannot deny it. ABC had a problem in the test cases, and we found that out during the contest. It was not fixed before the contest. What I feel is we should be more diligent going forward. And the way to do that is maybe we should be testing them by writing solutions in different languages and checking whether those pass or not. Now, when you give the feedback in that tone, the other person knows that you're not expressing your opinion or emotion, but you're rather telling them facts, and they cannot hold a grudge against you for stating facts. So your feedback should always be driven by facts and then maybe corrective actions, and be willing to discuss corrective action with the person. When you're getting feedback in a very similar way, you should always be asking for feedback. I mean, even when you know you're doing well, you should go and ask your manager, your peers, hey, how am I doing? Do you think there's something else that I should be doing differently? And there would be people who would not have seen this presentation and will give a very harsh feedback sometimes to you. And in those cases, make sure you don't take feedback on your ego. To understand the underlying reason that somebody is giving me feedback is because I did something wrong. How do I fix what went wrong? How do I figure out corrective action for what went wrong? If somebody is giving me feedback, one very common thing that we do is we get defensive. We start saying, "Arey nahi, but ye aise nahi, actually to ye aisa ho raha tha, is wajah se aisa ho gaya. It wasn't my fault. I actually had good intentions, but look, the situation was like this, which is why it happened." Don't get defensive. Let the other person complete and try to reason. Maybe there was a mistake on your end. Whatever little, accept that and say that, hey, I'll figure out a way of fixing that going forward. When you do that, then you improve over a period of time. If you get defensive, if you never accept that you make a mistake, look, all of us make mistakes. If you do not accept, you will never improve. So always get feedback, never take it personally, and figure out corrective action. While giving feedback, be very polite, state facts, and state corrective actions that you feel. When you do that, you will move up the ladder because people will like you. You don't want to create enemies anywhere, especially so in your current company, right? The last thing, I promise this is the last thing. As I said, be nice, be respectful, do not create enemies. Mostly you would have to work in teams, more so because teams can get done a lot more than you can individually do. The third thing which a lot of people do is they spend too much time on counting how many lines of code I have written or how many number of hours I've spent in the office. Don't do that. Look at impact. What should I do so that, let's say, my product becomes better? More people start using it, and state that. I mean, when somebody asks you, what have you done in the last 6 months? There are two kinds of people. There is a person, one who would say, I have written 1,000 lines of code in the last 6 months. And I have gone and done these many meetings, and I have done some X and Y and Z. And there's a second person who would talk about the change that brought. That person would say, hey, actually, in the last 6 months, I have increased the number of users using the product from, let's say, 100,000 to 200,000. I have reduced, let's say, latency or the time that the service used to respond back with by let's say 100 milliseconds. So when you state impact, that's a very positive sign for the person who is asking you for what you've done, right? Like, managers usually optimize for impact rather than what number of lines of code you wrote or like how many number of hours you spent in office. And the last thing is, and this is again like something which was very common within Facebook, there was a very term which would go around, which was growth mindset. Always think about growing, no matter where you are. You might be the CEO of a company, you might have already become like this VP of your organization. Even then, always keep thinking about what do I need to do next so that I grow. Have a growth mindset. And usually growth happens when you learn new things. So prioritize learning new things. Never be afraid to take risks. Maybe today I am coding in Java. This new company that looks very exciting codes in Ruby. It's okay. I'll learn Ruby and then I'll be able to go and do well there. So do not be afraid of learning. Always prioritize learning. If you are capable, then everybody would want you. The best job guarantee is capability. Nothing else can give you job guarantee. Jobs go away, people get laid off, but a capable person is always in demand. So always focus on growth, learning, building capability. If you're capable, you'll always be in demand, and as a result, you'll end up making a lot of impact as well as a lot of money. Both happen in parallel. So that is all from my side, guys. These were my learnings, personal learnings. Again, there are some of you who might have had different learnings, but I would love to take up questions as well. And
Yeah.
Naman is also here.
Sure. Thanks, Anshuman. So, guys, I will be taking questions from Slido, and you can post your questions here in this link, or the link is present in the description of this video. So we will be taking questions from there, or you can put your questions in the comments. I will be taking from both these sides. Okay. Okay. So let us start with the questions. The most popular question we have is that for CP, we mainly focus on algos and TS, right? But what topics should one be proficient for building large-scale systems? I think in the chat you mentioned about high-level design and low-level design. But is there anything specific in them? How to learn them? And also, like an extension to this question is a question from a person who is not from a CS background. So, as you mentioned, that CS fundamentals are important, and the high-level and scalability things are important. So, how can he learn those things?
Right. So usually, like, there are people who learn in two different sets, and like there's some people who find it easy to learn on their own, like being very motivated all throughout. For them, if you want to learn, let's say, high level design, there are a bunch of resources on the internet. There are some very good books. We'll post links and resources just after this session is over, where we would give you links to some of these resources. In general, like, there's a blog called highscalability.com, which discusses the architecture of different websites, how have different companies scaled. So we'll post resources there. You can go through it. And there is a second set of people who might not have the same background as other people, and they might not be able to understand these resources in the same fashion as somebody else might. There are a bunch of courses that are there all around. There are some paid resources. For example, educative.io has some good content on high level design. Scalar Academy at the same time does very formal a course with proper teaching material on both HLD and LLD. So you can join Scalar Academy. That also will help you. At the same time, like, when it comes to CS fundamentals, now people who come from CS background, who have spent time in colleges, they have gone through formal coursework of doing that. Even if you're not, that doesn't put you at a disadvantage. There are still ways of learning it. And to be honest, like, you don't need to go and read the entire book for operating systems. There are certain things that get used more often than not. Anyway, so when it comes to learning CS fundamentals as well, again, like, Scalar Academy addresses that piece as well. But if you're again interested in learning on your own, we'll post some resources for CS fundamentals, HLD, LLD. These are free resources on the internet. You can go and read up there. If you're able to understand and go through all of it on your own, it would suffice. If you struggle consuming the content, then you should look at certain courses, paid courses that are there, which have live learning and which have mentors who can answer your doubts, which will help you understand these guys.
Sure. So the next question is, during the session you had discussed that how building systems is different from competitive programming. But if we have to talk about some skills from competitive programming that helped you at Facebook, were there any skills from competitive programming that helped you there, and what were they?
When you do competitive programming for a while, there are 2 or 3 things that you learn to do. One is, if you look at development cycle, let's say Sachin is a developer, right? And if Sachin is spending 10 hours developing something, the typical pattern is people write code for 2 or 3 hours and then they debug the code for the next remaining 5-6 hours. Majority of the time is spent on debugging. So if you've done competitive programming, if you keep writing code very often, I mean, you do well in computer programming if you make less bugs. Like you're able to get your code right in one go. I mean, your code compiles, runs just in one single go. So one thing which you get really good at is writing bug-free code. So your efficiency as a programmer goes up because you've written these complex codes and which have run in the first go, right? So one is writing flawless bug-free code, saving you time on debugging. Two is that when you're working with a very large system which has a large code base, the one skill that you really need is that you go through the code once and you're able to understand what is happening in the code. And then, like, again, the more coding and the reading through other people's code you have done, the more skill you develop. So that also helps. That being said, most of the principles that you learn in DS Algo, for example, like we would solve a lot of problem on network flow, max flow. All of these were not utilized in the dev work, but like the process to get there, the process to understand all of these principles, they help because it got me to a position where I could write bug-free code. I could understand code quickly because I had just seen so much obfuscated code in the past.
Sure. So there is a question that how to deal with repetitive or the work which we don't like in project. I think you were fortunate enough to work on projects that were making an impact and probably you liked it, but many people are not at that situation. So how can they deal with that and learn alongside it?
Right. So yeah, that is again another another problem with a lot of work. I mean, and that happens with all kinds of organization. Even if you are studying at, let's say, or you're working at, let's say, Amazon, it is possible like there are certain teams that have very repetitive work, which might not give you enough opportunities to learn. I would say even in those cases, if your work is repetitive, the good thing is like your work isn't very challenging. You can finish your work quickly and then focus the rest of your time to figure out what are the things you can do to upskill yourself, right? So as I said, like learning, I mean, when we talk about, for example, high level design, not everybody gets to design components, not everybody gets to architect these high traffic systems. If there are 100,000 developers, then probably 100 out of them get that opportunity. That being said, if you understand that, that makes your transition into an SD2 or SD3 or an architect faster than everybody else.
Okay. So there have been some people are asking what are some good books how to develop that growth mindset. Do you have any book recommendations for that?
Actually, there are a bunch of books. Somebody actually in the chat had posted the 80-20 thing. I actually, on the growth mindset, I have never read a book, but it's been more through my own personal experiences talking to people. That being said, there are books like 0 to 1. 0 to 1 is actually a very strange choice because it talks more about startups. But if you just read through the book, you'll understand like how the psyche is around growth most of the time, how compounding works. Even if I'm growing by 2%, 3% every day, that compounds to become a huge number over a period of time. So I mean, I'll actually research and then maybe suggest books. Right now, in my personal experience, I did not have to read a book. I just experienced that through people around me.
Okay, so there is a question that when to say that it is done with a company, when to quit a company. Is there any particular situation that happens that you just decide that nothing more is possible here? So when to quit?
Right. So if you're in a job and you're thinking of quitting, there are a few things that you should consider, right? So usually why people should stick around for more time in a company is because if you keep switching very often, you don't get to learn enough, because usually when you go and join a new company, it takes you about a month or two to get used to how things happen in that company. And for you to actually build something which has enough impact, it takes you about a year. But let's say you entered a company, you saw that, hey, actually, the culture is really bad. Usually, if you're in a situation where there is a lot of politics and people who butter up their managers get promoted, other people do not get promoted in spite of the contribution that they're making, then it's probably not the right place for you. You should look at moving out. If you're going and talking to your manager about these things and how to progress forward, and the manager is dissing you, you're not willing to cooperate. Good organizations do not have those attributes. They look at investing in every single employee. They want to optimize for every single employee's growth. If you are at a place where people are willing to invest in your growth, then you should stay there, because even though today you might be in a project where you're not getting to learn a lot, it is possible when you talk to your manager and you express your concern, the manager might be able to draw a path for you where you move to a project where you might get to learn a lot.
Okay, so there's a doubt from a person who probably is shifting from a startup to a MNC. Says that in a startup, focus is on speed of coding and not much on code quality. And now suppose he is trying to shift to an MNC, will it be a problem? Because in MNCs, there is a lot more focus on code. So is that a hindrance or is that a problem?
Yes, initially there will be. Initially, probably for the first 1 month or so, you'll see that there is so much more attention that is given to code quality, and you'll feel
Frustrated by it, because you wrote a code, you know it works. Now somebody is telling you to go and change that code. You did some changes to code. Some people came up with other suggestions. Then you change that as well, and there's just so much back and forth happening on the code reviews, which causes frustration. But believe me, it's just going to be there for about a month or two at max. Post that, you'll get into the habit of writing code that is structured, and that is actually good for you. I mean, like, understanding how to write code that is of very high quality, that is good for you. What is going to happen though is, like, depending on what team you end up at your MNC, the amount of impact that you were able to make at a startup versus the MNC, that might go down. But again, it's dependent. It's dependent on, like, which company you are at, which team you are at.
So there's a question on any advice to freshers on what to focus on early in the career, and an addition from my side, what not to focus as well early in the career.
Got it. By the way, today's session was primarily on things that you should focus on, what you should focus on and what not to focus on. For example, bad thing to focus on is Hindi में एक word होता है शोषा, which is just like how flashy a company is, but doesn't really focus on getting people the right amount of learning. For a fresher, I mean, I would always say you should optimize on learning. Maybe you join a company and you figure out that the company is not helping me learn a lot. So then you talk to people around you, figure out a path on how do you get to the learning path. But the first 2 or 3 years of a career, the first 2 or 3 years when you join a job, they are formative years. That's when you are experiencing software development in a real life production environment for the first time. And that's when you start forming opinions. That's when you start, I mean, imagine you're a baby and then, like, you're learning how to walk, how to run, how to stand. You want that the people who are teaching you those things are the best people, and the company where you're getting to learn all of this is best, and you're learning the right things, right? Like, you're optimizing for learning. A lot of times what happens is you go into a safe company, but in the first 3 years, you don't end up learning enough. And then you see that there is a batchmate of yours who also has 3 years of experience, but that guy actually knows a lot more than I do. And then that's not a great state to be in.
Sure. So the next question is, what were the most challenging situations or tasks that you faced and were able to resolve in your professional life at Facebook or InterviewBit?
At InterviewBit, it was actually just dealing with people, internally as well as externally. I mean, all of what I'm able to tell you today is my learning from the past. And I wish somebody had told me all of this before. All of this I had to try and do and fail and then learn, right? For example, the entire thing about the framework of giving feedbacks. I've been at the other side where I've given feedback to people harshly, just because, I mean, when things don't happen, you get angry, right? And then you shout at somebody, or you give them a feedback in a very, very rude tone. And then you realize after introspecting that maybe was not the right way of giving feedback. How do you handle, I mean, machines are easy to handle. Humans are not. Humans have emotions. Humans have aspirations. So managing people, that was one thing which was extremely challenging for me. Two was, in general, even the growth mindset that people talk about. I remember there was a phase of 6 months even within Facebook when I couldn't focus on the right things. I would be focused on short term things. For example, let's say I am leading the reliability and latency team for Messenger. So there were occasions when I was focusing on slightly short term benefits, and I would just over optimize for that. I would spend a lot more time that was required versus not focusing on something which maybe required a month to do, but would have much bigger impact. Maybe it would have reduced the error rate to 1/10 of what it was. So prioritizing the right thing is something again which it took me time to learn. Slowly, I developed that. I remember an incident actually from my college days, from the competitive days, and I was reading through some of the messages, so I was able to see what changes have come. So in my competitive programming days, there was this coder called Triple M, who was a very helpful coder. That person would actually help out everybody who would approach them. I remember when I was just getting started. I just like some of the other coders had reached out to him for help and figuring out why my code was not working. And Triple M was again very busy man, so he did not reply. After a while, I again followed up. The person replied saying that he doesn't have time, and I wrote a very harsh and rude message to the person. It's now that I realize that maybe I mean there is a better way of handling people. There's a better way of giving feedback. There's a better way of managing expectations. I mean, person was doing me a favor. Why should I be rude or harsh to the person? So these are things that you learn with time. My major learnings is handling people and prioritizing the right things, long term things rather than short term things.
So a question is, what is the benefit of staying in a company for long period, even when you are not getting much hikes? Are there any benefits to stay? And what are the disadvantages of switching companies often?
If you switch companies often, then you usually, like, let's say if somebody comes and interviews at interview bit, I ask them what is the impact that they have made in the previous organizations. If you switch too often, you'll never have a good answer to that question because you haven't stayed at a company long enough to change a lot of things. You cannot say that, hey, actually I worked at, let's say, Grofers for a while and I was able to increase their order volume by 20%, or I was able to increase the number of people visiting the site by 10% by the changes that I did, or I made the site faster by 20%. Right? You'll never be able to say that because you've never spent enough time understanding what is happening within. And Grofers is just an example, guys. Please do not quote me there. I just took a random example. So you never spend enough time within Grofers to understand how things are working there and change things for the better. But if you spend enough time, then you're able to create these impacts and then you're able to talk about them when you go outside, right? It is okay if you're not getting hike initially. But if you know a lot more than somebody else who might be at a higher salary, then salaries would auto adjust themselves. As I said, like capability is the best job guarantee. Your current position is not. There are CEOs that keep getting fired here and there. There are CTOs that keep getting fired here and there. If they know the right things, if they are actually the best capable people out there, then they get rehired. Otherwise, they go out of job. You don't want to be the person who goes out of job.
So a question is, how often should you ask feedback from your managers? Is there, I mean, like whenever you want or anything like that?
So I usually had the framework of I had set a one-on-one with my manager to happen, a formal one-on-one every 2 weeks. So every 2 weeks, I had reserved this 30-minute slot on my manager's calendar where I would make sure that I talk to my manager for 30 minutes. And the theme of that was talk to me about things that I'm doing well, talk to me about things where I need improvement. And again, like re-stressing on the fact, look, I want to move to the next level. What should I be doing? What am I doing wrong? What am I doing right? Tell me what else should I be doing? So the whole reason why you want to do this is because you never want last minute surprises. You might believe that I am performing really well. You do not want that at the end of the year or in 6 months, whatever is the frequency of review, your manager comes and says, hey, actually, you were a bad performer. You don't want that happening. You want your reviews to be as surpriseless as possible. whatever the review, you knew it was coming because you've been talking about that for the last, I mean, every 2 weeks anyhow.
Okay, so let us take the last question for the day before we end. So, do you suggest a depth first methodology to learn, basically go into depth of each topic, system design, a programming language, even data structures and algorithms, or a breadth first approach is better? I mean, like have a high level overview of multiple topics, but being master of none. What do you?
Actually, there are both kinds of engineers, and both end up doing well. There are people who specialize in something, in the sense that there are some people who become, let's say, a data engineer, or a systems engineer, or if, well, even within front end engineer, like specific on a certain tech stack. And at the same time, there are engineers who you would call as generalist. Both are in demand. Both are good positions to be in. But do whatever you're doing, either depth first search or breadth first search, really well. I mean, it's don't go half-hearted at any of those. Even within breadth first search, there's one caveat: make sure you know enough. Do not. I mean, there's a phrase in general when explaining things which is called hand waving. Hand waving means that you know of certain terms, certain fancy terms, and whenever somebody asks you a question, you use those fancy terms to explain without really understanding what is happening beneath. So if you know less, that is okay, but whatever you know, you should have very solid knowledge on it. Always question what is happening, and never have superficial knowledge where you're just hand waving. Even within breadth first, you need to manage that too. So both approaches are fine, as long as you're not doing hand waving in any of those approaches.
Sure. Thanks a lot for taking out your time today. I know it's a weekend and still you took a time. Thanks a lot. So thank you guys for listening to us. We will be posting the books and the other resources in the comments soon. And yeah, have a good night and enjoy. Bye bye. Good night.
Thank you
Sure.
so much. Thank you so much, guys, for being patient with me and bearing with me through this session.
Definitely, advices that you gave today would definitely help me in my career as well, and hopefully to the listeners who all saw this video. Thanks again.
Hi, everybody. Very excited to go live today for this Android AMA session. Uh, Hi, folks. So we'll talk about today any and every question that any one of you has about Android. So, comments are open for you guys. I'd already posted about this session on some of my social feeds. So there are some initial questions that I got already on DMs as well as on comments on those posts, and we can start talking about those. And then as questions start coming in, I would love to take up those questions, and we can start discussing about those things, right? I think one of the first pieces that a lot of people asked me about was essentially that a lot of people ask about Android development these days is whether we should go with a native Android development, we should do Kotlin, or whether we should go with one of these hybrid frameworks like Flutter or React Native. So I think maybe that's one of the questions that we can pick up first. And in fact, that's the first few questions that have come. Dakshdeep and Akash have already said the same thing, so we can definitely pick up probably Akash's questions, Flutter or Kotlin. Let's talk about that, and let's talk about. So there's a lot of nuance to that. First of all, uh, job market speaking, I think that's what a lot of people ask about. So job market wise, the maximum number of jobs that are there, I think 90% of the jobs out there in the market are in native Android development, which means that it's going to be in Java and Kotlin. Okay. Now, that's the market situation as of today. Flutter is definitely growing. By the way, React Native is also there. Okay, so don't forget that React Native is also there. React Native, the kind of apps that React Native was used on largely, today a lot of this market is getting captured by Flutter. Now, there are particularly new startups where having separate Android and iOS teams is difficult. Very early stage startup, that's one of the places where Flutter is getting used. Two, I would say is agencies. So, design agencies, marketing agencies who also make apps for some of their clients, or small app studios who make projects for small companies, right? That's another space where Flutter is, has become sort of common today. So coming to your answer, I would say which one to pick. And a couple of things. Now, if you are proficient already in Java, by the way, okay, and you want to build up a very serious career in mobile development, you want to earn uh, a good bit of money, and you want to make a serious, 4 or 5 year long career in Android development. Today, the answer to that is still going with Java and Kotlin, right? Java and Kotlin, by the way, Kotlin is the new wave in which apps are made. But today, if you go for interviews for Android development, you would need to know both Java and Kotlin. It's very important that you understand this, that both Java and Kotlin, knowing them is important. Okay, that's the situation today. Um, Now about Flutter, I would say if you're a web developer, just for example, you're not so well versed in Java, but you're making websites, and sometimes you make a project and you feel like, okay, can I also would have made an Android app for it or iOS app for it, and just the mobile website would not be sufficient. You might need that app to be on the mobile offline first support or something like that. You can probably pick up Flutter in that case. Dart would be a language kind of easier, more familiar. Well, by the way, Dart is familiar whether you're coming from Java or Kotlin or coming from JavaScript. All of them are very similar languages to be pretty familiar. What Flutter does not solve very well is, the fact that there are a lot of external libraries for image manipulation, for video processing, for payment ecosystems. So these kind of things, there are a lot of third-party libraries. They exist only in Java and in Kotlin. They don't exist in Flutter. So even if you make Flutter apps and you want to connect deep system level things into it, like video encoding, encryption, these kind of things, you have to integrate. Then you will have to write some parts of your code in Swift for iOS and for Kotlin in Android anyway. Right. But if you're fetching information from an API and just simply showing it on the screen, right? A lot of it is just API based current information happening. So if you make a front end for, say, even if we talk about Twitter, so there's a Twitter client, you're showing tweets on the screen, something like that. Flutter is a good framework to come up and build for that. But if you're trying to build something like, say, TikTok, right? Then handling that video processing, that network pipeline, those things. Again, not saying it's not possible, but it's sort of harder. Even with apps like Instagram, which is actually made in React Native, the image processing parts are written completely in native in iOS and in Android. Okay. So I think that answers the Flutter versus Kotlin question at large. And then unless there are anything more specific in this, I would not be picking up this particular question. Going on to the next question, is Raghav Agarwal has said, how to make sure that a layout looks same throughout all devices supported by the app, and are there any tips for that? Now, there is to be an old school thinking, which is you create a portrait layout and a landscape layout. Then in portrait, you create a certain width, certain height, these kind of layouts. But the modern understanding of this is that you do how web developers do, how Bootstrap thinks about responsive layouts, right? So you might have two layouts for horizontal and vertical, right, landscape and portrait. But within portrait, for different screen sizes, use proportionality based things, like you want first half of your screen to show something, second half of your screen to show something. So you use constraint layout, and within constraint layout there's something called guidelines. So you can create a 0.50 guideline, which is at the middle of your screen, half of it, and then you can put items above it and items below it, and then so on and so forth. So I think today the conversation moreover is about the proportion of the screen to be used. Do you want like three cards to be shown in the screen or two cards to be shown in the screen, and then you just sort of implement that. Don't try to achieve screen specific layouts. Try to create a proportional layout, and then it will work for all screens. That's the modern way of doing apps. Also, one more thing that has happened a lot and people have understood is that people don't rotate their phones a lot unless they're watching media. So if only when people play games and when people watch media, they use landscape. Otherwise, they're always using portrait mode. So a lot of very popular apps by Google, Facebook, Twitter, LinkedIn, many of these apps, they lock the orientation of the activity to portrait mode, which is perfectly fine for you to do that. You won't want to bother about landscape. But For tablets, obviously, you will have to bother because for tablets, both the orientations happen. But for mobile, locking to portrait mode is something that's a valid thing that a lot of apps use these days. Okay. Hi Bilal, lots of love to you from India as well. So your question is that whether data structures algorithms are necessary for Android development and how to use. Very important question. Um, so when we talk about data structures and algorithms, it's a broad topic, right? What is needed and what is not needed. So some of the very advanced data structures like trees, tries, red black trees, binary sorted trees, min heap, max heap, uh, you know, say directed graphs. Now, these data structures are used to solve very specific set of problems. Now, understanding how these data structures are created, having the ability to manually write these data structures on your own, like you do in competitive programming, that's not needed for Android development, not for any basic level development job actually, for backend, front end, Android, any of them. The the ability to implement these data structures by your hand manually, that's not needed. Okay. Conceptually, if you know them, that's good. But your basic level data structures like stacks, queues, linked lists, hash maps. These are definitely needed because on a daily, day-to-day life, when you're creating apps, these data structures are getting used a lot. Okay, and arrays and strings. Now, very important is that you understand how arrays and strings are manipulated, how they can be manipulated using iterative, recursive ways, and a good understanding of where something like a tree can be used, something like a hash map can be used, something like a stack can be used, which problem can be best solved by which data structure. That understanding, if is there, being able to create the data structure on your own without looking up the internet, those kind of things people generally need for programming interviews. Those are not needed for development. But knowing which data structure is supposed to be used where, that knowledge is definitely going to be very useful. Okay. Hopefully that answers your question. So Ram Krishna has a question, which is you want to move to dream companies like Uber, LinkedIn, PhonePe. That's fantastic. For interviews, how should you prepare? Should you learn newer concepts or multi-platform? Okay. Now, interesting. So newer concepts like Jetpack Compose or Kotlin multi-platform, these are definitely not needed to crack interviews. That's for sure. Okay. So any piece of technology, any new library or new way of development that has not existed for more than 2 years, okay, that is not going to be a deal breaker in interviews. It's as simple as that. Big companies don't use new libraries and new frameworks unless they are at least stable version for at least 1 year old like that. Nobody is using alpha beta level stuff, right? So Kotlin multi-platform today, some companies are experimenting a little bit. Jetpack Compose, some companies are early adopters of it. Nobody is going to not take you because you don't know these things. So from a job change perspective, covering these things are not essential. Okay, very, very important. Now, what type of company it is, on basis on that, it depends whether you should do lead code or whether you should do side projects. Now, say for example, a company like PhonePe, I would say doing side projects is better. For a company like Uber, doing lead code is better because companies like Uber and a lot of companies like that, which have big workforces, they do not hire for Android developers. They hire for generic SD2, SD3, these kind of roles. For that, and after you join, by chance you know Android well, they will put you on an Android project. But if you don't know Android well, they don't care. They will put you into whatever project needs current, immediately hands are needed. So companies which hire for generic SD roles, their lead code stuff, that's more important than developing your skill set. But a little smaller, mid-sized company like say Zomato, we used to hire for Android developers particularly. Even at Target, we are hiring for Android developers particularly. We are not generic hiring for any developer. So their data structure algorithm based questions are lesser, and platform specific, topic specific questions are more in the interview process. Okay. Um, So I'm going to skip a question which has come from BMW about SD2 at Google. I think I might not be the correct person to answer that question as well, and it's not very Android specific. So I'm just going to be skipping over that question. Shirshak's question is about whether people hire specifically Android only for SD, and I think I just answered that question. Is that some companies do hire for SD's generic roles, and some companies do hire for Android specific roles. And if you go and search for job offers, you will find that there are a lot of engineer, software engineer, engineer level one, level two, these kind of job offers, and there are also Android engineer kind of job offers on the market, right? So generally, the larger the company is, the more generic the role is, right? Smaller the company, the more specific the role is. If the company has 5,000, 10,000 employees, engineering employees, then it's most likely more generic. Your topical skills are not so much needed at the interview stage. Okay. Okay. Sorry. Uh, okay. Coding Cosmos. Very interesting question. And I feel like a lot of people come up with questions like this, that you're in the fourth sem and you've been doing Android in first sem. And you're worrying about Fuchsia OS and it will replace Android. So this is exactly the effect of hype marketing that it has on young minds of the industry today. Okay. When I was in my fourth sem, I think, not fourth sem, maybe at least seventh sem, that's when I first heard rumors about Fuchsia OS. Okay. That's when I heard rumors. Today, it has been 4 more years since then, and Fuchsia, apart from a demo on Google Home device, has not, come out. Now, uh, Kotlin. People say that Kotlin was a new way of development and Java would be obsolete. And they started saying this in 2016. Okay. Kotlin, Google said officially that they will, make Kotlin an official language in 2017. In 18, Google said that they will make Kotlin as the primary language for which internal libraries and everything is developed. 2019, many companies started saying that they have started to use Kotlin internally. Big companies started saying, and I think since 2000, from 2016 and 17 time to 5 years later, 2021, is when Kotlin has actually become mainstream, and in most companies, more than 50% code is written in Kotlin in Android today, right? This starting from 5 years back when Kotlin first started getting used in production-based apps, and it was completely interoperable with Java. Okay, so Fuchsia replacing Android is, I mean, this video is gonna be there on YouTube for a long, long time, and I'm gonna be putting my neck out, and I wouldn't want to come back and see this video and see me myself being proved wrong. But within the next 5 years, I don't see Fuchsia becoming more popular than Android. Replacing Android is not even getting there, but Fuchsia being like a serious contender and replacement for Android is not going to happen within the next 5 years if I take a bet. Okay. So don't get into those hypes and don't try to prepare for a future that's 5 years away. Okay. Because you don't know what's 5 years away. Prepare for the industry today. And as the industry will change, you will adapt to it. That's what everybody does. Okay. People who were hardcore Angular developers, they adapted to React, they have adapted to Vue.js. Those same people who were hardcore Angular developers might have been sometime back Backbone.js or Knockout.js developers. People adapt. It's not like Angular people have become obsolete. They have just adapted to where the industry has gone. Okay. And by the way, one more thing, and this might not sound very sweet and nice coming from me, but from first sem to fourth sem, your Android development skills definitely might have improved, but production level Android apps, I'm sure you're not have started making, because production level Android apps means having unit tests, integration tests, CI/CD pipeline working, and using dependency injection, Dagger, using RX Java, or maybe these days coroutines in place, and all of these things should be happening. Then only we should say that we are making production level apps. So I believe that just 2 years of effort, you still have a lot of gaps to fill in that space. Okay. Uh, Siddharth has asked, K. Siddharth Sai, are there opportunities for freshers to get a job as an Android developer? Obviously, why not? Lots of people get, I think Android development jobs as freshers. A lot of companies hire. Okay. Uh, by the way, even very big companies like Google kind of companies, they're also people are hired for a generic SD role. Once hired, many of them right from day one, they are made to work on Android or iOS or web or anything. Like, there's no, you know, guarantee what kind of project you'll be given. So on bigger companies. But at a startup level company, freshers are definitely hired. Like at Zomato, we used to regularly hire freshers in our Android team. And similarly, a lot of companies where my friends work, Swiggy is there, Flipkart is there, uh, Urban Company is there, Ghana.com is there. All of these companies, they hire freshers for Android development jobs. Okay. Abhishek has said weight, like weight of Android apps or my weight. Should I reduce weight, or have you are you seeing me after a long time on YouTube and you're seeing I have reduced weight? If that's yes, I'm flattered. But okay, coming on to the next question. So Himanshu has asked, is Flutter going to be used by tech giants or startups in the future? So by the way, Flutter is used by Google to create their own AdSense app. Flutter is used by Zerodha, which is a big company, to make their Kite and Coin apps, right? And Flutter is used by Alibaba to create their dashboard app. So Flutter has started to be used by some of the bigger companies. None of the very big companies have used Flutter yet for their main app, primary app. Nobody has used. Startups, many of them have started using Flutter, yes, right? Like I said, if you are mainly doing a API based and UI based project and device hardware level stuff you're not getting into too much, then Flutter is a good choice to go with, and then you can make an app using it. Okay, Dipanshu has a question which is which has more career opportunities, web development or Android development? In terms of quantity, web development just has like way more number of job opportunities than Android. It's a bigger domain, it's a bigger field. Also, web is a wide word, right? I mean, you might mean front end, you might mean back end, you might mean full stack. Combining all of those things together, web is a huge domain, right? Today in India, like including service sector, product sector, big company, small company, everything included, if we have 1.5, 1.6 lakh fresh jobs every year in the development space, I think uh, 80 to 90,000 of those would be in the web development space, right? And mobile development space jobs would be 20,000, 25,000 of them in that space. I think rest of them might be in specific like desktop app security and system administration, these kind of things. So way more number of jobs is available. That is more. But if you look at like way the number of jobs with the median salary, uh, say jobs that pay 10 lakh per annum. So the competition for a 10 lakh per annum job in Android or mobile development is going to be less than the competition for a 10 lakh per annum job in web development. That's there. And as you go a little higher in the salary bracket, like a 15 lakh per annum jobs, I don't think there are more 15 lakh per annum web jobs than there are Android jobs. I think there the numbers start getting a little closer to each other. Right. So that's about a quantity quality assessment on web development versus Android development. Pankaj has a question. Where do you think Ionic framework stands when compared to Flutter and React Native? So, by the way, Ionic, so Ionic is a little too specific, but Cordova, which is basically running web apps inside Android or iOS app containers, Cordova itself is the framework which it's a platform on which the Ionic framework is also made, and there are other ways to do it as well. Now, Cordova is actually very big, and in fact, in both Android and iOS app stores, uh, the maximum number of apps are the native apps, like the ones made in Objective-C and Swift for iOS, or the ones made in Kotlin and Java for Android. That's the native apps are maximum. The second highest number of apps, are in Cordova in both the platforms. The reason for that is that there are hundreds and thousands of apps which basically are the website of that product wrapped into a app kind of container so that locally things can be stored. Right. So Ionic actually also is a subset of that problem. I think compared to native Android development and then React Native and Flutter, I think Ionic, particularly framework specific, is going to be a little less, quite less. But it's not like it does not exist. There's sufficient amount of opportunities in that as well. Right. Could you provide a real-time tutorial for learning Android app? Jitu, you should see the last video that we published. We just published, like, go channel, like, go back a little, you would find I did a 5-hour video. It was 5 hours of me continuously coding an Instagram clone. We will do more videos like that as well. So definitely check that video out. You would love that video, I'd say. Okay. Um, okay. Um, so Sahil Tanwar has asked, not worked in Java. So if you have not worked in Java, can you start learning Android development from React Native? I would say yes, you can. Though I would want to warn you that if you're making bigger projects, then having knowledge of how the Android SDK and Java works is gonna sooner or later come and then become useful. Okay. So eventually you will have to learn either Java or Swift or both a little bit to debug some of your issues, right? Um, where to start? I think there's a free code camp series on React Native. Maybe you can just at least start from there. It's a free tutorial, and then see where it goes. I think for most people, for most things, that's what I suggest. Go to free code camp, try out the technology, see if you're able to get started, make the initial project, and then you can see there are a lot of, if there are paid courses, if there are books and all of that stuff. Okay, so the free code camp one is the thing I would suggest. It's the first place to just go and check out. Fenil has asked an interesting question: how to implement the driver routing feature in Zomato app. So that's a NP hard problem, traveling salesman problem, right? So it's not a very Android specific question, and I would be honest, I wasn't involved in the team that worked on the system. But that's kind of like how the traveling salesman problem is solved. It's a subset of that traveling salesman problem. So I think if you take a look at the traveling salesman problem, and that's something at Scalar Academy in our courses we actually do cover. So you'd probably get a taste of how these kind of algorithms are implemented. Ayushman has a question that you're in 6M, have many other projects, but no work experience. How to get internships at good startups, and what should I do? So first of all, you have to apply to a lot of places. Just a moment. Okay, so you should apply to a lot of places. And for early stage startup internships, a good place to discover some of them would be angel.co, AngelList, and you can search for some of them there. Right. That's one place. Another thing I would suggest is, get together with some friends of yours and participate in some of the online hackathons where you have to build apps and websites and all. That's also a great place where you learn to translate an idea into a project, which is kind of very useful and very helpful, right? What these interviews try to figure out as well when they ask you the questions. Okay. Raghav has a question: what happens is that sometimes that an application perfectly running on Android Studio crashes after release? This happens because of something called ProGuard and minification. So when you make a release mode of your APK, in your early days, you can set ProGuard to false or Minify enabled to false. But that's not a good strategy long term to make production ready projects because obfuscation is important. So follow the ProGuard rules and make sure that all the ProGuard rules are added in your project. That's one thing, right? And connect your app to Firebase Crashlytics so that all the crashes that happen on release, you get a stack trace of them, so you can start deploying a fix for that. Okay. Manish has a question. How can someone start out in Android development as a fresher in COVID times? And how many large projects sufficient? So I think the right. The COVID time part is probably irrelevant, right? Because the answer is sort of going to be the same whether it's because of pandemic or without the pandemic and all that. Um, so I would say, I mean, go to developer.nano.com, learn the basics, and start building some apps, and then start thinking of some projects like a to-do list manager, a scientific calculator, note-taking app, these kind of projects, and start building something like that. That would obviously be uh, a good way to learn certain skills in Android development that are needed to be able to build such projects. Okay. Uh, How many large projects? I think you should have two, three smaller projects that you have built over a week or less kind of time, and you should have maybe three, four, uh, you know, probably contributions to some projects, which are little larger in terms, or you can probably set up a group of your friends, like-minded friends, and you can set up an open source project of your own as well, and that is something that you can do. Okay, so Rishikesh asked about progressive web apps, cross-platform versus native development. Now, progressive web apps are just basically way to install your normal web application, add a shortcut to that in your home screen, and do a little bit of local cache and push notifications, but largely they are sort of powerless. Cross-platform versus native, I think I had just discussed already a little bit. The trade-offs come between cost, which is uh, you know, about having two teams for different native products, or do you have one team which develops the app for both the products? Those kind of cost calculations come into the picture, right? So based on that, we basically decide whether to go with a cross-platform or a native implementation. Mohit, hi. Okay. So my first time I saw a big open source project which gave me a very good idea about good architecture was Firefox's Android app. Right. Nowadays, Firefox has two, three apps. There is the original Firefox Android app, then there's a Firefox Focus app. I mean, you might love to see that and see that project structure, but for little younger people, it might be a little overwhelming. So somewhat on the smaller side, Force Asia has got some good Android projects. I think you can go to GSOC and see last year's Android projects and see their GitHub repos, which is a good place to find out open source projects where the architecture is also good, but not so complex that as a beginner you won't be able to understand it at all. Okay. Shopify approach. So Aditya Pahilwani has a Shopify approach, KMM for business and React Native for UI. So both are a couple of different things. KMM for business is something that a lot of companies are thinking of doing. We had started thinking of writing our menu logic in KMM. when I was in Zomato, because that was a very complex piece of logic and we had to replicate it twice. But we did not depend on a lot of Android or iOS specific stuff to do it. So we thought that we should definitely be able to, I don't know, sort of use it as a, yeah. So just a second. So yeah, and we can use it like that. Now, the UI with React Native part is something that some people decide whether you want to have a common UI effort or not. And I think it depends on the kind of team and all you have set up, and whether you want to create a common design language, and or you do have very strong UI teams on Android as well as iOS already available in your team. Now, if you have that, then you don't need to create a common effort for UI. Now, React plus KMM is good, though that means that you would need, like, for a lot of for Shopify, this I think for Shopify they would need somebody with React understanding, they would need somebody with KMM understanding, and they would need people with native Android Kotlin and native Swift understanding as well to fix certain features. So that every different technology stack that you keep adding, you need expertise in all of them. And as your apps are bigger and more complex, and they are running on lots of different devices, then native level knowledge becomes unavoidable, and it is needed because there will be certain crashes which happen in the native layer. So you'll need somebody with native Android development experience and native iOS development experience to be able to fix those bugs. For bigger companies, I think it does make sense where common implementations which can be changed quickly by changing one implementation, you are able to change the UI on both those kind of things can happen. Now, many businesses use KMM to make the logic layer common while the UIs are separate. So that's a different part of the problem to be solved, and a lot of people are already doing that. Then a lot of people are also doing this thing is that they're writing the UI in a common framework like Flutter or React Native, and then some platform specific stuff like image processing pipelines, video processing pipelines, they are writing down in native as well. Right. Uh, and that's kind of the state right now. Shopify is one of the rare examples who is doing both of those things. They're trying to make things common at the UI layer as well, and then at the bottom of the business layer as well, they're trying to make things a little bit common. Does the okay, so where did I miss the next question? Siddharth asks, does the associate Android developer certification Google benefit us while applying for Android developer jobs? I haven't seen that actually to affect a lot, to be very honest. Gives a little bit of foot through the door. Like if somebody has that associate Android developer certification, then resume shortlisting layer, it might help a little bit, especially like if your prior work experience is not in an Android development role, or you are not from a very good college. In those cases, if that certification is there, that helps a little bit. If you have already made Android projects, if you are from a tier 1 or 2 college, or if you already interned in Android development role, or worked in Android development role already, then you don't need to go for that certification. It does not add anything more to value to your profile. Okay. Good companies to aim for summer internship Android. I think that I wouldn't have right now any idea of. Mostly you should check out obviously some of your favorite apps that you use, some popular apps, and then try to reach out to the recruiters via LinkedIn and see if their internship opportunities open. Many companies do not have internship opportunities explicitly mentioned on the internet, but if you ask the recruiters and you say that you are good on Android development, you have made some projects, do you have internship opportunities, maybe somebody might say yes. Okay. What do you see in an intern for second year pass out? Second year pass out. What do you mean by second year pass out? Like if you're in second year, then you're not pass out, right? Uh, But okay, fine. I'll just say that, if you are in your third year and you want to intern, I don't know. I mean, I don't want to see a lot of skills apart from the urge to learn new things, and if it's in a startup-ish atmosphere, then being a self-starter. That for every two things, every third thing, every fourth thing, you won't come to your whoever is your internship mentor or your engineer whom you're assigned to. You don't just come and bother them. You take a piece of problem given to you and you figure things out on your own as much as possible. So that attitude you have, that's probably more important that I try to see. Okay. Vignesh has asked how to prepare for freelancing and Android development. Portfolio building is important. So go to GitHub, make projects which are finished, okay, end to end, finished, put up on the Play Store. Get your friends and family to use it. Try to get 500,000 or 1,000 downloads. Even that's fine. But put it on GitHub. GitHub should have a README of that project. It should tell what the project was about. Like, packaging is very important, which helps you build a, sort of freelance side career. For future perspective with Android, is it better to learn iOS or backend? Um, if you're not spent at least 4 or 5 years in Android, then just continue to spend time in Android itself. There's a lot of depth to it. Okay. Otherwise, decide if you really, really love uh, mobile development, right? Making mobile apps is something that you're really passionately fallen in love with. Then maybe learning iOS or Flutter or React Native, another framework, is sort of helpful. Right. But if you learn backend, then you become versatile. You can work on projects where both backend and front end are needed, and you can work on both things yourself simultaneously together. I think an Android developer who moves into backend probably adds two very large skill sets, which can give, like, career growth wise, salary wise, better opportunities. Is what I feel. There's a small question about Target offering summer Android internships or not. So just to answer that question, no, I think there isn't. Right. Um, this is just full-time people are getting hired right now. So just answering that question. Santosh has asked web development or Android development for students in 6M. If you're a student, I will give you only one advice. That is, people excel in things that they like. There's this whole concept, Japanese concept of finding, or ikigai, which is things that you are good at, things that you like, and things that you can use to make money or make a career out of. Okay, the intersection of these three things is what you should be doing, right? That's your ikigai. So you are generally good at certain things if trying to solve problems in that domain keep you up at night, sleepless nights, and you're very passionate about it. So uh, try out web development, Android development, both for 1 week each. See which one excited you. See which one is stopping you from going to sleep. Right. So that is probably very important to discover what you really like. Once you figure out what you really like, put all your energy into it. You might figure out Android is what you like. You might figure out web is what you like. You might figure out you don't like either of them and you like something else like data science or machine learning. Well, whatever. But if you spend some time figuring out what you like, that is the best investment of your time and energy. Right. And based on that, take a pick. Don't try to pick web versus Android based on which senior said this is supposed to be taken because it has more scope, or whether you look at job offers today and you pick that. If you are among the top people doing anything, you can be very successful and earn a lot of money and travel countries and all of that stuff. So don't try to optimize for, this domain has more jobs or this field pays more and all of that stuff. pick up whichever one makes you feel better, whichever one you really feel like you like, and then you will automatically be very passionate about it, automatically learn a lot of things inside it. That's going to be important. By the way, just quickly covering Arpit, you can later on see the video freelancing I just covered a little while back. XML looks different on different phones. I talked about how these days a constraint layout is used for creating proportional layout files. I think you can see that. Uh, what is easier to make? Eugene has asked wallpaper app, Android Flutter Studio, or Flutter. What is easier to make? I think wallpapers can be probably easy to make if you just use a pattern-based wallpaper or something like that, right? Okay. Hi, this is somebody from Russia was asking Granny Fox. So lots of love from India. And your English is completely perfect. um, uh, just
Sorry, I think I lost my battery for my mic a little bit. Uh, we have somebody from Nigeria as well, so quite a lot of international audience. They did completely not expect that. Hopefully, this was good enough information for you folks as well. Though I think my personal experience is more India specific that I'm able to kind of draw from and give you answers from. So I think one of the last questions I would pick up, and unless you have more questions, feel free to throw in. But I think we'll also start to slowly wrap up our session. So Parth Patel has asked how to develop skills for prod level development before getting a job. Do something prod level. I think make an app of your own, try to put it up on the Play Store, and then open source its code, and then maybe ask your friends to come and contribute. That's one of the best ways to uh, do this. uh, and I think setting up CI/CD etc. using GitHub Actions on your side projects, and doing automatic code reviews and all these kind of things you can set up, right? Those things will really help. Mm, okay. I'm an Android developer, but really Aarti Negi has asked whether she should switch to Flutter or not, and I think that if you already are a good Android developer, you have made some apps, then you can learn Flutter. Additionally, it's not called switching; it's just adding, broadening your horizons. I have learned Flutter 2 years back, although I was very successful Android developer at that time. That's just increasing your social presence, and making sure you stay in touch with latest trends. So for that, you can do that. Okay. Uh, should I know testing and CI/CD for putting my app on Google Play Store? Ayushman has asked. So yes and no. I mean, You don't need testing and CI/CD knowledge to just put the app on Play Store, but if you have gotten an app to a place where you can put it on Play Store, that level of confidence you've gotten out of building apps, then I think yes, this answers that if you set up testing, if you set up CI/CD, it will make your life a whole lot easier, and it will prepare you for production level stuff that you need to do at jobs. But it would be great if you have these skills, and then they help you publish that app much more easily as well. Your code base is always tested, and your automatically you can deploy your app to Play Store and as well, those kind of things you can do. Okay. So I don't see a lot of other questions which are extremely pertinent to our today's topic, which is about Android development. Sadly, I haven't been able to pick up some questions, and I know that I want to acknowledge that some which were not so directly related to today's topic or exactly the video that we were trying to do today. So we might not have been able to pick those comments as well. But anyway, I think I have been able to answer a lot of the questions that have come in. And if there are more such questions that people have, feel free to probably just reach out to Scalar Academy or join our Discord. We'll put the link of that in the description of this video. You can come to our Discord, and there is an Android channel where you can ask some questions. Okay, so that is something that you can do. Okay, so any other questions that's coming in? So I think I'll just wrap up at that point because some of the other questions are, I think we can take them up in comments of this video itself. Some of them are not very directly related as well, so we can definitely do that. Take them up as comments here, and like I said, you can join our Discord. If you want to send a DM or something on my Twitter or something, then that's also available. But I think one of the best places would be that you join the Scalers Discord and ask that question in the Android channel, and me or even some other people who know Android development can maybe answer those to you. Okay. So I think I will just call it a day here. I will just wrap things up here, and it was great interacting with all of you people. Very humbled to see a lot of people from outside India joining in as well in this. I don't know what kind of time zone they might be on. Thank you so much. Right, and we would love to have more such AMA sessions on different topics by more Scale instructors and mentors in the coming days. Okay. I'll take one more question. I think I'll take just one more question. And that question is, I think, about. So I think who has asked this? Abhishek Sharma has asked that I'm new to dependency injection, so should I start with Dagger or Hilt? Hilt is a wrapper over Dagger. Hilt is not separate from Dagger, so you need to know Dagger to use Hilt. Hilt is just it reduces the amount of code that you need to write with Dagger, but Hilt is built on top of Dagger. If you don't know Dagger, then you don't know how to use Hilt. Okay, so I think probably that helps with that misconception. They are not separate vaccines. So they're not separate. Programming languages. Just some vaccine related thing just popped up here. I'm just seeing vaccine pop-ups everywhere on my screen these days. Somebody is getting some vaccine, and also I hope you guys also get vaccinated if you can get book slots and everything. Just popped up somewhere there on my screen. So yeah, if you're the Dagger and Hilt are not separate frameworks. They are basically Hilt is built on top of Dagger. So yeah. So I guess okay then. Thanks everybody for the questions you guys asked. Thanks everybody who watched the video. If there are further questions, you can drop them as comments on this video, or you can come to our Discord server and you can ask them as well. Thank you for tuning in. Have a nice day, everybody. Please, stay safe. Wear masks and get vaccinated. Okay.
How to become a full stack developer in 2021. Hello everyone. Do you wish to one day become a full stack developer and work in the field of information technology? It is all about dedication and your will to pursue a career that brings you closer. And if you have set your heart to become a web developer, it is evident that you learn everything about it and start understanding it from the early stages. There are several benefits of becoming a full stack developer. Let us see some of the benefits that will attract you and motivate you to even further. First, you can work with the top web development companies that provide high salaries. Second, you can create a website and start your venture. Third, if you have coding as a habit, you will enjoy yourself. Fourth, become a web development consultant. In this video, we will walk you through everything you need to know to become a full stack developer in 2021, from the basic level to the professional level. We will include future aspects, salary expectancy, prerequisites, and education required to become a full stack developer in this video. What is a full stack development? A software stack is a group of elements in a source code that ensure that the application operates smoothly. This category includes software products, upgrades, programming tools, servers, system software, database utilities, and other items. These elements are stacked on the top of one another to permit user engagement, conduct computations, and drive back-end operations. The development of both front-end and back-end of a website or an application is called full-stack development. Front-end development and back-end development are the two different types of operations associated with the production of a web application. Front-end development is responsible for the software's client end. A front-end developer ensures that the final product is enticing and user-friendly. The server side of the software is powered by back-end programming. The back-end programmer uses the coding language to transfer information between the client and back-end servers. Understanding the roles and necessities of a full-stack developer is vital. In this session, we will focus on the roles and responsibilities that developers bear. Who is a full-stack developer? A full-stack developer is not the same as a developer who only specializes in front-end or back-end development. A full-stack developer must have skills and complete knowledge about front-end development and back-end platforms. Therefore, a strong comprehensive grasp of web applications is essential. Full-stack developers work on the front-end, back-end, web servers, SQL, and application programming interface API. Therefore, they are responsible for handling the complete software stack. Role of a full-stack developer. To become a professional full-stack developer, you will need a lot of expertise and a deep understanding of web development. Full-stack developers are incomparable assets in a team because their knowledge is integral to the website's performance. They have a fundamental understanding of design, database management, and development environments. Let us discuss all the roles and responsibilities of a full-stack developer. A full-stack developer has to procure all the requirements and specifications for the project from the stakeholders or the client. Second, divide the requirements into sections and process each information to be integrated into the web development. Third, they have to do a thorough analysis of the requirements and look for potential problems that might arise. Additionally, develop solutions beforehand to these problems. Fourth, it is the responsibility of the developer to design user relations. Fifth, before starting the website development, the foremost process is to create repositories for the data that has to be stored and then release the data onto the servers to provide access. Sixth, the developer also has to test the codes for bugs and errors constantly. And in case of any, they are responsible for resolving the issues as quickly as possible. Seventh, the codes have to be updated regularly based on software and hardware requirements. Eighth, the developers have to use a systematic process for testing to provide different solutions. Ninth, Full stack developers must be able to develop web applications that run on different platforms. This video will help both beginners and experts to understand the prerequisite you need to become a full stack developer. It has something for everyone. Let us start with the details of full stack development. Prerequisite to become a full stack developer. Do you want to be a full stack developer and a career-driven IT professional? Or are you a code lover who aspires to be a developer someday? What does that require to be a successful full stack developer? But what do you think are the qualifications and conditions that are required to become a full stack developer? In the next section of the video, we will understand the preconditions and qualifications required to become a full stack developer. The first objective was to assess your current position in your profession and the industry. According to your skills and qualifications, categorize yourself. As you progress near the objective, it will benefit you in establishing a clear roadmap. Let us see what you need to become a full stack developer. You should understand your skills. If you have a wide range of technical knowledge, the process will be simple for you. The path will be simple if you are a competent front-end and back-end programmer. However, if you have never worked as a programmer and have no expertise in managing web development projects, you will undoubtedly face numerous difficulties. If you know your skills and understand what you need to learn, you can quickly become a full stack developer. If you are a beginner in coding, you will have to learn basic programming languages and understand different tools. If you are an expert in software engineering, you can quickly learn the skills and become a stack developer. Stay with us to learn more about the development tools you need to learn about to become a full stack developer. Learning about development tools. There are several tools that you would have to learn about and understand to understand full stack development. Let's see the different tools that you need to learn about. First, text editor. A text editor allows the programmer to type, modify, and save text strings. Website development tools and operating systems include editing tools. Full stack developers use these to modify the source files of coding languages. Second, web browser. Developers use browsers to debug difficulties that arise during programming. Google Chrome and Mozilla Firefox are the most popular browsers among programmers. Third, terminal. A terminal is an effective tool that is used by a full stack engineer to increasing efficiency. It serves as a user interface for the web application which allows you to run text-based operations. Terminals do not permit you to see the program code, but they enable the developer to run commands to perform tasks. Fourth, Bootstrap. Bootstrap is a non-proprietary website development front-end tool that defines page layouts for navigating, typeface, and icons, among other things. It provides the developers with a wider collection of typefaces, palettes, and templates to choose from. The most significant benefit is that all the items are presented in the same way across all browsers. Fifth, Angular.js. Angular.js is a toolkit created by Google. It helps developers to explain the elements of the website applications clearly through HTML code and frameworks. Sixth, Python. Python is a popular language of programming for learners that supports functional modules. It also provides unique space for object-oriented programming and emphasizes the readability of the code. Seventh, JavaScript. JavaScript library is a coding language for prototyping and object orientation. It aids in the design of interactive websites for all kinds of devices. Eighth, HTML and CSS. The foundations of full stack development are CSS and HTML. You will always require CSS and HTML knowledge for front-end programming, independent of the back-end programming or structure the developers employ. Ninth, Django. Django is considered a Python-based web server programming environment. It enables practical design and fast implementation. It is a back-end utility tool that helps developers in deploying websites faster. 10th, Ember.js. Ember.js is a renowned solution for developing web-based applications among software developers. Full-stack developers use this JavaScript technology to create desktop and smartphone applications while being predominantly for the website. 11th, Lodash. Lodash is also a back-end tool that full-stack developers use. It is a fundamental programming-based JavaScript library. It assists programmers in writing manageable algorithms. 12th, React. React is regarded as a JavaScript library that Facebook maintains. It is used to create single-page websites and Android as well as iPhone applications. 13th, Package Managers. A package manager is a package that allows developers to set up programming procedures and integrate quantities of resources. It allows the developers to easily pack and release the website product along with the applications. It makes it simple for others to find the websites. You may provide the project's title, version, hashtags, and prerequisite. 14th, databases. Before the stack developers create any website, they need a storage directory to keep all the information related to the website in a single space. And there are several databases available about which the developers should know. These include NoSQL, relational database, cloud database, cache, and lightweight. The developers can use any of the databases and store essential information. Now that you know about different tools, the next part of the video will focus on the required skills. Work on your deployment skills. After you have learned about the tools, you have to learn how to publish the front end on the web. You have completed the project development and evaluated the web at this point. The only thing left is to deploy the app to a web server. A developer with the correct deployment capabilities can guarantee that no resources are wasted. The developer must know the following deployment processes. Must know how to register domain. Should be able to provide a host for the website. They should know how to set the DNS record. Must be able to set up the emailing system. Full stack developer career path. First, full stack developers tend to progress swiftly through the hierarchy, and they may discover themselves in charge of a small team at the start. According to the performance in the work, they may also be well placed onto becoming team leaders in the future. Second, full stack developers are experts in every aspect of web development, including the front end and back end. To construct websites or applications, the developer has to cooperate with other designers and developers collectively. Fourth, during the development and testing of the projects, developers will have a role in every aspect. Depending on where your profession takes you, you will strategize, program, collaborate, and multitask with others. Fifth, a full stack developer must have expert knowledge in every field. They are professionals that are multi-talented and have high analytical as well as solution finding skills. But they will have to learn about the new technologies and develop better skills constantly. Can you become a full stack developer without a degree? You don't need a professional degree to become a full stack developer. And with the help of your knowledge and skills, you can earn a lot of money because there is a high demand for developers. Indeed, the workforce for full stack developers is predicted to rise by 22% over the next 10 years, which is way faster than the predicted national average. However, you have to learn several front and back-end development processes as well as programming languages. Let us see what programming languages and tools that you have to learn about are CSS, HTML, JavaScript, SQL, Node.js, Express. Future scope and salary of full stack developers. The future for full stack developers seems to be very bright. The high demand for developers in other IT customizable jobs creates several options for both the company and the employee. Let us see some of the factors that have added to the increasing demand for the role. Full stack developers are the fresh face of website development and information technology. With their experience and knowledge, they can change the face of the web development. Second, all the developers are paid very highly. The salary ranges according to the years of experience and knowledge. Third, an average developer with experience of 1 to 4 years can earn up to 5 to 6 lakhs annually. Whereas, with experience of 5 to 9 years, they can quickly be paid 15 lakhs. Fourth, the field of web development provides adaptability and is a driving force for advancement and developing skills. So, if you are a lifelong student, look into this sector for daily growth opportunities and a brighter future. Key takeaway. There is a growing demand for full stack developers in the world of information technology. It is regarded as one of the most attractive professions that will pay you well and help you build a career for yourself. Hope you guys enjoyed the video. Please don't forget to like and share this video. For any queries, comment below and we'll get right back to you. Thank you.
With the significant amount of resources these days, it is not at all surprising that if a person gets confused on how to start or maybe even build a career in machine learning. So in this video, we'll be talking about how exactly can a person start his or her career in machine learning, what are the important skills that will give you that boost to secure a job in the field of ML, and what are some of the most average salary trends in this field. So without further delay, let us get right into it. Let us first understand what ML is. Machine learning can be defined as the science of making computers learn automatically. With machine learning, the computers can make decisions and predict outcomes without any human intervention. The whole process is achieved using algorithms which play an important role in building machine learning models which can then be applied to a variety of other applications. Keeping in mind the definition of machine learning, now let us look at what are some of the most useful skills that one can learn to land a job role in machine learning. Firstly, mathematics and statistics are an integral part of machine learning. That being said, not all the mathematical concepts are relevant to ML. Some of the most important ones that are in fact relevant to ML are linear algebra, probability distributions, and calculus. One reason as to why maths is a prerequisite for ML is that mathematics is essential for applying the algorithms correctly and testing different hypotheses. With the knowledge of maths and statistics, one can pick up intuitions and learn the ML techniques really fast and accurately. Adding one or two programming languages to your portfolio is a great way to build foundations in machine learning. There are different programming languages in the current scenario, but the most suitable ones for machine learning are Python and R. The fact that Python is a high-level language makes it easy to understand and implement. An added advantage is that Python is so popular in today's world, so you'll have answers to almost every question related to Python on the internet, because the community is that vast. R is a low-level language which does the same thing that Python does, but most of the time it is used for data analysis and exploratory work. Having ML knowledge is another key aspect in building a career in machine learning. This includes both machine learning libraries and algorithms. For example, the Python machine learning libraries are the most preferred libraries used for machine learning. They deal with anything and everything related to machine learning. Libraries are basically a set of useful functions that get rid of writing the code from scratch. This in turn helps to reduce code redundancy and saves so much time. Some of the most commonly used machine learning libraries in Python include NumPy, which is used for various math operations involving multi-dimensional arrays and matrices, Pandas, which is mainly used for data analysis, importing data from various file formats like CSV, JSON, XML, and Excel, Matplotlib, which is mainly used for data visualization and involves plotting 2D graphs of arrays, SciPy, which is used for solving scientific and mathematical problems and is built on the NumPy extension, Scikit-learn, which provides efficient tools for machine learning such as regression and classification, and lastly, Keras, which has a wide collection of deep learning models. After gaining some knowledge on machine learning libraries, it is now important to focus on some machine learning algorithms and how they work. Each algorithm has its own purpose, like for example, linear regression is used to find out the relationship between variables and predicting certain values. If you want to dive deeper into machine learning algorithms and how they are used, there are tutorial videos for which you can find the links in the description box down below. After learning all these above skills, one must put them to use by creating small projects and maybe even contributing to open source projects on GitHub. This not only improves a person's practical knowledge, but will also give a slight advantage over people who don't have projects or any contributions. Apart from these two reasons, it is a good way to showcase one's skills. Now that we've talked about how one can start a career in machine learning, let us discuss the average salary trends and some common job roles in the field of machine learning. A machine learning engineer is someone who develops programs and algorithms that hugely enable machines to act upon by themselves. A typical machine learning engineer in India earns about 7,60,000 rupees per annum, whereas the same job in the US will fetch you around $147,807 per annum. A data scientist designs algorithms and prediction models to mainly analyze the data. The average base salary for a data scientist in India is about 9 lakhs, and in the US it is 119,000 USD in a year. Principal scientist is someone who does research and comes up with innovative and impact-driven machine learning projects. The job role also involves coordinating with stakeholders and other teams. This is one of the most high-paying jobs in machine learning, and it will fetch you around 15 lakhs per annum in India and 141,000 USD per annum in the US. A data engineer is a person who is responsible for data cleaning and making it readily available for further machine learning processes. This is one of the most important jobs in machine learning due to the fact that without proper data, it is impossible to get best predictions and insights. On an average, the mean base salary of a data engineer in India is about 10 lakhs, and this amount is around $125,000 in the US. The salaries in this field hugely depend on the experience level, your skills, location, and the organization you're working for. Various skills like deep learning, artificial intelligence, data analytics, natural language processing can help you stand out since these are especially in demand. And the jobs including these skills will fetch you a lucrative salary as well. With that, we have reached the end of this video. Keeping in mind all the skills that we have discussed today, it will help you start your career in machine learning and most probably land that dream job of yours. If you have any questions related to machine learning roadmap, let us know in the comment section down below. We will be more than happy to answer them.
Have you guys ever wanted to build your dream career in artificial intelligence? Well, you are in luck because today we'll be talking about how one can land that dream job in AI. We will be discussing the skills required to start a career in AI and also the average salary trends in the field of AI. But let us first understand what AI is in a simple manner. AI is the science of imitating human behavior in computers or machines that are programmed to function and perform tasks like us humans. Any machine that exhibits or mimics human-like traits constitute AI. These days, AI is used almost everywhere, and due to this, there is a huge demand for people working in the field of AI. Let us move on to the skills required to really start a career in AI. Typically, a bachelor's degree in computer science is required, but like every other job role, if you want to excel in AI, your fundamentals needs to be strong. Firstly, basic skills like maths, which include linear algebra, statistics, and integral calculus are important. In AI, the need for maths and statistics is crucial as almost all the jobs in AI require problem solving skills. AI requires a person to be good in statistical thinking and logical reasoning. In fact, the most preferred qualification after computer science knowledge or a CS degree is statistics. Having a grip over maths and statistics helps you understand most of the machine learning algorithms as they revolve around linear algebra and probability distributions. Coming to the next important basic skill, computer science knowledge. Like we discussed earlier, a degree in computer science is required but not mandatory. Having said this, knowledge in computer science, mainly in programming languages like Python, R, and programming concepts like databases, data structures, and algorithms will take you a long way in the field of AI and almost always gives you a competitive edge over others. Apart from these, having to show that one has a clear understanding of data sources like Kaggle, data mining, and web scraping are also an added advantage. If you don't know what web scraping is, it is simply taking data from various websites and converting it into structured data, which makes it easy to analyze or derive insights out of. Now that you've learned the Python programming language, you can now explore Python libraries used for machine learning. For examples, two such commonly used libraries are NumPy, which is used for math operations on multidimensional arrays, and Pandas, which is used for data analysis or importing data from various file formats. In addition to machine learning libraries, a knowledge of machine learning algorithms can take you a long way as well. Some of the commonly used algorithms are decision trees, which is a diagram or a chart that defines a specific course of action or an outcome, and linear regressions. This is used to find out the relationship between variables and predicting certain values. Since it is linear regression, the relationship is between two variables. Another best way to showcase your practical knowledge in these concepts is to try and create a few projects on the same. This definitely will help you get recognized in a pool of ordinary applicants who do not have any projects. After having a go at basic machine learning algorithms, one can start widening their skill set by exploring another branch of AI, which is deep learning. Deep learning is a branch of AI that deals with processing and analyzing data like how a normal human brain would do it. Here, the concepts of neural networks come into picture. Neural networks are similar to that of a human brain. Each neural network has a collection of nodes which perform the functions like that of a neuron in a human brain. Depending on the purpose you want to serve, there are different types of neural networks. Three types of neural networks are artificial neural networks. An example of this is stock price prediction, convolutional neural network, which is used for image processing, and recurrent neural networks. This is used for voice search applications like Google's voice assistant and Amazon's Alexa. Apart from these technical skills, non-technical skills such as critical thinking, curious nature, creativity, and ability to stay up to date with the new technologies goes hand in hand with almost every job in AI. It requires you to not just arrive at a decision, but wants you to arrive at it using trial and error and mandatory testing. If you want to excel in AI, one must be curious and creative. Having to ask the right questions at the right time and always wanting to learn more are two key aspects that a person wanting to land a job in AI must focus on. AI aspirants must have a passion for staying up to date with every new technological development there is. Main motive behind this is to be familiar with all that is going on in the tech industry and try to come up with innovations. Now we'll look at the salary trends for some of the common jobs in AI. Firstly, there is artificial intelligence engineer. According to Glassdoor, the national average salary of an AI engineer in India is around 8,51,755 rupees, and in the US it is about 118,416 US dollars. Big data engineer. You can pursue this career if you have a liking for distributed computing. The average salary in India is around 7,49,718 rupees, and whereas this sum in the US is about 151,307 US dollars. An average machine learning engineer in India earns about 7,60,000 rupees per annum, and in the US the average salary is around 147,855 US dollars. A data scientist is one of the most searched roles, and it can fetch you close to 9 lakhs per annum in India and around $119,414 in the US. On an average, a deep learning engineer in India earns about 8 lakhs per annum, and the same job role will fetch you about $136,307 in the US. To conclude, always keep in mind that the more you learn, the higher the chance there is to grow professionally. And especially since AI being a vast technology, it is paving way to new and trendy innovations, and thus one has to keep up with the moving trends.
Hey guys, my name is Lakshay and I am a research analyst at Scalar Academy, and I am an ethical hacker aspirant. So today I am here to share my knowledge about how to become an ethical hacker and what are the steps you can take to become an ethical hacker. So let's start off with some basic introduction. So defensive and offensive cybersecurity pursuits have been described using terms such as white hat hacker and black hat hackers. So these nicknames were used to distinguish the good guys from the bad guys. While both these terms are still commonly used, at least one of them may not be adequately descriptive of the various roles found in today's modern cybersecurity ecosystem. Although a black hat hacker is still just a bad guy, the good guys are now better described using expressions such as ethical hacker and penetration testers. Now, so before we begin the session, make sure you subscribe to our channel and hit that bell icon for further notifications. And I have a question for you guys. like how I'm making how to become ethical hacker right now, you must be wondering how to do your job role or how to become a different job role, such as data scientist or machine learning architect, something like that. So do let us know in the comment section what do you want to become and how to make video on that and on which video we should work on next, right? So let's start off with the session. Now let's say today's agenda first of all. So starting with, I'm going to explain who is an ethical hacker and what are his job roles and how does he work in a company. After that, skills required to become an ethical hacker. So what are the skills you need to become ethical hackers, soft skills and technical skills both. After that, I'm going to tell you the certifications through which you can become an ethical hacker. Different type of certifications starting from beginner level to advanced level. And finally, the most interesting part, how much a ethical hacker earn on a daily basis or on a monthly basis. So let's start with our first topic. Who is an ethical hacker? So an ethical hacker, also referred to as a white hat hacker, is an information security, or we call it as infosec, expert who penetrates a computer system network, application or other computing resources on behalf of its owners and with their authorization. But organizations call on ethical hackers to uncover potential security vulnerabilities that malicious hackers could exploit. The purpose of ethical hacking is to evaluate the security of any organization and identify vulnerabilities in target systems, networks, or system infrastructure. The process entails finding and attempting to exploit vulnerabilities to determine whether unauthorized access or other malicious activities are possible or not. So an ethical hacker is given wide latitude by an organization to legitimately and repeatedly attempt to breach its computing infrastructure. This involves exploiting known attack vectors to test resilience of an organization infrastructure posture. So that's how an ethical hacker works and what is ethical hacking. Okay. After this, let's move on to skills required for an ethical hacker. So first of all, before skills, I want to tell you guys that bachelor's degree in computer science or information technology or any related field is a must to begin your career. After that, let's move on to soft skills. The first one is problem solving skills. It is to determine the source of a problem and find an effective solution. Apart from technical skills, an ethical hacker must also be a critical thinker and dynamic programming solver. They must be wanting to learn new ways to ensure all security breaches are thoroughly checked. This requires tons of testing and ingenious penchant to devise new ways to solve any problems. The next one we have is analytical thinking. Hacking requires a creative and very analytical mind. Ethical hackers need to be able to reverse engineer security frameworks, come up with new ways to break into a network and something like that. This also requires thinking outside the box. Like social engineering is a common technique for both white hat and black hat hackers. It uses psychological techniques to gain access into restricted areas as well. The next soft skill that we have is communication. So communication skills are very important in just about any profession that we go in this world, right? And ethical hacking is no exception. You may need to present technical security information to a variety of stakeholders, answer non-technical questions, or you can just translate the technical knowledge into business value or develop or write policies and build strong professional relationship with your CEOs or your managers. You may also need to take a role in security advocate, that means promoting security practices to diverse audiences. So all these activities combined require verbal and written communication. So that's how important communication is. Next, and the most important we have is teamwork. Solving security problems does not happen in vacuum, nor do they have all the answers, right? You are often working in a team, collaborating with peers or other stakeholders and seeking other people's expertise to find solutions. So because of this, you need to learn how to build consequences as well as cultivate relationships between different teams and how do you work and how do you approach using those teams. So part of the ability to collaborate and work as a team comes from being an excellent communicator and problem solver. But you also need good people skills, an open-minded attitude, and patience among other things as well. So these are the soft skills that makes a ethical hacker a good ethical hacker. After that, I have some technical skills. The first one is computer networking skills. So this is one of the most important skills to become an ethical hacker. The computer network is nothing but the interconnection of multiple devices. Generally, we term them as hosts, and they are connected using multiple paths to send or receive data or media. So understanding networks like DHCP, supernetting, subnetting, and many more will provide ethical hackers to explore the various interconnected computers in a network and some potential security threats that this might create, as well as how to handle those threats. So next we have computer skills or handling computers or operating systems. So knowledge about computers and ability to which allow to use computers or related technology is very important. So typically basic computer skills include data processing, managing computer files, and creating presentations. Advanced computer skills include managing databases, programming, and running calculations in spreadsheets. So some of the most computer essential skills are MS Office, spreadsheets, email, database, social media, enterprise systems, and many more. So an ethical hacker need to be a computer system expert, and he should know about all operating systems like Windows 7, Linux, Mac, Kali Linux, all the operating systems that exist. And apart from that, Linux, he should be very good at Linux. So Linux is a community of open source Unix-like operating system that is based on Linux kernel. It's a free and open source operating system, and the source code can be modified and distributed to anyone. Either it can be commercially or non-commercially. The main reason to learn Linux for an ethical hacker is, in terms of security, Linux is more secure than any other operating system. It does not mean that Linux is 100% secure, but it has some malware for it, but is very less vulnerable than other operating systems. So it does not require any antivirus software as well. After this, ethical hackers should also need to learn programming. So it's an important skill for ethical hacker. So what does the word programming in computer world actually mean? It means the act of writing code understood by a computational device to perform various instructions, right? So to get better at programming, he has to write a lot of code. Before he can write a code, he has to choose which programming language is best for him. So we have some programming languages that ethical hackers should know, like SQL, C, C++, Java, JavaScript. I'm not saying he has to be an expert in it, but he should know how to do it. Suppose you are hacking into a website and you don't know how a SQL works or how a database works. So how are you going to hack it? So that's why knowledge about everything should be important for an ethical hacker. So finally, I have social engineering. So social engineering is a process of convincing people to disclose confidential information. It depends on the fact that people are unaware of their valuable information and are careless about protecting it. So before performing a social engineering attack, an attacker gathers information about target organizations from various resources such as its official website or maybe employee's ID, from his name, email address, and whatnot. There are many ways to gather information. So after this information gathering, the attacker executes social engineering attacks using different approaches like piggybacking or reverse social engineering and techniques like that. So after that, let me tell you what job roles do you have in ethical hacking. So first of all, we have security architect. He designs, build and implement computer security network for an organization. So he also holds the responsibility of building up complex security structures and ensure its effective functioning. Next, we have security consultant. So a security consultant is also an cybersecurity expert. So they are responsible for identifying cybersecurity risk, problems, and they come up with solutions. How can we solve these problems? They guide ways to protect physical capital and data. The next one we have is Chief Information Security Officer or CISO. He is considered as most powerful in the respective department. CISOs are responsible for building security teams, overseeing all activities related to the security of an organization, and he directly reports to the CEO or in charge person. After that, we have Computer Systems Engineer. So he is a professional who updates, modifies, he can install, test software or programs and hardware devices in a computer system. He is also involved in designing and planning data communication systems for computer networks such as LAN, WAN, MAN, intranets and WAN, something like that. After that, like how I described these four, responsibilities are all the same, but we have Information Security Analyst, Penetration Tester and Chief Information Security Officer. The same thing that we have just now, they all have the same responsibilities but with a different name. After this, let me get into the certifications. How can you go into ethical hacking and how can you do certifications? So first of all, I have CH. You guys must have heard about CH, that is Certified Ethical Hacker. So this certification teaches you how to think and act like a hacker. So topics in these certifications cover hacking technologies, the latest vulnerabilities, information security laws and standards. Students are put through real-time scenarios, exposed to hacking techniques, and finally taught how to scan, hack, and protect their system at the same time. This course benefits security professionals, site administrators, and anyone concerned with network security. So, after doing this certification, you will have an edge towards penetration testing jobs as well. The next certification that I have for you guys is CompTIA Security. It's a general level certification for those who are new to cyber technology or cyber security. It requires 2 years to complete it. It covers the IT concepts like network threats, defense techniques, effective security policies, network and host based security practices, disaster recovery, encryption and decryption, and all their standards and products. After that, we have CCSP, that is Certified Cloud Security Professional. So it's a traditional IT security protocol do not work in cloud environment, right? So this certification gives IT professionals who want to work in cloud computing a deep understanding of cloud architecture, its design, operations and services. So it needs 5 years of prior experience before we do the certification, experience in any IT industry. This certification covers domains like cloud architecture, design, data, security, cloud platform, IaaS, PaaS, SaaS, legal and compliance, and all topics like that. After that, I have ECSA, that is EC Council Certified Security Analyst. This certification is similar to CH certification. This certification gives you an understanding of hacking tools and the latest technologies. This certification is suitable for network server administrator, information security testers, firewall administrators, risk assessment professionals, and many more. After you know how to start with ethical hacking, you should know how to continue with it. So for this, I have advanced certifications. First, I have CISSP. Many IT organizations consider this certification as an essential requirement for network security. It is a vendor independent certification and can be applied to a wide variety of setups. This certification requires prior experience of 3 to 5 years, and once completed, it is one of the best knowledge assets you can have. So this covers domains like access control, cryptography, telecommunications, networking and whatnot. After that, I have CHFI, that is Computer Hacking Forensic Investigator. So this is an advanced cybersecurity certification for forensic network security investigators. It enables you to gather the necessary evidence and prosecute offenders in a court of law. The hacking forensic investigator is responsible for analyzing attacks, extracting information, and report hacking crimes and conduct audits to prevent future crimes. This certification covers incident response and forensics, recovering deleted, encrypted, or damaged file information, technical examination and analysis, and finally reporting of computer-based evidence. Next we have CRISC, that is Certified in Risk and Information Security Systems, that is Certified in Risk and Information Security Control. So it's an enterprise risk management qualification for professionals looking for extending their knowledge and experience of IT, business risk, identification and implementation of business systems control. CRISC is one of the first certifications which help to improve IT professionals for real world threats. It adds a higher value to employers and clients in risk assessment and management, fosters continuous of knowledge and up-to-date information. The next certification I have is very famous, that is CISA, Certified Information Systems Auditor. This certification focuses only on information auditing. CISA certified professionals have good audit experience and can manage vulnerabilities. It too requires 5 years of prior experience as well. Students gain expertise in domains like information systems auditing, IT management and governance, and protecting information assets. So after I am done with all the certifications, let me tell you what is the salary that you get after these certifications. So I have divided it into India and USA. So first I'm going to tell in India, for beginners, it's 3.5 to 5 lakhs per annum when you start with any certification and you complete it. After that, when you get experience from 5 years to 10 years, you get 15 lakhs per annum to 25 lakhs per annum. While in USA, when you start with these certifications and you complete it, your salary is $80,000 to 90,000 US dollars per annum basis. After you get experience of 5 years to 10 years, your salary will become $120,000 to $130,000 after you get experience. So that's it about this session, guys. If you have any questions regarding this, put them in the comment section below and let me know what else do you know about ethical hacking and what do you want to know. That's it from my side, guys. Thank you.
Hi, we are back with another video on the topic how to become a cloud architect. Before we deep dive, please make sure you subscribe to Scaler's YouTube channel and don't forget to turn on the bell notification icon. If you have any doubts, feel free to drop a comment below. How to become a cloud architect? Have you ever wondered what cloud engineering is or how to become a cloud architect? Cloud computing is a rapidly rising trending technology. When any technology snowballs, it comes with several job opportunities for people skilled in it. In today's session, we will tell you what works under the hood. Here is everything you need to know to become a cloud architect. Before we go any further, we would like to address the agenda for this video. We will explore what is a cloud architect, what are the prerequisites to become one, what are the cloud architecture career paths, can you become a cloud architect without a degree, and what is the scope and salary range for a cloud architect. Let's understand what exactly is a cloud architect. A cloud architect is an IT professional who is solely responsible for developing a company's computing strategy. These strategies incorporate cloud adoption plans, cloud application designers, and cloud management and monitoring. In simple words, cloud architects are professionals who are responsible for creating blueprints of application designs. As it is an extensive area, these professionals must possess advanced technical and designing skills to identify bottlenecks and suggest solutions without disturbing the entire system. Now that you know who a cloud architect is, it's time for us to introduce you to the prerequisite to become one. We will help you explore the key pillars of cloud computing architecture so that you do not encounter any roadblocks on your journey to becoming a cloud architect. Before understanding the different skills required to succeed as a cloud architect, let us look at cloud architecture's 4 core fundamentals or pillars. When cloud architects build a company's cloud environment, they work with 4 primary concepts: cloud infrastructure, cloud service model, cloud delivery model, and cloud deployment model. Now that we have got a basic understanding of the fundamentals of cloud computing, let's explore each of these concepts in detail. First, cloud infrastructure. The services run on cloud infrastructure, which includes storage, servers, and networking equipment. It covers components necessary for cloud computing, such as network resources, hardware, and abstracted resources. Second, cloud delivery model. The cloud-based services delivery might comprise a front-end platform and a back-end platform. In some cases, front-end systems access the cloud environment using the internet or a VPN link, whereas the back-end has the pooled cloud infrastructure data, resources, and applications. Third, cloud service model. If you are interested in learning all the types of services most familiar with cloud technologies, let's look at some of the most popular examples. Infrastructure as a service, IaaS. IaaS, or infrastructure as a service, offers the computing architecture and infrastructure of all the computing resources in a virtual format so that multiple users can access them. These resources include data storage, virtualization, servers, and networking that can be requested programmatically using a REST-based application programming interface API. Amazon Web Services is the most famous example of IaaS. Coming forward to Platform as a Service, PaaS. PaaS, or Platform as a Service, is mainly a development environment consisting of a programming language, execution environment, an operating system, a web server, and a database. In case of the heavy burden of various tasks such as operating system maintenance and middleware management, a PaaS service comes in handy. Third, software as a service, SaaS. We believe most of you must have heard this term even before it was popularized. SaaS, or software as a service, is a service that offers on-demand per use of application software to users. The consumer has no or minimal control over the software service. It's an independent platform that you don't need to install on your PCs. SaaS cloud computing is comparatively inexpensive. It includes Facebook, Gmail, Instagram, and cloud storage services such as Dropbox in the consumer world. Cloud deployment model. Now that you have got an essential understanding of various cloud-based services, let's examine the various deployment models. If you're from the IT industry or planning to step into it, you must be familiar with private cloud, hybrid cloud, public cloud, and multi-cloud. We will discuss each one in detail. First, private cloud. The cloud infrastructure is provisioned for exclusive use by a single organization comprising multiple customers. For clarity, the most common example of a private cloud is banks. It may be owned, managed, and operated by the organization or a third party, and it may exist on or off premises. Second, public cloud. As the name suggests, the cloud infrastructure is provisional for open use by the general public. It may be owned, managed, and operated by a business, academic, or government organization. Moreover, it exists on the premises of the cloud. Third, hybrid cloud. The hybrid cloud infrastructure is a composition of two or more cloud infrastructures, including private and public clouds. It includes the advantages of both public and private clouds. Fourth, multi-cloud. In simple words, the use of services from multiple cloud providers is called a multi-cloud. The most common examples are mission security requirements, policy, and compliance considerations. Moving on, let's talk about the skills required by cloud architects and other prerequisites. First, we will discuss the essential hard skills, and later we will move to soft skills that play a significant role. So let's get started. Fundamentals of cloud computing. Hands-on experience in the various programming languages including SQL, Python, XML with Java programming, and .NET frameworks is crucial when you are starting out. If you are looking to build up cloud programming skills, Python is an excellent language to kickstart your journey, as it is a high-level language and is easy to grasp. Along with all the commonly known benefits, Python helps to declutter large chunks of data with utmost ease. Additionally, XML with Java programming will help you with data description. On the other hand, .NET is the most preferred framework, especially for Azure developers. Today, knowledge of operating systems is an essential technical skill that is gaining much importance. Having a sound knowledge of operating systems such as Linux keeps you 10 steps ahead of your competitors. Employers are on the hunt for professionals who have a solid understanding of Linux. It brings open source advantages, easy customization, and security features, and has been adopted by various cloud platforms. Communication skills. Designing great architecture doesn't mean a thing if you fail to explain your vision to software developers, managers, and fellow architects. You must master communication skills to articulate your ideas via emails, documents, and presentations in a way that convinces your team why your solution is the best. Work on your communication skills, improve your presentation skills, and learn it concisely. Reflect your ideas and explain your vision in the least time possible. You can choose to focus on using diagramming tools to show complex environments. Other soft skills. In addition to the hard skills and communication skills we mentioned earlier, soft skills set influential cloud architects apart. While hard skills are the base of any technical job, soft skills allow you to stand out from the crowd. Though we won't be discussing each of them in much detail, we will run through the essential ones including problem-solving skills, domain knowledge, time management, teamwork, adaptability, and sixth, leadership. At this stage, we have discussed some of the most popular machine learning concepts and prerequisite essential for every cloud architect's career. Now that you are well aware of the various tools and skills, let's analyze the different career paths that can be formed using these skill sets. Being a cloud architect comes with significant responsibilities, as it requires a fine balance between art and deep technical knowledge in the cloud. Well, you will not be drawing buildings or bridges as a cloud architect. Let's understand a few possible paths that could lead you to a rewarding, high-paying career in cloud computing architecture. Get your degree. One of the essential requirements to become, or at least to want to become a cloud architect, is to have a bachelor's degree, preferably in a science background. As a cloud architect, you will need to deal with hardships every day. And the best way to get started is by receiving a formal undergraduate degree from a reputable university. The undergraduate degree will prepare you for the upcoming challenges, build your technical skills, and inculcate soft skills such as communication and leadership skills. Second, get on the job experience. Once you are done with your undergraduate degree, it does not guarantee you a job. A cloud architect isn't an entry-level position. Instead, these roles come with a high level of expertise and immense dedication. Before kickstarting your career as a cloud architect, you must have good IT experience as the field requires strong technical skills, leadership, and team handling skills. Third, get certified. A cloud architect is not just about completing a degree course or getting experience. In fact, it is about boosting your existing skills and learning something new through online courses. There are many multiple certification courses offered by world-class platforms that transform your learning procedure and validate you for your hard work, design, network, storage, and security. If you're looking for the best certification courses to enhance your skills, go for these popular ones. Solution Architect Associate Certification by AWS, Azure Architect Certification by Microsoft, Google Cloud Platform Cloud Architect Certification, Microsoft Certified Solutions Expert MCSE in Cloud Art Platform and Infrastructure Salesforce certifications, Cloud Solution Architects V2 certified by IBM, or Oracle Cloud Infrastructure Architect Associate certification. Then CompTIA Cloud Essentials, System Administrator in Red Hat OpenStack certified by Red Hat. Then VMware Certified Professional 6 Data Center Virtualization Exam. Apart from enrolling in these certification courses, you must engage yourself in reading, analyzing, practicing, and implementing various concepts that will help you give the much needed push, intelligence, and guarantee of achieving success. Wait, what if you do not have a degree? Isn't not having a degree the end of your career choices? Well, you must be thinking that a degree plays a significant role in chasing your dreams, without which it's next to impossible to become a compelling cloud architect. If you ask us, we partly agree with you. It's a fact that a degree is a crucial aspect to build and shape your career well, but it's not the only thing in the world to need to chase your dreams. Want to know why and how? Stay tuned to learn how to become a cloud architect without a degree. Taking on and completing a full-blown formal degree is a massive decision in which you cannot blindly invest without analyzing the circumstances and repercussions. About 5 to 10 years ago, a degree was everything you needed to embark on a successful career path. But today, having a college degree is further down the list. In contrast, employers are looking for people with certifications. Cloud computing is a complex area that requires domain-specific skills that you would never pick up in college. However, if you get focused training and certifications, you're more likely to be widely accepted and selected in the world's largest enterprises that are always on the hunt for talented professionals with certifications and relevant credentials in such specified fields. Let's discuss a cloud architect's career scope and salary. As mentioned earlier, the world's biggest companies are searching for emerging talent to build their career as a cloud architect. Cloud computing is associated with the Internet of Things IoT and data virtualization. Advancements such as modular software development are rapidly changing the face of cloud architecture, allowing professionals access to remote jobs in a number of industries including fintech, healthcare, insurance, education, automotive, real estate, and travel and hospitality. Cloud computing. Architecture is a complex domain that is exponentially growing with the rise in demand. So if you are thinking of building a great career in it, we will suggest taking your best shot with this trending choice. You never know when you will get a call from Microsoft, Google, or Facebook. When it comes to the monetary value, cloud architects often hold senior positions in the company and earn over six-figure salaries. On average, a senior cloud architect's salary is around INR 25 lakh per annum in India, and a technical cloud architect's salary is around INR 24 lakh per annum. Hope you guys enjoyed the video on how to become a cloud architect. Please don't forget to like and share this video. For any queries, comment below and we will get right back to you. Thank you.
According to Harvard Business Review, data scientist was named the sexiest job of the 21st century. Such is the impact for the newfound love of data in today's world. That being said, what does a data scientist do? What are the key skills one must possess to start a career in data science? What are the average base salary trends in the field of data science? We will be answering all of those questions in this video, but before moving further with what a data scientist does, like, share and subscribe for more such amazing content. What work does a data scientist do? Firstly, let us understand data science in a simple manner. Data science is the idea of using algorithms, processes, and systems to uncover hidden patterns from the data, which is at hand. An example of this would be discovering customer shopping habits using their previous shopping experiences data. Now, to achieve data science, data scientists are a vital part of the process. A typical data scientist's role includes combining mathematics, statistics, and computer science knowledge. Data scientists extract the data which is available, interpret and analyze it, and share the insights with the respective groups. Working as a data scientist needs you to be equipped with technical skills such as programming, data visualization, machine learning methods, and social science skills like maths, statistics, communication, and business knowledge. Let us now discuss these skills in brief. Firstly, let us discuss about maths and statistics. This is no surprise, but every good data scientist has a strong building foundation on both maths and statistics. Statistical concepts like probability, mean, median, variance, distributions, and standard deviations play quite an important role in shaping yourself as a data scientist. And mathematical concepts like linear algebra and calculus are also key as they are used by most machine learning algorithms. With a strong background in statistics and maths, we can say that you are on the right track to become a data scientist. Programming concepts. To go from a drawing board to actually creating real-world applications require a data scientist to be strong in at least one of the programming languages. Two commonly used programming languages for data science are Python, which is a high-level language, and R, which is a low-level language. Apart from these languages, one has to have a basic understanding of programming concepts like databases, data structures, algorithms, object oriented programming concepts, and functions. If you want to learn more about these programming languages such as Python and R, there are in depth videos on those for which the links will be provided in the description box down below. Data visualization can be referred to as one of the key components required to become a data scientist, and also it includes the most fun part as well. Since the whole of data science revolves around data, it is important to transform that data into a format that is easy to interpret and understand. As a data scientist, you must be able to achieve this with the help of data visualization tools such as Power BI, Tableau, and the simplest of them all, Excel. With the help of these tools, one can create interactive visualizations or dashboards to convey the insights. Now that we've talked about data visualization, a data scientist also needs to have strong verbal communication skills, as most of the work includes communicating with stakeholders, company executives, and different departments. You want to be able to ask the right questions to the stakeholders and adapt to their needs. Emphasize more on the 5 W's, the what's, the why's, the when's, the where's and who's, and one H, which is the how. Keep in mind that communication is also one of the most important skills required to become a successful data scientist. Machine learning concepts. We can say that data science can also be achieved without machine learning, but a basic knowledge of some of the most commonly used algorithms can take you a long way. Since a large number of data scientists are not proficient in this area, one can easily make a difference or stand out from the other data scientists with the knowledge of ML techniques such as regressions, decision trees, and neural networks. Each of these techniques can be used for various applications in the field of data science. Now coming to business knowledge. It is true that data scientists require a level of business knowledge to effectively use the available data to derive meaningful conclusions. Firstly, one has to understand the objectives and goals of the business, connect with all the stakeholders to get a better understanding of the problem at hand, and be able to create solutions to reach certain expectations. There are a variety of roles that you can choose from in the field of data science. Each of these roles have a different job that needs to be done. A data scientist is someone who designs algorithms and predictive models to analyze the data. The average base salary for a data scientist in India is about 9 lakhs, and when it comes to US it is around 119,000 USD per annum. Data analysts usually deal with identifying the patterns and relationships from the large data sets to obtain meaningful insights. A mid-level data analyst earns somewhere between 6 lakhs to 8 lakhs per annum in India, and this amount in the US is about 67,000 USD, according to Indeed.com. Business analyst's job involves prediction of a particular business's performance in the future with the help of the available knowledge and the past performances. Average base salary in India is 6 lakhs, and in the US it's 74,000 USD per annum. Data engineers take care of the data preparation part, which involves data cleaning and data organizing from various sources and make it available all at a single storage called the data warehouses. In a year, the mean base salary for a data engineer in India is about 10 lakhs and 125,000 USD in the US. Note, since this is just the basic salary, the actual sum is even more. Like we discussed earlier, each of these job roles are different and they involve different responsibilities to be taken care of. For example, data scientists develop algorithms for data modeling, where the data analysts identify patterns and trends by examining the datasets. Since data scientists require more technical knowledge when compared to that of a data analyst, it is considered to be more of a senior role. Additionally, data scientists often move to senior roles, which means more pay as and when they get experience. So there is definitely a better chance for career growth in this vast field. And that brings us to the end of this video. By learning the skills which we discussed today, one can start your career in data science and land that job which they have always dreamed of. With that, I bid goodbye and keep learning.
Hi everyone, I'm Ramit. I'm currently a lead data scientist at ShareChat. Just recently joined after completing
a technical lead stint at Tower Research for the past 3 years. And along with that, I've been fortunate to work with Professor Rajiv, who we have on this call with us today. He's a professor at IIIT Delhi. Before that, he's completed a PhD in National University of Singapore, and he's also the director and founder of the Midas Lab at IIIT Delhi, which has been basically the source which has led to all of everything that I've learned in research in the last 3 years. So, in a way, my guru is here for this call, and today with him we'll be going briefly over some of the very commonly asked questions that we've been getting from the last 1 month around machine learning, data science careers, artificial intelligence, what is next in research, all of these kind of questions. We have our expert to help answer with these. And before we begin with some of these audience questions, we'd like to start by getting a little bit more about Professor Rajiv. So, Professor Rajiv, if you could give a brief introduction on how you started, what has your journey been, and how you've got to the place where you're a director at the Midas Lab, publishing so many great papers.
Thank you so much, Ramit, and it is my pleasure and honor to be here. And thank you for inviting me for this talk. And I hope I can answer some of the questions from the different students and somehow help them in their career, or probably could be a kind of torch bearer for them. And in our life, I mean, there is always some torch bearer who show us the direction. So in my life as well, there are many. And so whatever I'm today, yeah, definitely due to the help and probably the direction that they have shown. So regarding my journey, so I am from Banaras, and I've done my schooling from Banaras itself. And after the schooling, I moved for my undergraduate study to Banaras Hindu University, majoring in mathematics. So I did my basically undergraduation in mathematics honors. So during my undergraduation, basically there was a course on programming. So that is deals with how you can basically do some small programming. So my interaction with the programming and computer science started there during my BSc. So though computer science association started there, I was not so much into the computer science because I was basically too much into the mathematics. I like the theory of computation, all these courses. I wanted to pursue basically my research, not I would say research, I would say the career. Again, the research is something which started very late after that. So since I was from a kind of humble background, so though I wanted to do higher studies, but I have realized it's better to probably look for the career which can also give you good job profile. And during that time, my elder brother basically was doing his BTech from MNNIT Allahabad. So that is very well known, at least in the area of computer science, electronics, and all those. So during the summer break, I visited the campus, and I really liked the environment, and probably also heard about so how the different students getting placed to the top companies. And also, so at that time I was only looking for the job opportunity, or probably the career which can help me in at least getting good direction, and probably probably give me a high paying job. So I was only aiming for high paying job, or at least some job profile in computer science. And that's how I got to know, so after my BSc honors, I can enter formally in computer science program through a program called MCA, Master in Computer Application. And that's how I given the entrance examination in different universities across the India. And fortunately, I was able to secure places in almost all the places. And finally, I've decided to choose Jawaharlal Nehru University for my master's. So it was amazing journey at JNU. For my master's, I learned and gone through all the fundamental courses of the computer science, starting from probability statistics to linear algebra to any algorithm and programming and data science, not data science, data structure, operating system, and all those. So that is formally has given me 3 years education in computer science. And since we are located in Delhi, we also attract a number of good companies. And after my MCA, I got placed to a company called Erisent Communication, so in Gurgaon. So that's how I moved to software industry after my master's. And since somewhere in my mind, I wanted to pursue higher studies, but during my early days, I have seen, at least I have struggled in terms of money, in terms of facilities. So I really wanted to go for job. So I started my job at Edison Technology as a software engineer, and but after working for a year, I would say approximately 1.5 years, I have realized that so probably software industry is not the best place for me, at least at that moment, because actually that was the time when the recession enters in India. So that is 2005, when I mean a lot of things is happening globally in terms of recession. So
Right.
I have seen. So despite, I mean, I was doing well. I was. It was a good job. It was very good learning profile. But one thing I've realized that like the amount of effort and work I am doing, I'm not probably getting the outcome for that. And it's basically more 9 to 5 job, and probably there is not much to learn, because when we were in, I mean, usually at least in me, when I was in my masters, I've gone through, I mean, very competitive programming, all those programming. And but once you come into the company, I mean, during the study, you study linked list, you list
Yeah.
very complex program. But once you reach to the companies, my experience was very, very different. I mean, you have given a programming stack, and now you need to just focus on some part, and
Mm.
don't have to probably mess that up. So at least the learning experience which I was getting, I was not very much satisfied. So I consulted my brother. So fortunately, my family and brothers are very, very supportive, and they said, okay, so if you don't like, I mean, it's fine. I mean, whatever our past was, but at least both of us are kind of in good position to support you in case you want to go for higher studies. So they have motivated me to basically, okay, so you can, if you want, go for higher studies. And that's how after 1.5 years, I left my job around October 2009. So at that time, I did not have any clue how to go for higher studies, because I have completed Master of Computer Application, which is treated more as a application.
Mm.
I would say the degree, it's kind of towards more, not towards well known for the research, I would say. And in fact, that is true as well, because we have not taught, and we were not doing any research as part of the course. It's more like towards the computer science applications. So I spoke to a number of people, what can be done. So one of my seniors from JNU basically just got admitted to National University of Singapore for his PhD. And I spoke to him, I spoke to a number of people as well. Okay, so, and I thought, okay, so let me apply to the different places where I can probably do research. I can enjoy at least what I have probably envisioned earlier. So that's how I left my job. I did not had anything in my hand, in no offer or so. So after exploring a number of places, I found, okay, so what are the places where basically you can apply for PhD? So in India, I have looked for ISC. Okay, I look for TIFR, Tata Institute of Fundamental Research, and I found that, okay, so these are amazing places, even IITs, where basically you can go for higher studies. So okay, so these are the places I thought, okay, I can apply. So I have given again. I basically, since I've taken break in October, I have basically prepared for GATE, because that is the way you can go for, at least go for master's program or the PhD program in India. So that is, I in one direction I started looking for that opportunity. In parallel, I have started applying for PhD abroad as well, because I mean, one thing definitely, I mean, I wanted to pursue research, but at the same time, I would like to explore the world as well. Because usually I travel, I like traveling. So when I spoke to a number of people, I found that, okay, so during PhD is also something, it's not only do research, but also get opportunity to visit different places and all those. So keeping this in mind, I apply different places. And unfortunately, I mean, I have got selected to the written exams in some of the places, but could not qualify, I would say, the final entrance. For example, for TFR, I cleared the written, but I could not finally clear the uh, basically the interviews part. So, but that's how, I mean, it was kind of disheartening. But at the same time, since I have decided I have to go, there is no way I want to come back to industry again, at least not very soon. So I decided, okay, let's go for GATE as well. So through the GATE, I mean, I prepared for 2-3 months by myself and given the GATE exam in February, I think. Yeah, February 2010. And that's how, I mean, fortunately, I was able to secure good ranks and got a couple of offers for my MTech, because some of my seniors basically suggested, since MCA is not treated more as a research oriented program, So it's better to basically go for MTech, which is well known in not only in India but also abroad, which can help you in giving the good PhD offers. And that really worked for me. I took admission to DTU, Delhi Technological University, which is formerly known as Delhi College of Engineering, and that has basically started giving me more confidence. I started interacting with more people, started doing little bit research in information retrieval. So that is at that time, I mean, I recall one of the first challenge I have participated in, SMS based FAQ retrieval. So where the input is just an SMS, which is not, I would say, complete sentence, a word where you use the abbreviation. So that's how I started my journey in basically the information retrieval direction, and that has also finally yielded into one of the paper at the FIRE conference, for Forum for Information Retrieval, and I have attended my first conference at IT Bombay, and that has given me further confidence and also basically the motivation to pursue further. As I mentioned, in your life, there will be always a number of people who motivate you and support you during this journey as well. A number of people and my professor and colleagues, friends supported me throughout this. And after this paper, I have also, since I have already started applying for different PhD position at different universities, during my master itself, I have started applying to some of the places. And fortunately, I got PhD positions, PhD position from National University of Singapore, and that's basically was a great news for me. And after that, I did not sit in the placement because I never wanted to go into industry, at least not very soon. So I got my PhD offer in between the masters during my MTech at DTU, and I did not sit in the placements, and I joined PhD program at NUS Singapore. And after reaching there, one thing I realized, I mean, definitely why universities, despite Singapore is very, very small as compared to India, but they have many world-class universities like NUS, NTU, and recently they started SUTD and SMU, which are also doing equally very, very well. So the reason being they are excelling in the research because they do understand we need to provide all the facility, all the infrastructure to the students, and definitely, I mean, they also need to probably have the world class facility, resources, teachers, and everything. So I really struggled in the first semester because it was a transition for me where I have studied. I'm not criticizing like the courses or rigorness in Indian institutes, at least where I have studied, but I have seen like at least as compared to what I have gone through before, there was tremendous or multiple, I would say the multiple times tougher curriculum and probably the rigorness I have seen. So in the first semester I struggled, but fortunately I worked hard and I settled there and I started my research there under the supervision of Professor Roger Zimmerman, a great person, a great supervisor who always encourage and motivate to pursue whatever you like. I mean, he has given me the flexibility. Okay, so you are free to do anything, and we will figure out later how to basically stitch all the work together, because anyways whatever the work you're going to do is somehow related, so you don't have to worry too much about PhD at the moment. Right now your focus should be learning. He encouraged me to participate in challenges, in the submitting paper to workshop, to the conference, journals, and basically collaborate with as many as people as you can, meet at the people, build your network, and that thing basically helped me a lot in basically growing in my career, at least what I follow. Because definitely alone you can do good work, but if you want to increase the impact of your work, you will have to do with a team. And that is the fundamental thing I always follow, and that is the reason whatever I'm doing today at Triple IT Delhi, probably I will cover more details on that. It's all due to the amazing students, colleagues, collaborators, friends I have, because I mean together we can do great work. And that's how I mean I started my PhD journey at NUS Singapore. I was fortunate to learn a lot of from him, my colleagues, my friends. Even I mean that has helped me to visit approximately 15 to 16 countries during my PhD itself, to explore, to learn from the different people, different culture, and it was amazing journey. And after that, I wanted to come back to India. I wanted to join academia, and so around my PhD thesis submission, I have basically discussed with a couple of seniors and my supervisor mentors, where should I apply? So many of them suggested, I mean, the IIIT Delhi is the place where you should go, you should look for. And that is the reason I have only applied to IIIT Delhi, nowhere else in India. And I was very fortunate to get the position there even before I have I've done my PhD defense. And so it's great supportive environment at IIIT Delhi, and that's why basically, despite it is just 11 years old, it is excelling in different research areas. So be it in computer science, be in SCI, and so on. So before joining to IIIT Delhi, I have requested, I wanted to have a postdoc experience before my PhD, and IIIT Delhi has kindly agreed me to allow me to basically do my postdoc. I had a couple of offers, but since I had planned to come back to India soon after this, so I had offer from Singapore, some of the places in Europe. And so thanks to everyone. So finally, I have joined Singapore Management University because that is closer to the area I was working, social media computing. And after working there, learning a lot. And there basically I have seen, so during my association with SMU, so I have learned that, so before joining SMU, people say, I mean, you're going to join a management university. Then I got to know management is not only about people, management is not only about business. Management is also about data. And that's how the data I have, I mean, though I was dealing with data earlier, but my association with the SMU has taught me basically, okay, so the data management, data science is something, I mean, which is great area. And that is the time basically a lot of focus has started on machine learning, deep learning. I would say specifically deep learning. Machine learning was people were working earlier. So, and that's how the time of 2000, like 18, 17, when a lot of papers have started coming using deep learning. And that has also interested me. Okay, so it's the time to look into the deep learning. It's time to probably jump into the deep learning. That's how basically my work started more into the deep learning areas and so on. So during my PhD, I was mainly focusing on multimodal data around us. Because one thing I've realized, one modality is not enough. One modality is not enough. So in that case, you need to look at all the sensory information or all the information which are available with you. So in that case, you can think of human is the best examples of multimedia system, because human can process information, human can say something, speak. So kind of audio, visual, speech, touch, and other sensors that you can have. So I have realized this is definitely going to be an amazing direction, and a lot of work and applications you can build around that. Because my most of my work is revolves around some kind of applications, because definitely, of course, I mean, there are a number of direction and the areas, research area, which are equally good and probably excelling in different direction, but it's all about interest. So my interest is all towards the application, so that because whatever you can build, you can show to the people, you can use them directly and so on. So that's how I started during my PhD. I focus on a lot of on the building some kind of multimedia systems and building demos, building prototype and so on. And that's how once I joined IIIT Delhi, immediately after joining, I had a vision to start a multimedia lab. But with the help of a couple of colleagues and my initial, I would say, collaborator and the students, including you, Ramit, I have started MIDAS Lab. So MIDAS stands for Multimodal Digital Media Analysis Lab, which leverages the multimodal data around us and use advances in machine learning, deep learning to solve a number of interesting problems around us. So that's how I would say I probably become a bit long introduction, but that's how my journey is through the research and how I come to IIIT Delhi.
No, I think that's really helpful for a lot of people watching this, because turns out there's a big audience who is interested in machine learning and data science, but does not necessarily know where to start. And I think you are a great example of saying that we don't have to start with an undergraduate machine learning course. You know, having a mathematics background, being someone who is not started with computer engineering or computer science, going all the way to publishing deep learning papers today and having their own lab as CS faculty in one of the best research institutes in India. I think the length and description of the journey is probably something that people are going to ask for more. They would want to know more details, that how did you do X, how did you do Y? But I think, and in fact, a lot of the audience questions we have are around this. There are people who've asked, do we need to have a bachelor's degree in computer science to start? There are people who've asked, how do you go from India to universities abroad? What is the process? Would people want to go to Singapore? Would they want to go to Europe? There are all sorts of questions like these, and we can start taking some more of them. But I think a good number of the questions have already been answered through this introduction. So thank you for that.
Great.
So one of the first questions related to the machine learning field that has been asked is, how important is machine learning as compared to some of the other fields like software engineering, database management, web development, full stack, etc. Especially given that more recently there's been a boom in AI, machine learning, data science kind of jobs. So do you have any opinions on, should students focus on machine learning because it's a more booming field, or how does it compare with some of these other software engineering heavy fields?
So my response to this is, I mean, just like I've given the example of human, right? Human are the best example of multimedia system. And one example I have given also earlier, of course, we as a team, or as a, I would say, together, you can do a lot of things. So in case of research area or the direction, like, so a computer systems, or probably anything that you use today. So even, I mean, this video call that we are having today,
yeah,
it's not just one area that has contributed to that. It's all together. There is a team, there is a number of components to it. So including video processing, including speech processing, even the transmission to this. And even, I mean, writing to this, we need software engineering to write such a massive program for that, right? So all, at least to me, all the research directions are equally important and very, very important. It's all about where your interest is. The people definitely should not run behind the hot areas around you, right? Because today, machine learning is the hot area, but tomorrow it could be something different.
Yeah.
So that's why it's better probably focus, or probably choose the area where you can excel, where basically you have interest. So for example, there are people who have interest in computer architecture. They should do that, because and basically without advancements in the computer architecture, because we might not be here. I mean, even, I mean, we see a number of I mean, we all use GPUs and all those advances, right? All is coming through them, right? It's not like we are the one who are doing. So every research area and the people have their own importance, and accordingly, I think everyone have to contribute to that. So like in my case, I focus more on, I would say, the application. That's why basically I focus less on theory. I focus less on, I would say, the core machine learning or deep learning research. I focus more on just use. I'm more applied machine learning researcher. So I use the advances which are available in machine learning, computer science, or different areas like, I mean, sub areas like computer vision, natural language processing. I use them. I basically assemble them and to come up with solving some problem. So to me, all the research areas are equally important. You should go behind what you like more, and basically people can also assess. And one thing, because I would like to share my experience, because once I've started applying for PhD program, I have more interest in theoretical computer science, because I was from mathematical background. I thought, okay, so I could be, and now I have studied computer science, so I could probably contribute more on theoretical computer science. I was good at that as well, and I was, I would say, had a grade and all. I mean, quite good grade as well. So, but as I said, after joining MTech, I started working on information retrieval specifically. I found it more interesting because, again, so not to criticize theoretical computer science, it's more about what I like more.
Yeah.
And that's how my association and probably area shifted towards information retrieval, data science. And finally, that text processing has helped me to further grow towards not only text, but also, okay, so you're already doing natural language processing. How about go for speech processing? How about go for video processing? And that's how I expanded from one modality to the multiple modality and so on.
So I think the answer to the question in short is, there's so many different fields and everything keeps making advances of their own. They're all interrelated. And this is something I agree with. In fact, My career choices have also been many, but the different cases where one needs to decide, between finance and tower research or AI and share chat. And I think, not to say that AI is booming right now, so one would do it, but eventually I think you choose what interests you the most, because that's where you will exceed the most. So one of the next questions is another interesting question, and I think I know some of the answer for this. But so, given the fact that there's so many different opportunities around, things like internships. In fact, at our own lab in Midas, internships at IIIT Delhi, internships with different companies. There's so many different opportunities for young data scientists to work with professors, labs, industries. How does one go about finding such opportunities? LinkedIn is obviously one such way, but what would you recommend? How do people keep in touch with what all opportunities are there, and how do they pick between so many different opportunities, between, let's say, a research lab versus interning at an industrial position as a data scientist?
So I think it's very interesting question. And before that, probably I just want to add, it also depends on the students and probably what career choice they want to make. Because at least what all the application I receive at IIIT Delhi at my desk, one thing I've noticed that majority of the application that I receive who are interested in higher studies, right? And that makes sense because probably we were doing some research which is visible to the community, which is visible to the people, and at least the initial students who have also probably got benefited by the kind of research they do.
Yeah.
Right. And that basically helped them. So, and definitely, I mean, there are many students who are doing internship at the top places like industrial companies, I would say, for Google, Microsoft, and Amazon, and so on, just to name a few. Right. So it's all about, again, what your preference is, what your basically the aim is. If you are interested in software engineering, software development, go for the companies like which basically work in the area you want to work in. So for example, if people interested in finance, they should go for Tower Research, Goldman Sachs, and number of companies are there. If the people interested in so for example, building some kind of web development based thing, so there are companies which are there which are excelling in that, right? So in a way, I mean, if you are interested in software development and related, again, so there are people who may be interested in I want to probably learn and I want to basically contribute how to make 4G, 5G, and advances, LTE, and so on, right? So in that case, they need to look for and they want to build their career in so as a software developer or in probably consultant and architect and in those directions. So in that case, I mean, they should go for the companies. If the student interested in higher studies, my recommendation, and based on my experience, it has worked for them as well, go for probably some well-known research, not well-known, I would say, let me correct. So you should go for some research lab or at least some professor who can basically work with you closely and help you in formulating the problem statement, finalizing the problem statement, helping you probably in some possible direction, doing some brainstorming, and not only because completing the work is easy, taking it to the logical conclusion is something takes time, because I have seen that most of the, at least not most, majority of the students I have seen, they want to have everything immediately, but in the research it takes time, right? In software development, you start working, you probably come up with some visible output in a week or probably a month or so, but in research it takes time. And so that is something you will learn, at least get the first taste of research while working with the research lab or some professor, India or abroad, and so on. So the choice is depends on where you want to go for. If you are willing to go for higher studies, I think, so be it like masters, because the reason being, the people can say, okay, so I want to go higher studies, but not for PhD, but only for masters, and after that I want to go for IT companies, right? So based on my experience, I mean, when you apply to any reputed universities, right, you see a massive number of application. I mean, the universities got, right? University get the huge number of application, and you have to, and they have to basically, they need to be very selective because they don't have any options for that, right?
Yeah.
So what are the ways? What are the ways basically you can, and you will only be get selected if you probably somehow distinguish yourself from the rest of the profiles.
Yeah.
How you can do so? One possibility could be great. Okay, one of a possibility could be, so where are you from? So for example, some people from IITs, some people from NITs, some people even from some normal schools, right? Some people probably, I mean, able to probably, they are quite proficient in English, because earlier, I mean, the GRE, TOEFL, all these are also a good requirement for admission, right? Something you can change, something you cannot. So for example, I had a couple of students, they're not from IITs. Okay, so if they're not IITs, if they don't do something extra, they won't be distinguished themselves from the rest of the application. Similarly, I mean, there are people who are quite good at programming, quite good at probably other things, but not at English, because English may not be their first language, and probably they are probably from some place who haven't given them enough practice or the time for that. I mean, that's perfectly fine. Again, so how such people can basically excel, how such people can get admission to, say, for Stanford, MIT, UPenn, or Columbia University, and so on. So research at least is the way, because something they cannot change, they cannot change. But this something they can build and probably make a kind of add as an extra thing in their profile. And research is something they can do. And other people can say, okay, so I can also do the research in companies. I mean, I can mention that. The one thing I have noticed, at least based on my so limited, I would say, the experience so far, anyone can write anything, but there is no validity. So for example, I build a robot which work and interact well. Probably I build a software which probably do X, Y, and Z, right? But there is no validity for that. Anybody can write in anything. But in the research, if you write something, a research paper will be published, and you can mention the link, and that people can verify. And that, so it's more about the credibility. I mean, the people understand it, reputation, I would say. I mean, so that's how something, despite you're lacking in some aspect, the research can give you that additional aspect to get admission to the top universities. And after that, again, so you can make your own choice, whether again go for higher studies, for PhD, or probably you can go for IT industry. Again, it's your choice.
Right. Yeah. No. So I think that's very helpful in understanding for some of the people where, as people who are just starting data science, there are multiple options. And I'd say two good ways of distinguishing them based on Professor Rajiv's answer would be more industry oriented data science and more academic oriented data science. Academic oriented data science can be more focused if you're interested in pursuing a master's, a PhD. Perhaps it's also it's one of the ways in which people think about data science jobs abroad. I think 7 or 8 questions here are about how do we start data science jobs outside of India. And it might not be very easy to get some of these jobs directly from India, but one of the ways of becoming a data science in, let's say, Amazon US, Google US, things like this, Europe, Singapore, would be to do a master's degree, gain some more skills, more specific to a global machine learning and AI kind of spectrum. And based on those, apply for master's, PhD, get jobs abroad. The more industrial aspect of data science is where you focus on problems that are happening within India. A good example is what we do at ShareChat, for example, where it's not something that deals with solving research problems or writing research papers every day, but we're solving industry level problems to make tangible impact. A difference I've seen myself is in research, we write papers, we get this validation from conferences, our work is presented, gets covered by newspapers, everything. But it takes a while for it to reach an actual user. Whereas in industry, your work starts with the user where innovation might be limited. So I would suggest for most people, it's good to get a blend of both. If you're early in your career, in fact, that's something what I've done. Early in my career, I was focused in industry with software development, but I tried to balance my time and work with the Midas Lab in IIIT Delhi. And that's allowed me to get some academic exposure, publications as well. So although it might take some extra effort, the idea should be if you're in undergrad or even if not in undergrad, many research labs, including Midas, in fact, a lot in IIIT Delhi are welcoming applications from candidates of all age groups, all backgrounds, everything. The only idea is you should have an interest in data science and it's never too late to start. So my suggestion in alignment with Professor Rajiv's is let's try both, see what makes more sense. And if higher studies, academia seems more sense than more research oriented. If your interests lie more towards industry, maybe more data scientist type of roles, the intersection of this often ends up becoming something like the research scientist kind of role at organizations like Google, where your work not just limited to only industrial problems or research, but kind of doing both.
So before you go next, I just want to add one more thing. So these days, very interestingly, a number of companies also have their research division and a lot of opportunity which are available to you. So for example, Google have their Google Research. Similarly, probably ShareChat might also have something, some wing or division which is primarily focusing on probably some research aspect. And similarly, TCS Research and number of Amazon Research and all those.
Yeah.
So and basically they have also started some residency program. So these residency programs are very, very useful for students and also well reputed, I would say. So that they can explore, which give them a blend of, I would say, the research as well as the industrial perspective of any work.
And to add to that, I think it's a very good point. Answering the first part of the question, where how do you learn about such opportunities? I think one thing that I've learned through has been, again, LinkedIn, or even Twitter for that matter. If you think a certain position looks interesting, try reaching out to those people on LinkedIn. Interestingly, if you send messages on LinkedIn, initially I used to be scared of sending them, but over time I've learned that people are willing to help you. They're happy to talk about the kind of work they do. Reach out to people, try to understand what do they do as a data scientist. Do they solve more industrial problems? Does their data science job have a research flavor? Do they target publications? And you'll get a sense. Data science as a career also has multiple different variations, like software engineering has full stack, backend, routes where you could be more of an architect or you could become more of a software engineering manager. Similarly, data science has multiple of such aspects, and it's good to explore as many of these as possible younger in your career.
Yeah. So before you go to next question, I just probably I did not answer the last question fully. So because you asked about like what are the ways or probably the source where the people should approach. So LinkedIn definitely is the one way.
Yeah.
Another thing is not every people are active or equally active on LinkedIn, right? There are a number of popular researchers. At least probably I can give the perspective of academia. The number of researchers who are doing excellent work, but they're not active on LinkedIn, right? So the best way would be, I mean, you need to look at their lab website, their profile, and you also need to probably, because once you finalize, okay, which area you want to probably explore, you also need to do a kind of background work to find out what are the people you need to follow. So in that case, I mean, again, so different, and these people you can find in different ways. For example, in my case, I wanted to search, okay, so what are the people in information retrieval? If you just do information retrieval something on Google Scholar, so Google Scholar will give you a list of papers. And again, so it's just one source where you'll find a list of papers. You can look at, okay, so these are the people which are in my proximity, or probably something even you can approach. And again, so you, at least in the era of globalization, proximity is not an issue. You can also approach to any people located anywhere. And that's what I always teach to, I always basically encourage. And that's how basically I got motivated from my professor at NUS. He said, I mean, contact anyone. I mean, and contact anyone and probably reach out to them, make a network, and probably tell about what work you are doing, what interests you are, and probably what they are doing, and so on. So one thing I just want to add here, it's not like just approaching them. It's not just like approaching them through LinkedIn or email or probably finding these people. It's also about how you approach them, right? If you just do a message on LinkedIn, hey, professor, I'm looking for a internship. I have great interest in data science. Please give me opportunity. I cannot help because I receive hundreds of such messages every week. I cannot respond to all those. And again, so even though I have time, I mean, again, it's all about selectiveness. It's all about who give a different, I would say, the flavor to their profile, how you are different. Because when I was preparing for interviews, one of my seniors says, okay, so when you enter the the interview room, I mean, if it is very as usual as the other candidate, I mean, they're not going to have you. So probably what different you can do. So once you enter the interview room, you can ask them rather than they ask, you ask, hi, how are you doing? Rather than they ask you, and so it's give you all the confidence. So again, so just giving different flavor to that. So at least in academia case, if you are approaching anywhere, it's better to since it's about research work, it's better to basically look at the some of the work of that professor. And if you can do a kind of read that paper and probably do a critic analysis and say, okay, so hey professor, I mean, I read this paper, I really found interesting or bad, whatever you feel, and say, okay, so this is something, I mean, we need to improve on, or this is something, I mean, if I have to work on this, I mean, where I can contribute on. So if you highlight that, then definitely, I mean, your profile grab my attention and anyone's attention. And so that's how I think you need to approach. So of course, I mean, you can find the people through different sources, different looking at their website, or probably LinkedIn, or even job portal and so on. But in order to distinguish yourself again, you need to probably find better ways to approach them. So read their work, comment on what they are doing, or how you can contribute specifically, what's your strength is, how you can relate your skills with the kind of requirement the professor or probably other lab have. And the same applicable for industrial companies as well. So for example, Google research might have some vision or some direction they want to work in. So if you are applying them, I mean, you need to somehow relate them either in interview, either in while applying. And all these are matters. All these things are matters.
I think in short, and this is something I learned also after I think a year or two of approaching people. There's so many people like us, right? The industry is so competitive. In one word, you need to show how you add value. And that value you can only show if you've done homework around what this person does and tell them that, this is how we can improve. And it's actually good that you've brought this point up, because the next questions are actually about this, that what should students be doing when they try to approach different labs? For example, if they want to come from Midas or they want to go for an industrial job, I think we've already answered part of it, which is around developing value. The second part of the question is more around what are some of the absolutely basic prerequisites that people need before entering into data science. Like one prerequisite, for example, is, of course, we need to have some mathematics background. Now, some mathematics background can mean a little introduction to statistics, probability. So the basic question from a lot of people, in fact, is what are some of the key basic prerequisites in getting started with deep learning, machine learning? What are some of the main subjects that people should read either online, take courses on, etc.?
Okay, so prerequisite in a sense, I mean, definitely the mathematics is the kind of core of at least data science, right? So, I mean, definitely you need to have the fundamental probability, statistics, linear algebra, and all those. And again, fortunately, in the era of globalization, you'll find a lot of amazing resources available, publicly available on the website. And thanks to a number of universities, including, I mean, a number of initiatives from Indian government as well, like NPTEL is there, right? Where the professor from IITs and many others, I mean, they take classes on number of topics. So these could be one of the best source. Similarly, I mean, they can also look at, I mean, institute like Stanford, I mean, all those, I mean, they make all the lectures available to publicly available. So that is something, I mean, people can get benefit and probably create their fundamental at least clear. And again, so those who afford, I mean, if you think, I mean, they can take additional courses which can give them more hands-on experience, and all those things are again there. It is all up to your choice. It's not mandatory, I would say.
Yeah.
Because all the fundamentals you can get at least through, I mean, a lot of free resources which are available around us, and we can get benefited from that.
Add to that quickly, one of the things that, as part of, I think I'd say the last 1-2 months that I've been working with Scalar Academy, for example, I think some of the course that they are building has also been similar to what Professor Rajiv is mentioning. So the basic foundation, I think people often think they need a computer science foundation, but you have to start with a maths foundation. And I think that's also what's been Professor Rajiv's secret, because he started his studies with maths, not computers like us. So there's definitely a maths background that comes into play. In fact, I'd go as far as saying that a lot of data science is more about looking at the data rather than building complex models. And both the foundation of basic data processing and complex models, all of it starts with basic maths like stats, probability. Over time, it moves to things like calculus, multivariate calculus, things like this. So I think 2 sets of prerequisites. One is more on the theoretical side, which is maths heavy. Second is more on the practical side. I think, and this is something we do in our evaluation at Midas as well, where we basically would ask students to do an assignment in Python. And we suggest Python because it's such a rich ecosystem. So many libraries are there. So many things are easy to do. So it's important for students not to just look at courses or do book readings where there's no hands-on experimentation. You only learn after you do. So a suggestion would also be to look for courses that involve hands-on assignments where you can actually try building out your own neural network. In fact, in today's day and age, it's a funny thing. Like linked lists or like trees, we ask them in interviews, but we don't use them in our job. But we need them. We need to understand how they work, because eventually you can't just import things in code which you don't know how they work internally. Similar with data science, a lot of people know, or in fact today it's as simple as 2 or 3 lines to create your own big, transformer convolution neural network. But how many of these people actually understand how gradient descent and the training of that neural network works? Very few. So focus on the kind of courses where you can try out these basics and do these things from the ground up.
So I think that's a very, very valid point. So in fact, at Midas, this is one of the key criteria that we have. We don't just interview. As the first step, we always give some task.
Yeah.
And because we receive humongous, a huge number of applications.
I think last year was more than 1,000. So I can.
Yeah. So, and the first criteria that we give, you need to give we give some task and ask them, and basically a lot of application filter out, because that also help us to check the motivation of the student as well. And usually all the application that we received, the students who complete the task, we try to give a lot of attention to all those submissions, go them thoroughly and look for probably what are the students who can go for the next round of interview or so. But one thing I really want to highlight, it may probably sound not so good, but it's very selective. I would say the very competitive process. Yeah. Because recently, while discussing with one of my colleagues, he said, so competition is just like a way like this. If you want to get admission to a PhD program, you need to complete half of the PhD work to get the admission. Yeah. So because it's very competitive, the same thing applies here as well. If you want to get enrolled to some well-reputed industry or probably the lab or anyone, you need to also add value to that, and because it's very competitive, so don't just probably go through the book. You also need to do some hands-on, do the practice, so that you can help in the definitely our expectation is not like we want you to probably be expert in machine learning, but at least we expect you to have some understanding. And during the interview we ask this basic simple questions, right? So what is gradient descent, what is linear algebra, what is all those and all those very simple questions related to that to check your foundation.
Yeah, agreed. I think for anyone who is looking to start in data science, whether you're someone who's just starting out fresh with undergraduate, or it's someone who has multiple years of experience in industry, there are multiple parts. One, people that look at are the mathematical basics. How well do you understand things like linear algebra, calculus? How well do you understand basic machine learning algorithms? This doesn't mean you are solving problem like sentiment classification on Twitter. It means simple things like, do you understand how a basic neural network is trained? And the third and most important thing, which often helps people who are already in software engineering or even students who've studied data structures algorithms, is the coding aspect of it. As much of machine learning as you learn theoretically, even in research, and people often forget this, even when we write research papers, a lot of the time goes in coding. So it's important to not just have theoretical skills, but also to be able to implement these with practical coding. And there's altogether a new world now which focuses on ML operations. This is something we do in Midas, in one of the industrial collaborations that we have. This is what happens in industry. So you've made a machine learning model. How do you scale this machine learning model to serve so many requests that come in a minute? How does that work? For example, more recently, Google Search now uses BERT. It's a transformer-based NLP model for searching. How do we take BERT from just a research experiment to something that can serve millions of queries in seconds? This whole field around machine learning engineering, machine learning ops, building and deploying models, Docker, Kubernetes, this is another important field that students should focus on.
So before you go next, I believe we missed one part because we're talking about internship. Yeah. I have mainly covered the internship in India. Yeah. So regarding internship in other places, so there are several ways which work. So there are a number of programs which are established between different countries and probably supported by different organizations, which support you to probably visit different institution in the world and do your internship. So to name a few, like MITAC is one of the popular one. Similarly, S&N Bose Fellowship is also very popular one. So these are similarly NTU has, I forgot the name, but NTU Singapore also have some fellowship for inviting internship application. And in the world, so basically there are numerous such fellowship programs for internship which are already there.
Right.
So you need to also explore that. So this is one way of getting to I would say the international internship.
Right.
So since it's an international internship, often in some cases many people are not already aware of this, so somehow they miss it. So at least this is one thing they should try.
Right.
Second thing, which also comes through your network. When I say network, so like through your professor, because your professor might have some network with they have some collaborative work with us at different universities, industry,
Yeah.
in different parts of the world. And that's how basically you can basically get it. Third way, basically you can get the international internship. Many of my students travels a lot because they also attend the different conferences held worldwide. So like in 2020, at least 15 students from our lab have attended AAAI conference in New York. And that's how basically they get to meet a number of people around from across the globe who are experts in doing amazing work. And that's how because networking always helps because you through the network, when you get to know the people, at least you pass the first hurdle of getting to know them, or probably because once you meet, I mean, definitely you can tell about what kind of work you are doing, what value you can add on to the research the other people are doing. And you can also get to know, I mean, what are the people who are interested in your profile. And so definitely these networking through conferences help a lot. And fortunately, many of students who attended conference last year, now they got to the amazing places for their either for higher studies, for further job, for internship, and all those.
Yeah, I think that's an important point. And in fact, that was actually the next question where people were asking, how do you go about foreign internships? So everyone has their answer. And to add to this, I'll give a short example. And this actually shows why academic research or research papers don't need to be only for MS applications. So I had a friend who was amongst these 15 people who came with us to New York for the conference. And his interest was purely in data science job, not necessarily interested in PhD or academics. But he had a research paper. And what that research paper does on your resume, when you apply to any industrial company, is it sets you apart from hundreds of other applicants. Not everyone will have a top rated research paper. So it shows that you are capable of A, working in a team, B, getting your work reviewed by top level reviewers, getting it published. You can do the code for it. You can do the paper writing, documentation. You can present your work globally. And a lot of such conferences, in fact, which are now happening virtually. So it's the chance to take an advantage of these things. They have sponsor booths. All companies, Google, Microsoft, Facebook, all of these companies have booths over there. And they're very excited to have people who have a publication background. I'd say, in fact, if you look at most data science and AI related jobs, even machine learning engineers, often they say that in preferred qualifications, you'll always find a bullet point that says publications are not required, but are a very strong plus point. And to speak to that point, the friend who was there in New York, within, I think, 2 days, he got an internship with one of the AI companies in New York. So, and at that point, he was in India. So the whole idea is publications can really set you, and research, even if you don't write publications, even just reading publications and staying up to date with latest research or implementing research papers is a good way of getting into the industry and keeping up with latest cutting edge data science related things. I think we have time for one last super quick question. We'll be skipping some of the questions, but feel free to add comments to this YouTube video or on LinkedIn. We'll try to get back to these, or perhaps do another at some point. Okay, so yeah, I think this is a good question. This says, how would you say that preparation or the career path for someone in data science is different when they have multiple years of experience? So basically, a few people are worried that it's been a few years that they have done software engineering. In fact, like you had done some software engineering, I've done 3 years of software engineering. So some people are worried that they've already crossed 10 plus years of experience or 5 plus years of experience. How do we shift from software engineering to data science now? What kind of skills do we need to build up? What is the easiest way of maybe trying to get into data science while being in a software industry related job?
I think it's a very, very interesting and very good question. And I think experience matters, right? I mean, so even though you don't have experience in data science, right? So whatever the experience you have acquired, be it software development, software engineering, is going to help you, because you have different approach, or probably you have learned a lot, which will help you in quickly, which will help you basically quickly learn something new. Because at least in academia, if you see, I mean, the trend changes very quickly. Like before the deep learning, for example, deep learning, at least in the conferences, getting a lot of I mean, the most of the people started using deep learning for different problems around probably late. I mean, not late. I would say around 2014, 2015. You'll see a lot of papers coming in the deep learning. So the people who, even though who are not working in area of artificial intelligence and deep learning, switch to that. And at that time, probably their experience in the academia would be 30 years, 20 years, 35 years, and so on. So it's never too late. I mean, even though you have, and that's how people switch, right? Because you can switch to a new area, you can switch to something area. Practice you had over the years, over the month, is not like quick learning, bit learning in different ways, and so on. So at least to me, I mean, it is going to be helpful, because whatever the new skill that you have to learn, okay, I mean, it's basically few week or probably few months task. But so just think in that way. Of course, you have learned all the fundamental for data science, and you already have additional, I would say, the benefit of having 10 years of experience in software engineering. So I mean, you can complete all those fundamental in a few months, or probably in a year, 2 year. But after that, I mean, you have 2 plus 10 years of experience in data science, kind of, because you can apply 10 years of your software engineering to the 2 years of data science that you learned, and you can probably excel. And there is numerous such examples. People are doing amazing works, both in industry as well as in academia.
Yeah, no, I think that's
so it's never too late. It's never too late.
Yeah,
it's never too late.
I'd say it's an advantage, like Professor Rajiv said, that if you have some software engineering, industrial coding related experience, this is something that helps, because like we mentioned, data science is not just about the maths and neural network theory, but also about how you can implement this. ML engineering, ML ops might be a good career path to transition into a research scientist if that's what interests you the most. So in short, look for courses that might have multiple variations, like maybe a beginner kind of course which allows you to start with coding, Python, etc. And maybe there are some courses which are more intermediate or advanced, where it assumes that the person knows already how to code, and you just learn more on the theory so that you know how to apply this with the skills that you already have. Awesome. So although we do have, I think, more than 20 more questions to go over, but we're almost crossing an hour now. So we'll stop bothering Professor Rajiv with so many more questions. And I'd like to thank you for taking the time out. I know it's a weekday and everything, and I know how busy you are. So from that perspective, we're really grateful to have you. And for the audience, if you have questions, more questions, follow-ups on any of these things, we're always reachable through the comments on LinkedIn, YouTube, through the email IDs that we have of the lab. And we're always there to help people who want to start a career in data science. And I think a tagline that I've picked up from what Professor Rajiv has said, that it's never too late. So keep that in mind, and best wishes to people starting their data science career and journey.
Thank you so much, Ramit. And it's my pleasure, and it's great interacting with you. And I hope our interaction can help some of the brilliant mind and bright minds. And so with that hope, let's wish them best of luck. And just for, some of the students' reference, in case they want to apply for the Midas Lab, we always basically post the different opportunity on our social media pages. And again, so you can also look to those pages, follow them, and get the latest updates from there. Thank you so much.
Awesome. Thank you, everyone. Bye-bye.
With the significant amount of resources these days, it is not at all surprising that if a person gets confused on how to start or maybe even build a career in machine learning. So in this video, we'll be talking about how exactly can a person start his or her career in machine learning, what are the important skills that will give you that boost to secure a job in the field of ML, and what are some of the most average salary trends in this field. So without further delay, let us get right into it. Let us first understand what ML is. Machine learning can be defined as the science of making computers learn automatically. With machine learning, the computers can make decisions and predict outcomes without any human intervention. The whole process is achieved using algorithms which play an important role in building machine learning models, which can then be applied to a variety of other applications. Keeping in mind the definition of machine learning, now let us look at what are some of the most useful skills that one can learn to land a job role in machine learning. Firstly, mathematics and statistics are an integral part of machine learning. That being said, not all the mathematical concepts are relevant to ML. Some of the most important ones that are in fact relevant to ML are linear algebra, probability distributions, and calculus. One reason as to why maths is a prerequisite for ML is that mathematics is essential for applying the algorithms correctly and testing different hypotheses. With the knowledge of maths and statistics, one can pick up intuitions and learn the ML techniques really fast and accurately. Adding one or two programming languages to your portfolio is a great way to build foundations in machine learning. There are different programming languages in the current scenario, but the most suitable ones for machine learning are Python and R. The fact that Python is a high-level language makes it easy to understand and implement. An added advantage is that Python is so popular in today's world, so you'll have answers to almost every question related to Python on the internet, because the community is that vast. R is a low-level language which does the same thing that Python does, but most of the time it is used for data analysis and exploratory work. Having ML knowledge is another key aspect in building a career in machine learning. This includes both machine learning libraries and algorithms. For example, the Python machine learning libraries are the most preferred libraries used for machine learning. They deal with anything and everything related to machine learning. Libraries are basically a set of useful functions that get rid of writing the code from scratch. This in turn helps to reduce code redundancy and saves so much time. Some of the most commonly used machine learning libraries in Python include NumPy, which is used for various math operations involving multi-dimensional arrays and matrices, Pandas, which is mainly used for data analysis, importing data from various file formats like CSV, JSON, XML, and Excel, Matplotlib, which is mainly used for data visualization and involves plotting 2D graphs of arrays, SciPy, which is used for solving scientific and mathematical problems and is built on the NumPy extension, Scikit-learn, which provides efficient tools for machine learning such as regression and classification, and lastly, Keras, which has a wide collection of deep learning models. After gaining some knowledge on machine learning libraries, it is now important to focus on some machine learning algorithms and how they work. Each algorithm has its own purpose, like for example, linear regression is used to find out the relationship between variables and predicting certain values. If you want to dive deeper into machine learning algorithms and how they are used, there are tutorial videos for which you can find the links in the description box down below. After learning all these above skills, one must put them to use by creating small projects and maybe even contributing to open source projects on GitHub. This not only improves a person's practical knowledge, but will also give a slight advantage over people who don't have projects or any contributions. Apart from these two reasons, it is a good way to showcase one's skills. Now that we've talked about how one can start a career in machine learning, let us discuss the average salary trends and some common job roles in the field of machine learning. A machine learning engineer is someone who develops programs and algorithms that hugely enable machines to act upon by themselves. A typical machine learning engineer in India earns about 7,60,000 rupees per annum, whereas the same job in the US will fetch you around 147,807 US dollars per annum. A data scientist designs algorithms and prediction models to mainly analyze the data. The average base salary for a data scientist in India is about 9 lakhs, and in the US it is 119,000 USD in a year. Principal scientist is someone who does research and comes up with innovative and impact driven machine learning projects. The job role also involves coordinating with stakeholders and other teams. This is one of the most high paying jobs in machine learning, and it will fetch you around 15 lakhs per annum in India and 141,000 USD per annum in the US. A data engineer is a person who is responsible for data cleaning and making it readily available for further machine learning processes. This is one of the most important jobs in machine learning due to the fact that without proper data, it is impossible to get best predictions and insights. On an average, the mean base salary of a data engineer in India is about 10 lakhs, and this amount is around $125,000 in the US. The salaries in this field hugely depend on the experience level, your skills, location, and the organization you're working for. Various skills like deep learning, artificial intelligence, data analytics, natural language processing can help you stand out since these are especially in demand. And the jobs including these skills will fetch you a lucrative salary as well. With that, we have reached the end of this video. Keeping in mind all the skills that we have discussed today, it will help you start your career in machine learning and most probably land that dream job of yours. If you have any questions related to machine learning roadmap, let us know in the comment section down below. We will be more than happy to answer them.
Hey everyone, so we are live on YouTube and we are live on LinkedIn. We'll just give them a couple of minutes to join in. Okay, so all excited about London. Have you got the first like on arrival you would stay and everything is all arranged, everything is sorted?
Yeah, actually that's a good thing about Facebook, right? Almost everything is sorted. They've taken care of almost everything. There are a couple of things, of course. There's a lot of paperwork that gets involved when
Of
you are
course.
switching countries. So that's
Right.
something that you need to take care of. That's
Right.
not something that they can do for you. But other
Right.
than that, yeah, it's been breezy to say the least. But it's still a lot of work. It easily
Yeah.
takes up a month. Like I
But
didn't notice how.
are you getting those goosebumps, like new country, new environment,
Yeah,
new culture, food?
Yes,
For me, the
yes.
biggest problem is food. You know, you go to a new place, खाना कैसे arrange होगा?
खाना खुद ही बनाना पड़ेगा. There's no other way around. I think London still has a lot of Indian restaurants, so it shouldn't be too big a problem. But then again, yeah, I know cooking, so I think I'll manage. Let's see.
Awesome. Great. So everybody who has joined us so far, we have Bhavul with us. Bhavul is moving to
Hello.
London to join Facebook London, as you guys can hear from our chit chat. What during this conversation, what we would be getting to know more about, we'll be getting to know more about Bhavul, of course, and then in addition to that, we would also talk about his journey to Facebook London as a machine learning engineer. Machine learning, do we call them machine learning scientists or machine learning engineers?
So I think the technical term would be machine learning engineer, or the official term for that Facebook uses is software engineer for ML. So that's what they call it. But honestly, there's just a lot of variance now in the industry. There's data science engineer, there's machine learning engineer, there's AI engineer, there's software engineer for ML. All of them kind of mean the same thing. There's data scientist, there's research scientist, right? So in my previous company, I was called research scientist, and I'm going to be doing the same sort of work essentially.
Right. I think the only title that is scientist is kept for data scientist, which makes it a bit cool, you know.
I know.
I wish they had machine learning scientists as well. Yeah.
So I think outside, I'm not, although some startups are using scientist terms to hire anybody who does ML. Usually these FANG companies or any big company giants, they reserve the scientist terms only for those who have a PhD. So I've not done my PhD, so I can't apply for a scientist position. Even if the work is same, it's gonna be reserved for those who have a PhD under the name. Yeah.
Right. I'm familiar with this particular terminology for Volvo, because I think Volvo follows the exact same thing.
Yeah.
Even if you have done your master's, you can only be a data analyst or a software engineer but the scientist term is only reserved when you have a PhD in the topic. So
Right,
pretty
right.
interesting. So it's pretty interesting.
Yeah.
But you have also been a data scientist, right?
Yeah.
How different is it? Is it significantly different? Is it exactly the same?
No, it's kind of the same. So it kind of depends. Honestly, company to company, it differs. Even now, although things have changed and streamlined quite a bit since like I started with my ML career, but even now, I think it depends a lot from company to company. So you could be given a title of research scientist, but then a work might involve mostly data analysis. So that can
Right.
still happen, and the other way around could also be true, right? You could be called a software engineer, forget about having any ML thing in your position, but then you might
Right.
be working on some cool ML stuff. So it
Hmm.
comes down to company to company. I think job description is where you get to know about what you're gonna be dealing with.
Amazing, amazing, amazing. And we'll talk all about that. But first of all, I mean, I would want to know more about Bhavul, who you are, where
Yeah.
do you come from? So where are you from, Bhavul? Where are you staying right now?
Yeah, so I'm in Delhi. I'm from Delhi only. Delhi is my
Okay.
hometown. I've been brought up here only, and then I moved to Goa. I studied there. I studied in BITS Pilani Goa
Hmm.
campus for 5 years. I did my
Hmm.
computer science bachelor's there and master's in mathematics.
Why
Uh,
Goa?
so th-
Why not BITS Pilani, the main campus?
no, I Goa is just better. Also, I did not score high enough, honestly, to get Pilani campus either. So I was like,
We were just
fine,
talking
Goa
to
is good.
Yeah, we
Yeah,
were just talking to Mohit last week, right? And Mohit said,
yeah.
I just wanted to go to Goa because I mean, Goa, it would
Uh,
be so much fun.
I think if you send anybody to Goa after a year,
Yeah,
they would choose Goa over other campuses. So it's true, it's true.
I'm pretty sure.
Even if somebody was initially planning for Pilani, Goa
Yeah,
does have that sort of a vibe to it. Yeah,
right. I mean, the
yeah.
work and play balanced because I
Yes.
doubt the work and play will be balanced in Pilani or Kharagpur or Kanpur or any of those
True.
cities for matter,
Yeah,
right?
can't really say because I've not been there, but I love Goa. If I wish there were big or any good companies in Goa, I would have stayed in Goa. It's just as simple as
Completely
that.
agreed. Completely agreed. I was talking to this design firm a couple of years back. They were based
Yeah.
out of Goa, and I think some of the best creative work is done in Goa for unknown reasons. Uh, Amazing. So,
Uh,
BITS Pilani, computer science.
yeah.
Um, was that your first interaction with computers, or have you been coding for long?
No, no. So my first interaction with computers would have been back in sixth or seventh standard. But that was not coding. I think I started coding in ninth standard ish when again, just like Mohit, I think I was introduced to HTML and these sort of things, web designing sort of thing. But from
Hmm.
sixth standard itself, I did a lot of graphic design. So I worked with a lot of Photoshop
Yeah.
during that time, and I
Wow.
designed a bunch of things for some websites back then.
Hmm.
uh, then it went on to front end. In the college, I did some front end work, some designing work, just kind of carrying on to whatever I had learned during school time. But my proper coding experience started in 11th standard when C++ was taught in my school.
Hmm.
So that's where I was fascinated. Honestly, I was very fascinated by a simple for loop, what it could do, and what all we could accomplish by writing a simple program, right?
Right.
And that fascination has been there for each and every sort of subfield in computer science. So it was always a known for me that I'm gonna take computer science up. So I was sure from then on that if I'm going into a college, it doesn't matter which college it is, but I want to make sure it's computer science. That
Right.
I was pretty sure of. And then it kept on going. I tried almost every sort of thing, right? So graphic designing front end, I've done a lot of back end work as well during college, after college. But machine learning was I was introduced to machine learning in my second year in the summer vacations. I tried to do this course that was becoming very popular by Andrew Ng
Oh.
on Coursera, the
Hmm.
original OG machine learning course.
Right.
uh, Went through that. I was again completely fascinated by what machine learning can do and what it is basically. And
Right.
then that caught my eye. I tried to take up from then on. I tried to take up every single course that my university offered related to machine learning. I remember continuously knocking on the door of professors that I want to do some project with them. I even stayed back the next following summers in the campus alone just to work with a professor on a research problem. So that was where the entire machine learning journey started for me. I worked on support vector machines, which are not so popular nowadays. It's a machine learning algorithm, one type of algorithm. And some papers came out of that, but that's where my journey started, and it's just been going on from then on. But yeah, after that, after college, I went into direct eye. There I joined as a software developer. So initially I was just working on backend stuff. Slowly I transitioned into some machine learning projects, and then since then it's just been machine learning.
Machine learning, data science, machine learning.
Yes, data
Amazing.
science.
Amazing. So we have just one quick question that I would want to answer. Joyjeet Pal. So Joyjeet, what we are talking about right now is Bhavul's journey. Bhavul's journey to Facebook London as a machine learning engineer, and what sort of helped him in that journey. What worked, what did not work. Make sure that we can learn from maybe any mistakes that he has made, and make sure that we are able to avoid that, and we are able to help more people move in that direction if they want to. Right. We'll also come to that question, should they or should they not? We'll also come to that question on when is it okay to choose machine learning, when is it not okay to choose machine learning. Great. Awesome. So Facebook London, right? I mean, before Facebook London, you were working at Zapper.
Yeah.
What does Zapper do?
So Zapper is a company in a media advertising space. Their primary source of revenue is through advertising. They help advertising agencies and advertising partners to kind of build a strategy as to for offline advertising where they should be advertising, right? Which channels would give them the best yield of reaching out to the target audience while still being able to optimize their cost, right? So that's their primary source of revenue. It works. The entire backbone is a lot of data, right? So they have some patented signal processing tech through which they're able to identify like who is watching which TV program at a given time. Okay, so now this is obviously integrated into some applications and platforms, and it happens via consent form. But whoever signs up, we can obviously through this way in an anonymized manner get an idea of who is watching what sort of a serial or what sort of a TV show or what sort of a movie, and that sort of a data is quite helpful in then identifying which sort of an audience a particular advertising agency should cater to and which channel are they usually on a given time and date, right? So that's where the backbone is built up. Recently Zapper has been trying a lot of new things in voice domain, so voice and speech domain. So they're working on some new speech tech, and it's all in-house, the speech recognition to the chatbot building process. And we're trying to work on voice bot related technologies wherein we try to work with certain clients and try to solve their problems of automating part of their customer center calls, at least the more common use cases. So these are some of the things that Zapper is working on right now. And there are a few other projects that Zapper worked upon that I was when I was in Zapper. Now it's been a month. I miss Zapper quite a lot. It was an amazing place to work, actually. And it gave me the opportunity to actually own up a lot of modules and work on all the cool machine learning stuff there.
Right. I mean, this actually brings me to a very interesting learning that I got just a couple of days back. Right. Machine learning in itself does not have implications only towards fan companies. It has implications all around. For example, just a couple of days back, I'm a big time automotive fan. Right. I think most guys are. So I was looking at this particular brand that is based out of Europe, and their entire car is designed by machine learning. So not a single person is involved, and they have brought down cost by 95%. So
nice.
99%, sorry. So the cost to develop a hypercar usually is 500 million. Just because a machine is doing it and no human is involved, the cost to develop that car was just 5 million. 500 million, 5 million.
Yeah.
Yeah. I think the implications of machine learning is very, very wide, right? It's across the industries, and I think that is one of the biggest places for people to experiment, learn, and try. So among all of these opportunities, what made you choose Facebook? Because Facebook has been doing the same thing for a very long time, at least to the outside world.
No, yeah, that's true. So uh, Facebook was always one of the dream places to be. Whether you believe it or not, they do work on certain very challenging problems. Like some of the problems that I'm particularly interested in, for example, is fake news detection. For example, right? That's a very crucial problem that we are all facing, especially if we have looked at our parents' WhatsApp groups. I think we've all seen these problems. So problems like that, a problem like preserving integrity while still maintaining freedom over a social network, right? These are some of the things that I'm particularly interested about. And Facebook seemed like one such place where I get to work on these. I was even happier when I got to know that these teams are specifically placed in London itself. There are a bunch of other teams as well in London, but this was something that attracted me quite a lot. Although it was not a outbound scenario, I was reached out by a HR from Facebook, and that's where it all started. Like that got me flowing, got the thought flowing that hey, maybe this would be a great idea and let's try it out. And then this entire thought process began, and I gave it all my time that was required. Yeah.
How was that preparation? I mean, for example, let's say when the HR reached out to you, did you immediately interview, or did you take some time off for preparing first?
No, I took a lot of time. So I think this is where my journey would differ from quite a lot of folks. My entire interview process lasted over 6 months, and that would be a surprise to almost everyone, I guess. The reason being, even though this is a machine learning role, Facebook as such, even though it's a tech giant, right, it tries to work in very small teams, like small startups of their own. Okay, so they still try to retain that sort of a culture within them, that you should be bold, you should try to move fast, and you should try to own as much as you can and build things completely, right? So it kind of gives you that all the positives of having a tech giant, as well as also all the kind of ownership and freedom that you need in a startup, right? Now with Facebook, what was happening is, even though it's a machine learning role, it's very unlike all the other companies that will take machine learning rounds. So usually other companies will end up asking you, taking 2 or 3 technical rounds. All of them will be machine learning based. So if you've been working in the ML space, you need a few revisions and you can kind of crack them. Okay, and you can crack most of those rounds if you've been working in machine learning, or if you have studied well enough. In Facebook, it was not that way. So in Facebook, it was primarily a software engineering interview with a one ML round in between. So what that meant was that I had to kind of relearn everything that I had learned back in college time.
Go back to the basics.
All the basics, right? Data structure algorithm, I had completely forgotten about all of that. So so it was a lot of relearning. It was also a lot of new learnings, right? System design is something that I got to work on here or there during my first job, a little bit in Zapper as well. But again, I had not worked at the scale of Facebook. Like I had never built a system which would scale for, say, 10 million users or 100 million users, right? I got to work on that in Zapper at a particular time where I got to think about that. But usually software engineers would get to do that more often than a person who's working in the ML space. So that was something that had not occurred so many times that it had become natural to me. So these were things that I had to learn. So I took my own comfortable time. One lesson that I would want everyone to take from here is that uh, I personally used to feel very anxious that hey, I should probably not ask for more than like 2 weeks of time or 3 weeks of time from the HR. But it's completely fine. I through my preparation, one day I was reading some blog where a particular guy, some lead engineer, had basically broken down how much it costs to a company to hire a person or reject a person, right? Any candidate that gets rejected, a company loses close to $5,000 on them.
Wow.
And that's a huge cost to a company, right?
Yeah.
So if they would be more happy if you take your own time and prepare well, and then
Right.
appear for the interview, because they're going to lose more than you would actually
Right.
from a business, right? So yeah, so that's what I can talk more in details as to what rounds were there and how much time I took for each of them. But yeah, I took considerable time. Yeah.
Yeah, we'll come to that. We'll just come to that, Bhavul. I would want to maybe break down a bit of that last component that you shared. It is the economics of hiring, because, for example, we talk about how much do these companies pay and the kind
Right.
of crazy pay scales they have. And in the end, it's these engineers who are interviewing you, right? So
Yeah.
their hour has a cost. If they talk
Yes.
to 5 people, they would want to
Yes.
hire those 5 people, right? If they are unable to hire 4, those 5 hours that have gone in hiring that one person become a cost. So
Right.
if any, I mean, I think what Bhavul also put together very well is take as much time as you need, because the companies also want you to do your best and hopefully come on board and work with them, right? No company is
Right.
trying to reject you. We're all trying to do our best to make you extremely productive, extremely good, and work together. Um, can you, before we go to the interview pattern, can you give us a quick overview of your preparation plan? What was that 6
Right.
months preparation plan? Where all did you spend most of your time?
Okay, so my initial plan was just 2 months long. Not It was not supposed to go 6 months, but this is a common problem that I think software engineers deal with. That spillovers happen. So
Yeah.
now my initial plan was that I need to do well in all of these rounds. Right? There was primarily a coding round. There were a few coding rounds, which were data structures and algorithms. There was a system design round. There was an ML system design round, which is not the usual ML rounds that startups take. Um, so it had to be completely new sort of learning as to how you need to structure your answers for any sort of question that appears in this. And again, then there was behavioral, for which there isn't too much of prep needed, but I can talk about that later, right? So these were the 4 rounds. I was primarily focusing most of my time for the preparation on the first 3.
Okay.
And for coding, I think my initial plan was that, okay, I need to. I was scared of coding, honestly. So I've not been that guy who used to always do well in data structure algorithm. I've been a good problem solver. If you give me a good problem, software to build, an application to build, I'll happily do that. Okay, and
Right.
and it's not like I'll write very bad code or anything like that. But somehow, just this idea, like if we go 1 year before this, and if we were having this conversation, I would not feel very excited about solving a DSA problem. And the
Got it.
reason for that was simple, that it was more like a puzzle, and I did not see it impacting anybody out there other than me. Of course, it could impact me, but there was no social impact to it.
Right.
And that somehow used to keep me from away from it unless there's a need. But here there
Got
was
it.
a need. There was a big need. So
Right.
at this point, I try to prepare a plan. There was a book named Cracking the Coding Interview. So that
Right.
was my first part, that I need to go through that book completely. Then I started going through one of these platforms. So I chose Lead Code, and I went through, I solved about 150 questions before I interviewed for my first round. Um, and yeah, that was my main plan for coding. That after that it'll be lead code. I can talk a little more in detail, but let me cover the bread first, probably.
Sure. Sure.
Then for system design, again, since I was more new to this, with only few technology stacks that I've used here or there at various places, I started from the basics. Again, there's a course on educative, grokking the system design interview. So that was the starting point for me. I also read a bit of, there's this excellent book. If somebody has the time and bandwidth, I would highly recommend reading Designing Data Intensive Applications, Martin Kleppman. So again, a highly recommended book. If you got the time, it will build your thinking about scalability and about building these data intensive systems that which are having millions of billions of users, right? And then those were the two primers, right? After that, a lot of knowledge I received from YouTube itself. So there's this guy, Hussein Nasser, on YouTube. He has a channel on backend engineering. He has a lot of videos, I think hundreds of videos on backend engineering. And he has covered almost all kinds of technologies and the comparisons. So a lot of insightful content you will get from there. That okay, if you get to know that there are message queues, such as you can use Kafka, you can use Redis as a message queue, you can use um, I'm forgetting the third one. But if you have three different message queues, now as a newbie, you might not know which one's the better choice at which time. So there were some insightful videos on this guy's channel where you'll get to know these kind of stuff. So that was
Akash
there.
sorry to interrupt. Akash Galab has this question. I think you mentioned a book for system design. What was that book? I'll just type it in comments so that they have it.
Yeah, the book's name is Designing Data Intensive Applications by Martin Kleppman. If you just write designing data intensive applications, I think you'll Google will like direct you to the book. It's an excellent book. I think if you've got a few months on your wrist, definitely go through that book. It'll develop the perspective and thinking about the right sort of thinking about system design.
Awesome.
The YouTube channel as well. It's Hussein Nasser.
Hussein Nasser. Great. Awesome. Sorry for interrupting. Please continue.
No problem. So Hussein Nasser was one. There are a lot of YouTube. There are a lot of playlists on system design as well on YouTube. If you just search system design playlist, you'll get through a lot of them. I remember Code Karle is one channel. Gaurav Sen is one channel. There were a couple of more channels, I guess. All of them are good. If you're somebody new, what you want to get to know initially is a lot of breadth, right? But one very important point is that there needs to be feedback loops when you're learning. So you cannot learn in this way where you go through a video and then try to understand what they said. I used to look at the problem that they're solving, pause the video, make the solution, and then go through the video. There have been a lot of times where I designed a very terrible solution. Okay, I've spoken to my close friends on the telephone saying, "Dude, I'm gonna fail this system design interview and I'm not gonna do well at all because it's I just suck at it." But it improves, right? With every single video, every single try that you do, you will improve and you will see that improvement. And either you're doing mock interviews or you're doing this sort of a feedback loop mechanism, it will help you know that as time processes, as you've gone through say 20 to 30 problems, you will see a definite improvement compared to the design that you'd built on your first few problems. So was my...
Sorry, have you had a chance to look at interview bit system design questions?
I haven't. I do recommend interview bit. Somehow I just didn't go to that website, but I love that website. I had checked it out a few years back. I've not checked it out recently yet though.
So the system design question, why I brought it up is because the format in which we give system design question is very much the same. You have the question, and then when you click on next, it would ask you, now you think about it. Okay. And then when you have given it a time, then you click on next, and then it will say, okay, did you think about what was your approach? And this is what we recommend. So it is sort of developed in the same fashion so that's why I brought it up. Yeah.
Oh, that's awesome. That's awesome. It should be that way. So that was a lesson as well. Another lesson was that, so with system design or ML system design, both of them are open-ended questions, right? So your solution may not be the optimal solution, but it can still be the right solution. Okay. So, and it can get you, it can get you to be hired still. So the thing is that one aspect for system designer that you need to become okay with uncertainty. When you are coming up, when you're going for an interview, most likely in these fan companies, you're going to come up with a problem that you've never heard before
Okay.
with these open-ended problems. So you're not going to see the kind of problems that are mentioned online on these platforms. Most likely you will not. For system design, ML system design, it will be something new. Now, when you come across something new, you need to be prepared, and you should have gone through enough of such problems that you're okay with any new problem. And that's another thing that I learned, that which makes mock interviews very, very crucial for system design, I think, because you are experiencing that exact same nervousness, anxiety, whatever goes on in an interview, and you have to experience it so many times that you become okay. Now throw me a problem and I'll try to take a stab at it. Right? It should not be that,
Right.
oh shit, I've not seen this problem at all. I don't know which pattern it belongs to and what should I do with it. You have to get from there to this other place where you get a problem and you're in that mode that, okay, I'll take a stab at it and this is what I'm thinking about.
I have a question at this point. So, for example, let's say system design, is it specific to the level at which you were interviewing, or is that asked across all levels?
That's a very good question. So I think Facebook has levels in their hierarchies for software engineers. So from I'm not sure of their E3 levels and below, but E4 and onwards, which is categorized from senior engineers to tech lead to so on, managerial positions. I think
Right.
system design stays as a constant round of interview. Some positions will even face 2 system design interviews. So that also happens.
Okay. Got it. Got it. Got it. Amazing. Awesome. And I had another question on the previous pointer that you mentioned, that you were preparing on lead code. Now, one of the challenges that I've heard from people who prepare on lead code or any open-ended platform is that you can solve a lot of problems and then you can still not cover everything, right? So what was your approach to make sure that you have some self-discipline to make sure that you cover a bit of everything and not just stick to something that you like? Because that's what people end up doing, you know?
That again, a very, very impressive question. So there are a few things that I want to talk about there. One, the lead code part. Second, the self-discipline part, right? So let me go at lead code first. My lead code started after I was done with cracking the coding interview book in its entirety. So which meant that I have gone through each chapter, each sort of type of data structure and algorithm sort of problems on their own, right? So initially, when you're just starting new, it's good that you take up a sort of problem like arrays problems or strings problem, and then you try to solve only a bunch of questions related to that sort of topic, right? But once I was done with the book, and I try to code all the exercises also that were mentioned in the book for every chapter, as many as I could. Once I was done with all of that, that's when I moved to lead code, right? And that's where I moved to a completely random solving, because it will be random at the end, right? So you will not know what sort of question you're gonna get, and
Right.
It's pretty important that you become okay with a new question appearing from a completely different topic. So that's where I started with lead code. Another thing that I tried on lead code was I used some extension to hide the difficulty level altogether. So so when I'm solving a lead code problem, I open the problem, and my mind is not biased by seeing if it's an easy, medium, or hard problem, right? Because you will not know these things when you're actually appearing in the interview, right? So that was
Right.
another thing that I tried to do.
Right.
And that used to make me very happy when I used to solve a hard question in like 20 minutes or 15 minutes. That used to
And then
happen sometimes.
realize it's a hard problem.
Yeah, then realize it's a hard problem. So there are some extensions like that. If you just search for lead code in Chrome extension, I think you'll get through one of those
No, I
which
think if
hides the
somebody
result.
from LeetCode is listening, please, this is a very important feature feedback. You should build this feature so that people don't have to download extensions.
That's true. That's true.
Amazing.
But yeah, I did that. I also tried to, initially I was trying to do some there are some 100 top interview questions. I was trying to take a stab at that, but later I just purchased the premium account from LeetCode, and there were questions there which have seemed to appear on previous Facebook rounds. They were tagged with Facebook, so I tried to make it more focused because I was only targeting Facebook at the time.
Right.
So that also helps, I think, because one thing that I realized quite later on was Facebook it seemed so. I'm not too sure again on this, but it just seemed that Facebook was not asking a lot of dynamic programming related questions as much
Okay.
as say some other companies do. So, so just doing slightly more focused way of solving DSA problems will help in such manner, right? If a company is focused towards a certain kinds of question and not towards certain kinds of questions.
Got it. Got it.
Yeah.
Interesting. And maybe before we take up some questions, one last question that I have been waiting to ask the whole day before we get into this session. So, machine learning is definitely a buzzword, right?
Yeah.
I mean, it is very safe to say that it is one of the top buzzwords in the tech industry, right? Everybody who talks about any new product, oh, we have applied machine learning, or we have AI. When is it okay to chase after machine learning, and when is it not okay to think about a career in machine learning?
All right. So honestly, I will be a very my opinion might be a little biased, right? Because I believe machine learning will be. I am sticking to this because I am fascinated by all the aspects of what all it can enable us to do in future, right? I believe that
Right.
it will get us in a couple of decades. It will be one of the primary factors which gets us to a future place where we are right now will seem very archaic, right? So maybe children or children of children of ours will feel that you lived in some very old age times. So
Right.
that's where I think it can get us, right? And that's why I think it's going to become an important aspect of software engineering in any way, right? Regardless of whether you chase after it or not. Now, whether I can talk a little bit about where the industry is right now and what you get to do if you are getting into machine learning and what you don't get to do and what kind of myths are there and how I can try busting a few of those, right? So
Right.
now as a machine learning engineer or research scientist or data scientist, you should understand that you will the good part is that you're going to mostly work on some cool problems. Okay. The reason is that people are going to come a business is going to take up a problem with machine learning only when they are kind of sure that it can't be solved via plain old engineering. Okay. If they are doing the other way around, I don't agree that's a great way to do it actually right now. And
Okay.
this is not just me. Even Google says so that when you're starting with a product, start with engineering. So engineering will get you 50% to where machine learning can get you with some very basic rules, right? So once you have inherently you will get to work with very cool problems which will make you think that hey, this is something complex, but this is something that can be achieved only via machine learning at this point, and that inherently has a cool factor of its own, right? But how in reality any problem with machine learning is built on data, so it's not built on you using your own logic and writing out the rules, right? Usually with a problem like for example any DSA problem, you are thinking about the logic, right? You're not writing a program which will write the code for the DSA problem. With machine learning, what you're doing is you're relying upon data. There are a few algorithms. There can be few tweaking around these algorithms, but there are a bunch of algorithms that work. And what you have to work on is building and having good data with so that these algorithms can do the job and solve your problem, right?
Right.
So a
Right.
lot of work for a data scientist or a machine learning engineer is about building this data properly, right? So any new problem you get, maybe 5% of your work will go into initial research of what people have done or how people have tackled this problem. After which you will be spending 50-55% of your work just building the data correctly. And by building the data, I mean getting the data, whether it by scraping, whether it's by writing your on your own or hiring agencies to do it for you, and then pre-processing the hell out of it, right? So you will write a bunch of scripts to kind of get it in the form so that these algorithms can learn properly from it.
Right.
And then there's the cool part, which everyone thinks is cool and which every course also teaches you online, right? Most of the courses, when they're teaching machine learning, are going to talk about these algorithms, that what are these algorithms and how they can learn to do something, right? It
Right.
is the core aspect, but in your job, it's going to take up only 10 to 20% of your time. Okay,
Awesome.
so here's where you are trying to here's where you get to tweak around these algorithms, try to see which algorithm works, which doesn't work, which one will scale, which won't scale, and just try a bunch of them. And it's an iterative process. So if again you're the kind of person who doesn't like iterations, machine learning might not be the place for you, because machine learning, and why jobs are called scientists, is because it's based on science and not engineering. So there's this science aspect to it, that you try out something and it may not work at all. And then you're going to try again with something else, and there is that aspect which, yeah, you don't usually get in engineering, right? I'm not saying that either of them is less beautiful. I like both of them honestly quite a lot, but
You know
it's just
what is
I'm just yeah.
this is very closely reminding me of humans, like, how we talk about humans, that you only see the success and the fancy part, you do not see the failure and the years of hard work. So when you think about
Exactly.
machine learning, it's exactly the same. There's a lot of
Yes.
hard work, training your machines and all of that, and people only look at the fancy part. Oh, you just did it, and machine did everything.
Yeah.
Pretty, I mean, I think that's what it makes it very, very, very interesting. Awesome.
Right.
Okay,
Right.
so
And
let's
yeah.
take some questions. I think, sorry, please go on.
No. So I was just saying that the last part of what you will be doing in your machine learning job is communication. So exactly this part, right? A lot of people in the industry still see machine learning as a fancy tech that you can try to apply and then it will do the job for you.
Right.
It's not that way. It's a very
Right.
iterative work, and because of that, a lot you need to be good at communication, specifically how are you promising things, because an engineering pipeline, you can design the architecture once and then kind of plan ahead of time how many months or how many weeks or how many days it's going to take, because all of the tech is done and this is all deterministic, right? With machine learning, it's not deterministic. So you have an idea that, okay, if I prepare data like this and I use this algorithm, it should mostly work, and it may not work after one month, right? And then you
Right.
have to inform your stakeholders that, hey, this did not work, but this is other algorithm which will work, because by then you've gotten to learn about it. So there's this iterative aspect for which your communication needs to change, and I think a lot of stakeholders also learn while they're working with machine learning that about its iterative nature. So a good part of being a machine learning engineer or scientist is being able to communicate these things with the stakeholders properly.
Amazing. I have so many questions right now, but it's just like, I know that we have people with us. We have a lot of viewers
Yeah.
right now who have questions. I'm so excited about this topic. I just want to keep talking about it. Okay, so we'll keep going in sequence. We'll start off with Sambut. Sambut has a question that says, what's the difference between AI engineer and ML engineer? Is there a difference?
Short answer, not so much. And I would say look into the JD. There are a lot of different terms that are being used to describe an ML engineer. Job description or talking to the HR will tell you exactly what the job will entail.
Is it safe to say that a lot of times these titles are used interchangeably?
Yes. It completely depends on which term looks fancy to a particular company, I feel.
Yeah. If it's a startup that's trying to attract a lot of people, it might just say AI engineer.
Yeah, it could even say scientist of some sort.
Pretty amazing. Okay, so Vaibhav, this is a very, very good question. I've been waiting to take this up. Can you explain any DSA problems, any DSA topics that are not needed in data science at all?
Not needed. So here's the thing, right? If you're appearing for most of the companies, right? I'm pretty sure that these tech giants will take data structures and algorithm rounds. If you're appearing for an ML role, even if you have a PhD. But other than that, most of the companies will not. Or even if they do, they will have a very simple round. So because most of your work is not going to be centered around the kind of things that an back-end engineer or a front-end engineer would be doing. So the work in itself is quite different, right? There is some aspect of coding involved. Of course, you need to be a good coder, but then DSA is something that on which not a lot of people test you, right? Most startups will not. Some will, but even they will be usually simple problems. So as long as you have some basic knowledge, you've done some top 50, 75 most asked questions in DSA, you'll be sorted, I think.
Awesome. But is it like if somebody has a very strong base in DSA, I think it doesn't hurt. It's always good.
No, it doesn't hurt at all. It helps only, right? Because I think one thing that I learned by solving a DSA is it does train your mind quite a lot.
Right.
Thinking
Intuition
logically.
building.
Yeah, intuition
Yeah.
building. Yes.
Amazing. Amazing. I think we have covered this to a certain extent, but if you could, like, for example, how many rounds did you have? How many
Yes.
were machine learning and how many were DSA and how many were
Yeah.
design?
Yeah. So there will be total 6 rounds that you will have usually. One would be a screening round initially, tech screening, which will be a DSA round. And this is an elimination round. So if you do well, you proceed to on-site rounds. If you don't, you're out. On-site, once you've proceeded to on-site, you will have all the rounds. There'll be 5 rounds there. There'll be 2 coding rounds again, which are again same DSA sort of rounds. Could be slightly harder problems. Then one system design round. General system design, any backend engineer usually is asked. One ML system design round, which I just realized that we have not covered too much upon. That if we get some time, I can cover a little bit of ground on that. And one behavioral round. So that's the rounds that you will have. I did have 2 extra rounds because for one of the round it did not go that well, but my communication was very well, and my method of approaching the problem was interesting to them, so they thought they could have a stab at it. So and that's what happened with me. I did not do well in actually couple of rounds, and then but they still felt that I was approaching it in a nice way. So sometimes that helps.
I think that again goes to prove that the companies are not trying to reject you. The companies are actually hoping that you make it through. Awesome. There are a couple of questions for Scalar, which maybe I'll just take up. So how does Scalar help to get into big data engineering positions in FANG companies? So Alok, Scalar is a program that helps you strengthen your entire DSA and strengthen your entire system design, right? So if you come into Scalar, you have you have a beginner, intermediate, and advanced batch, and they help you to brush up on your entire DSA, your advanced data structures, everything from dynamic programming, bits, arrays, manipulation. You will solve so many questions that you cannot think about. And then we'll also touch up a lot on system design. So that helps you make your resume and your interview experience a lot better. Okay, awesome. Just going through all of these questions.
This is such a good skill. You were talking to me and still reading all the questions. I just can't do that right now. It becomes so difficult. Kudos.
I think we have covered this. Maybe just a bit about what do you think got you the call?
Got me the caller. That's an interesting story. I'll try to shorten it. So I regularly try to keep myself updated with machine learning as a field, right? There's a lot of interesting stuff happening every day. And I usually do this via some newsletters. Now, one of the times there was this GPT-3. I don't know how many people in the audience have heard of it, but it was an algorithm that came out that did a lot of things at once without training it automatically, right? So, and it was done by OpenAI, the company headed by Elon Musk. So, so they when it came out, before it got all the mainstream attention, I had basically just posted a simple post on LinkedIn about it, about my own thoughts about it. And somehow the next day I had received a message from the Facebook HR that are you interested in this sort of an opportunity. So I am not saying that it's completely a causation aspect there. It could just be two completely different things, right? But I do think that it could have been possible due to that. But yeah, that's when they reached out. I think the lesson there is that if you get to know about something, just share it on some social media. It might help you. You never know who's reading it.
Right. Just put yourself out there. The more you share, the more you talk to people, the more eyeballs you have. The only recollection of OpenAI that I have is that OpenAI came to play Dota. I think OpenAI had a Dota game against Dendy, one-on-one Pudge game. It was a pretty amazing game. So that is my only recollection of OpenAI. But pretty amazing, right? We have somebody from college. So Amar is in the second year of his college, and he knows some basic machine learning. What should be his pathway?
Great question, Amar. Amar, I'd suggest try to do as many projects as you can. Um, the real experience of working on a machine learning project will make you learn about aspects other than just the algorithm aspect. So a lot of courses and materials online will teach you about algorithms, but in your machine learning job, you're going to deal with data processing a lot. You're going to deal with which should be the metrics, how should you deploy it, what is A/B experimentation, A/B testing, a bunch of things, right? That come up only when you have a project with you. So I would suggest try to work on some projects. It could just be simple as Kaggle competitions. Kaggle is a website where there are usually machine learning competitions. So they will pose a problem and a data set, and you just work on it, right? Or it could be something that you just think of on your own, right? And then try a stab at it. Open source it, do not open source it, sell it. That's on you. But I would say as much as possible get like practical experience. And if you want some resources on courses, if you still need to learn more, fast.ai is the platform I recommend the most. Deeplearning.ai is another website that has a lot of good courses now. So these are two platforms that will give you a lot of content if you want to learn about different aspects of machine learning.
Awesome, awesome. We have another good question from Prabhat, which is like, if you look at the career growth, is there any pros and cons of ML versus software development?
Honestly, I do not believe it to be so. I think, yeah, forget about software engineer. You pick up any position, right? Everyone's making an impact, and it may not just be Facebook anywhere, right? When a product is coming together, there is a lot of engineering, a lot of product management, a lot of designing, a lot of machine learning that's going into it, a lot of QA work, testing work is going into it, right? And each of them are equally important, I feel. So I would suggest whatever technology excites you the most, try to follow that. Like listen what seems to be exciting. What if you and if you haven't, if you are at that place where you don't know what's exciting, just try out a bunch, right? Maybe in the course of next 6 months, pick something from machine learning, pick something from backend engineering, pick something from front end, right? Maybe pick up React here, pick up Kafka in backend, pick up trying to do some Kaggle competition on machine learning, and try all of them and see which seems most exciting to you, right? And then go ahead with that.
Right. Pretty amazing. I mean, I think we have another follow-up question from Webber. I think we discussed about Amar's career journey. What skills should a fresher have when they are approaching data science? Do data science jobs expect a lot from a fresher? Nowadays, I know software engineering expects a lot. Like even if you're a fresher in software engineering, you should have done a lot of work.
Yeah, so I think machine learning has always I don't think that a lot is expected from freshers. So what's expected is that you are willing to learn. As a fresher, I think that's the most important aspect, right? If you really want to learn to do this well, right? The passion aspect or the willing to learn and solve problems, that aspect is the first most critical thing for me to hire somebody. The other things would be that yeah, you need to have show some sort of interest, right, in some way on your resume. That will help a lot. There will be nowadays, I think a lot of companies have opened up taking freshers for machine learning positions. When I was sitting in my campus placements, there used to be only one, maybe couple of companies that will come for this. Most of the companies were not. In 2015, most of the companies were not hiring for machine learning roles out of college. Now there are a lot of companies, so there is a good chance that you get through. Just try to show a little bit of interest through projects or through the work you've done, through research papers, anything, right? If you've done some courses and some projects, I think that will show a good range of interest, and that can get you through. But they're going to ask you same machine learning algorithm related stuff only. They're not going to expect things like ML system design, for example, from a fresh. So it's going to be mostly knowledge based, and what algorithm would you use? What is how can you explain this algorithm? Can you explain something like decision tree, random forest? why one is better in this situation, what would you use, things like that.
Right. I think projects are very, very critical, whether we talk about machine learning, whether we talk about software development. Projects show that you like to build things. You don't just like to the theory aspect of it.
Right.
Now, Sambhu, there's a very good question. Like, for example, how important is it to understand the maths behind the algorithms? And how deeply must we dig into the mathematical aspect?
That's an amazing
Before we
question.
get into that, do you love maths?
I like maths. The aspects uh, that are involved in machine learning. Somehow those are my favorite aspects of math. I did do a
Right.
master's in mathematics from BITS Pilani while studying there, besides
Right.
computer science. So, but there are also some aspects of maths that I do not like so much. There is an entire field on abstract mathematics. Wasn't my cup of tea. But probability, statistics, and algebra and calculus. These are the four things that will play a role somewhere in machine learning, right? And these are the things that will cover that you need to cover. Now there are very good places to go now. You can try to check out StatQuest as a YouTube channel. Can I type these somewhere? Or
Yeah, you can
maybe
post
I'll type it.
yeah, you can post a comment.
Yes. StatQuest, and then there's 3 blue, 1 brown, right? So you can try to cover a lot of math ground behind algorithms and behind what goes into machine learning just through these two channels to start with. If it feels interesting, try to go deeper into it. I feel a lot of software engineering ML jobs nowadays do not require so much of you delving into the mathematics of it. However, the
Right.
maths is always a bonus aspect. It will get you far. So if you like it, if you do not mind it, try to study it and understand it in more depth. Yeah.
Right. I think knowing how something works always helps. You can sort of, that's how you go towards the other side where you create libraries for others to use.
Exactly. Exactly. Yeah. Yeah.
Awesome. Okay. Kritika, I think Bhavul mentioned it took about 6 months for the entire preparation journey.
So 6 months, including all the interviews, were over in that as well. So
Okay.
not just the preparation. So interviews were also placed in those 6 months.
Right, right, right. How theoretical do we need to go for ML? I think we've already somewhat covered it. Thank you, Kandas. We'll try to make more tutorials in Hindi. We'll try to have more conversations in Hindi. I'm really sorry for making it very English oriented. Can you maybe tell a bit about the importance of statistics in machine learning and the performance of ML models?
Statistics. I'm assuming this is regarding studying statistics to understand how models are working. For that aspect, yeah, there are essentially a lot of models work on probability and statistics. So you will come around with terms that are often found in statistics books or probability books. Normal distribution, p-values, null hypothesis. These are some things that become common when you're working in an ML job. It's I would say at this point there's enough material on the internet that if you do not want to do a deep dive of a statistics course on its own, you don't need to. You can study the aspects that appear in machine learning, and they will be covered in one or the other platforms or courses, or even some Medium articles itself.
Right, right, right. Awesome. Kritika says that Bhavul, you have an amazing Medium article. She has been following you for a very long time, and I think you've also written a bit about machine learning. So I'm just going to post that link here if somebody wants to, look at that. One last question, and then we can maybe call it a night. From Manoj, I think we can take the last few minutes to talk about these. What did you exactly mean by ML system design? How to prepare for case-based ML questions like A/B testing, etc.
Yes. So thanks, Manoj, for asking the question. I wanted to cover this. So this is the aspect that will that makes FANG companies ML positions different than rest of the companies. ML system design is where you will be asked a problem statement, just like system design, that hey, you will need to design say something like Facebook feed or YouTube feed, right? The home screen. And but now you have to talk about this problem from an ML perspective. Okay, so now what usually is expected in this problem is to cover the entire ground of uh, all that is utilized in ML. So first you will need to understand the problem. Like if they are talking about Facebook feed, okay, then what am I trying to optimize? I would want more engagement, for example, right? I would want more people to stay on the feed, right? So this is more product level related discussion that you'll start with. You'll talk about the problem itself and what sort of metrics you will be following, right? Because any machine learning problem you're solving, you are gonna be looking into some metrics to see if this is going well or it's not going well. So metrics becomes a part of it. You need to discuss metrics. Then you go on to discussing about the data. So what data will be available to you? So you have to think about, okay, if I'm designing a Facebook feed, and my idea is that if a person logs in, I'm able to show relevant recommendation of posts, images, videos, etc. to the person. Then what data do I have available with me as a Facebook engineer that I can utilize for this? Okay, so you need to think about user profile data that will be available to you. Uh, uh, Maybe data about what day it is, what time it is it a holiday, right? A bunch of things about what sort of data is available to you. What sort of groups is this person in? What sort of friends does he have? What sort of topics has he liked, right? This becomes your data. So you have to think about what would be the data part, right? So you're not given any data set. You have to come up with what would be the features that you will be using in your machine learning problem here. Okay, and you come up with that feature set. This is called the feature engineering part. So we covered problem statement, metrics. Third is feature engineering. You try to then talk about, okay, if I have these features and this data and these metrics, what algorithm will I use? Okay. Now, when you're talking about the algorithm, it could be something simple as logistic regression. It could be like decision tree, random forest, XGBoost, neural networks, deep learning based any sort of architecture, and you have to be able to justify the decision. Just like in system design problems, you have to kind of justify your architectural decisions. Here, you have to justify which metrics you're choosing, why these features, and why this algorithm, right? Will it scale for this problem? There are going to be 1 billion people using Facebook every day. These many calls happening to the feed. Will your algorithm be able to make enough predictions at runtime, right? So you talk about algorithm aspect, after which you talk a little bit about deployment aspect, right? So how are you going to deploy this? Is there going to be A/B testing used? What happens? What sort of debugging strategies would be there? What if something goes wrong? How will you debug it? Are your models interpretable in nature or not, right? So these are some sort of questions that you try to cover in the deployment aspect. That what if something goes wrong? How are you going to tackle it, right? So
Right.
when you're given a ML system design problem, you have to kind of cover ground on all of these topics one by one, go through each of them and go into a little bit of depth of each of them. And if an interviewer wants you to talk more about any particular topic, you need to talk more about that particular topic. But yeah, that's the idea. Time management becomes very crucial because each of these topics is can easily take up half an hour if you want to. So it and it's on you. The onus is on you to kind of strictly shortly cover a particular area and move it to another area and make sure that entire ground gets covered.
Understood. Understood. We have one last very quick question. How important is data engineering for FANG if applying for machine learning or data science role?
Yeah, so I think data engineering is important because data engineering, I feel at this point, overlaps quite a lot with what you learn in system design. So when you're dealing with system design problems that would be asked as company at FANG companies, they're gonna ask you things which scale up to billions of users, and they are
Right.
usually going to ask you things uh, which are running on their product. So maybe a feature on Facebook or on YouTube or something like that. So in that case, there is already a billion user platform. So there is a lot of data. So when you're dealing with data engineering, a lot of the lessons there overlap with the system design part, I feel. So you can, I think it becomes pretty important.
Awesome. Great. Thank you so much for your time, Bhaval. I mean, everybody who is watching us right now across LinkedIn, YouTube, do let us know in the comments if you would like us to roll out a machine learning data science course. And if so, what would you like to see in that? And thank you so much for taking out time on a Friday evening and talking to us.
No problem. It's been a pleasure. It's been a pleasure. I also want to thank everyone who came here. This was my first live stream, I think, in life. So sorry if I fumbled here or there, but I
No,
guess it was
I think,
helpful somewhat.
yeah, it was very, very educational, and I'm pretty sure that all of us, everybody, can we guys get a quick response? Did you guys find it helpful? I'm sure that if you guys can just say yes in the comments.
Also want to just tell out that I am writing some more blogs. They are still in drafts, but I'm going to share in much more depth about each of these rounds and like how you can prepare with whatever resources I use, right? So there's like a huge Notion directory I have of all the links I used. I will be sharing those in the coming weeks. You can follow me on Twitter, LinkedIn, or Medium if that's going to help you.
Please do.
Thank you
Please
so
do.
much.
We'll comment down all the links to Bhaval's profiles so that you can very, very easily connect with him, follow him. If you guys want to hear from, if there is anyone you want us to interview in future, anyone you would like us to bring to the platform so that you can hear from them, please comment with their name, tag them, let them know that you want to hear from them, and we will do our best to get them on board. Awesome. Thank you so much, Bhaval. We have so many people who have had a great time. Amazing. Thank you so much, guys. See you again next Friday. Have a good night.
You all would have heard this term at least once in your life. Such is the kind of buzz that artificial intelligence or AI has created. Almost everything in today's world uses AI in some way or the other, be it your daily Netflix recommendations or predicting the stock market prices. With more and more data being generated each day, the need for technologies like AI is now more than ever. So, what really is artificial intelligence? AI is the science of simulating human behavior in machines that are programmed to perform tasks like humans and mimic their actions. Any machine that exhibits human like traits such as problem solving and learning constitutes AI. Ever wondered about how a Tesla drives by itself from one place to another without the intervention of any humans? This is possible due to AI. You would be surprised to know how that AI is not a new technology. It all started with the simple question, can machines think, which was asked by mathematician Alan Turing in the year 1950. A side note, Alan Turing was the man behind decoding the Nazi encryption machine called Enigma, which led to the victory of Allied forces in the World War II. The term artificial intelligence was first coined in the year 1955 by John McCarthy from Dartmouth College, Nathaniel Rochester from IBM, Marvin Minsky from Harvard University, and Claude Shannon from Bell Telephone Laboratories. The first artificial intelligence program, The Logical Theorist, was presented by Alan Newell, Herbert Simon, and Cliff Shaw at the Dartmouth Conference in the year 1956. The program was designed to mimic humans' problem solving skills and went on to prove 38 of the 52 theorems of Principia Mathematica by Whitehead and Russell. From imitating mere problem solving skills to currently building driverless cars, we can see the significant improvement of AI over the years. Now, how does AI work? The main principle of AI is feeding input data, processing it, analyzing it for any patterns or correlations, and then using these patterns to make predictions or future decisions. Therefore, it emphasizes on three human like behaviors: learning, reasoning, and realizing. Learning. In this stage, the main focus is to acquire data and make rules or algorithms as to how we can turn that data into something useful. After defining a certain number of algorithms in this learning stage, we now have to choose which is the best one for the task. This is done in the reasoning stage. In the realizing stage, the algorithms are trained over and over again with the right data to ensure that they provide accurate predictions and make important decisions. With that, now we will look into four major subdomains of AI, namely machine learning, deep learning, natural language processing, and robotics. We will now be discussing these in detail. Firstly, let us look at machine learning. Machine learning or ML is the idea or the science of computer programs that can automatically learn from their previous experiences and adapt to the new challenges without any human intervention. It is one of the most used and demanding fields of AI, and that is the reason we'll be discussing it more in detail. The machine learning algorithms are coded in certain order to perform tasks, analyze, and predict information from the given data. And depending on the type of data that is available and what they want to be predicted out of the data, ML algorithms can be divided into three types. Supervised learning. Supervised learning algorithms are the most commonly used type of algorithms. You may ask why. It is due to the fact that they're simple and easy to implement. The input is in the form of label example pairs, which are usually in a text, spreadsheet, or a CSV file. These label example pairs are fed one by one to the learning algorithm, allowing it to predict the right label for each example. The algorithms are focused on one single task or a problem. An example of a label example pair is as shown below. Here you can see that the employee name, employee ID, gender, position, department, and employee satisfaction are all attributes of one dataset. Moving on to the next one, unsupervised learning. We can say that supervised and unsupervised learning are two extreme ends. Here we do not give a specific target for the model, nor do we give it a feedback. Instead, the machine only has to find a way to learn by itself. Input data is usually in the form of unlabeled data and unstructured data, which is basically data that contains missing values or unknown data. Examples of unstructured data include text files, flat files, system logs, etc. Moving on to the next one, we have reinforcement learning. The models in reinforcement learning are trained to make not one, but a sequence of decisions in an interactive or a complex environment by using the feedback from its own previous experiences and decisions. Here, the models use trial and error methods. An example of this would be self-driving cars. The input data here consists of data from a wide variety of sensors on the car. If you guys want to know more about machine learning, there is a dedicated video for that, for which I'll be providing the link in the description box down below. Moving on to the second subdomain of AI, deep learning. Explaining this will be easier now as we already know what machine learning is. We can say that it is a type of AI that teaches a computer to behave exactly like that of the human brain. From the learning stages to predicting and classifying information, a deep learning network processes and analyzes data like how a normal human brain would process it. This is done with the help of neural networks. Neural networks are a set of algorithms that are modeled after the human brain, with recognizing patterns as the main motive. Structure of a neural network consists of a number of nodes, which are loosely designed to compute like that of a neuron in the human brain. Typically, neurons are arranged in a series of layers. The input layer, which receives various forms of data from the outside world. The hidden layer, this is where the computations happen. This layer consists of many units and its main job is to convert the input data into something that can be used by the third layer, which is the output layer. An analogy of deep learning would be that of a child who is learning a new language. The next subdomain of AI is natural language processing, or NLP as it's commonly called. NLP deals with communication between humans and machines by natural language. The technique involves processing of human languages and it enables the computers to read and understand data, mainly by imitating human natural language. In layman words, NLP algorithms try to break down the language into shorter, simple pieces, understand the correlations between those pieces, and determine how the pieces can be put together to create meaning. NLP is important as it makes it possible for computers to hear speech, read text, interpret it, and determine which parts of the text or speech are useful. Some of the applications of NLP include speech recognition, Twitter's sentiment analysis, which is used to filter hate language from various tweets, and spam detection. Lastly, we'll move on to robotics. As the name suggests, robotics involve the programming and designing of robots. Robots are often deployed to perform tasks which are laborious and difficult for humans to perform. Robotics is probably the only field where software, electronics, and mechanics are brought together. It has computer programs that tell the robot what, when, and how to perform a particular task. It consists of mechanical components for performing that task, and it has electrical elements for providing power and controlling the machinery. Some of the main applications of robotics are manufacturing, military applications, outer space applications, and health service. With the number of applications of AI increasing each day, people might only think of one question: will AI eat up jobs in the future? Not all the applications of AI are the same as factory automation or robotics. Industry sectors which involve manufacturing goods and products thrive on efficiency and low cost. They would save so much investing on AI when compared to investing in human labor. In fact, some factories in the world have already made their complete process automatic, and there are more factories which will follow the same feat in the future. But there is no need to panic because reports from various giant firms state that AI will create a plethora of new jobs. Experts also think that if anything AI will do in the future, it will be creating new jobs. The jobs we don't even know that they existed in the first place. In fact, PwC predicts that over the next 20 years, AI will create around 7.2 million jobs in the UK alone. That being said, yes, it will displace some jobs, but not all the jobs in the world. I hope this gave you some clear cut insights on what AI is, how it works, and the subdomains of AI. Please do subscribe to not miss out on more such content. Keep learning, and goodbye.
Hello, everyone. How are you? Cool. So I guess we
Hi.
can quickly begin with our introductions. So Tarun, would you like to introduce yourself?
Sure. Hello, everyone. Welcome to this live stream. My name is Tarun Malhotra. I am a lead software engineer at Intuibit. Before Intuibit, I was working at DirectEye, and yeah, that's about me. Hey, Pragya.
Cool. So as you can see, my name is Pragya Agrawal, and I'm also a senior software engineer over here at Intuibit, and I'm also an instructor at Scalar. Right. So you guys have probably seen both of us in many of the previous videos at the Scalar YouTube channel. So yes, today's topic is a very interesting topic, right? Since you all know that AI is the new thing, right? AI is the upcoming thing. So today's topic is going to be, first of all, what is AI and what will be the impact of AI on our life? So will AI be taking away our jobs, right? Or basically, what kind of jobs will AI take away? What kind of jobs, what kind of new jobs will AI create? And how do we prepare ourselves for the future? Okay. So yes, let's begin with Tarun. So Tarun, how would you define AI? What do you think AI is really?
Right. Okay. So first of all, guys, as Pragya said, all of us are worried about that. Hey, what kinds of jobs will AI take away? But before that, what is AI? What is artificial intelligence? So let's talk a bit about that. Basically, what we have been trying to do, we have been trying to utilize the computation power of our computers and trying to ultimately mimic. Hey, Pragya, am I audible? It seems that there is some.
Yes, so there's some lag in your audio, but yes, you are audible. Can you just? Okay, I think Tarun is gone. Let's just wait for Tarun to come back. In the meanwhile, let me basically introduce what AI is. So if you look at it from the perspective of the science of AI, right? Then AI, the ultimate goal of AI is to basically create something that can mimic a human mind, right? So we are trying to create an artificial brain. That is what artificial intelligence is all about. Right now, you can think of AI from a lot of different perspectives. So one of the perspectives that you can take AI from is basically AI research concerns itself with a lot of things. One of the things is what AI really is. What do we really mean by intelligence in the first place? Right? What are the capabilities of intelligence? How do we produce intelligence? Right? All these things are part of the AI research, and there are some philosophical considerations as well. So, what is consciousness? What is free will? All those different things. However, as you can understand, we are not here to talk about those philosophical parts of the AI. We are here to talk about the practical scenario. Basically, what can AI do for us? Right? What are the capabilities of AI, and how will AI change the future as we see? Okay. So, leaving aside the theoretical definition of AI, what can AI do? Right. So yes, Tarun is back. So yes, Tarun, could you tell us what AI from a practical perspective? What will AI
Yeah.
do for us?
Sure. Okay. Yeah, so basically AI, artificial intelligence, trying as the name suggests, that you are trying to generate intelligence which is artificial, which is not human. As of today, we historically we have been trying to look at intelligence from a human prism. That we have intelligence, we are intelligent, we can look at data, figure out patterns, take some decisions based on those patterns, and trying to figure out that hey, that is what we have already always called intelligence. Now AI is that you are trying to recreate that by using the computation power of your computers and trying to figure out those patterns and predict outcomes based on that patterns, or in a way structurally trying to mimic human intelligence and making machines capable of that level of intelligence, or maybe an intelligence which is beyond our human intelligence also. So that's what AI is for me, Pragya.
Cool. Perfect. Perfect. So what we can do is we can draw analogies of AI with what kind of technical revolutions we have seen in the past. So one very common thing that we have seen, one very very interesting thing that we have seen in the past is the industrial revolution that began in the 1760s and so on. Right? It lasted from 1760s to around 1800, mid of 1800s. So yes, we did see a lot of new technologies come up in the industrial revolution. So perhaps could you talk about that, Tarun?
Sure, sure. Okay. So first of all, guys, all of you would have heard about the term industrial revolution, right? Industrial revolution essentially is the revolution which actually gave us these machines, these steamed power machines, trying to and actually ended up in automating a lot of things that were done by hand before. But I will actually give you a much more deeper perspective here, and will try to actually tie that with this new revolution that is going on, and people actually call this the fourth industrial revolution. So actually, before coming to the fourth industrial revolution, let's try to imagine the history, our past, and see how all these industrial revolutions actually change things drastically. So the first industrial revolution, as Pragya said, was in the 17th century or the 18th century, is the industrial revolution which actually gave us the steam powered engines. And that is when all back in the day, the textile manufacturing was entirely by hand. And that first industrial revolution totally replaced that hand woven clothes and gave us machines that are going to create our clothes. This had a massive impact and led to a much higher level of we actually went to a much more optimized world where things could have been done at a much larger scale, which you could not have imagined early on. Then the second industrial revolution, which is also known as the revolution, which is also known as a technological revolution, happened when the world actually saw the invention of a telegraph. So people started building these great networks where people can talk to each other via far off to each other. And then they also started building extensively the railroad network. That is, you can very easily transport yourself from one place to another, and also via telegraph you can also communicate your ideas, that is, transfer your ideas to much larger geographical regions. Now the second industrial revolution also changed the way we have been living, right? It actually drastically changed things. Early on, if you can't actually move very quickly to different parts of your country, what would really happen is that there are some centers of all the innovation, some centers of all the trade, and some centers of all the education also, and everything beyond the geographical reach was a place where not a lot of things happened. But with this industrial revolution, things changed a lot in that aspect. Now the third industrial revolution, which is very closer to us, we know a lot more about that as of today. This is we actually appreciate that a lot better, is the digital revolution that happened. These computers, which actually started doing a lot of logical tasks for us, and started doing a lot of computation using these chips. This is the third industrial revolution. Now this fourth industrial revolution is actually the AI revolution, where not only some computations can be done using machines, but you can also hope to deduce a lot of inferences using these machines. So basically giving machines the data and asking them to figure out figure out more about that data, figure out patterns in that data, and then trying to also predict things. This is what the fourth industrial revolution is, and very similar in a lot of sense to the previous industrial revolutions, but also very different in some aspects. So Pragya, I would maybe if this made sense, I would want okay. Hey Pragya, are you there? Hey, so yeah, would want you to add in your 2 bits on how is this revolution different, let's say from the early 3 revolutions that I talked about, and then maybe we can also discuss about how this can also be seen very similar to the earlier revolutions.
Right. So you have already drawn the analogies with the past. So basically, the AI revolution can simply be seen as a continuation of the previous industrial revolution, right? The previous 3 phases. However, there are still a lot of dissimilarities. Right? So we have to understand that earlier in the industrial revolution, what was being automated was the labor-intensive part. Right? We were automating power. We were automating mechanical things. Now, what the AI revolution will allow us to do is it will allow us to automate the process of thinking itself. Okay, and thinking, if you look at it from the perspective of the things that we can do, thinking is the center of the human being. Right? So everything that we do, everything that is logical that we do, everything that is creative that we do, the science that we do, and even the very human connection that we establish with each other, right? The kind of emotional bonds we form, all that stems from our capability to think. Right? Now, because the AI revolution is going to automate this AI thinking, basically what we will be able to do is we will be able to put all these human traits of logic, science, even the human connection into a machine, right? And maybe, perhaps, we will be also able to make that machine much, much better, 10, 100, 1,000 times better than the humans, right? In achieving these things. Right? So even though the AI revolution is simply a continuation of industrial revolution, this might perhaps be one of the most significant bits of the industrial revolution, because the kind of impact, the kind of lives, the changes in the society that AI revolution will bring will be very, very drastic. So
absolutely.
Yes.
Pragya, I would just want to add one thing here. Of course, this revolution may actually take us to a world where the rate of change is going to be very, very high. We all appreciate that. But there is also, I would want to point another underlying similarity. So the rate of change today seems to be very, very high with this fourth industrial revolution. But if you try to imagine the kind of world that was before the earlier industrial revolutions also, you would realize that actually the world changed a lot with those revolutions also. But now when we look in hindsight, it seems that, hey, it was a small change, but that was a small change only because where we are today. But if you look at the perspective from that time of the world, then you will realize that maybe the changes then also were very, very huge. For example, just imagine that if there were no machines whatsoever, right? If there are no machines, the humans can actually hope to be most productive by doing laborious jobs. You actually farming yourself by hand, you producing goods yourself by hand. That seemed to be the most outcome driven work that you can do back then. But with the machines, that changed. Our perspective changed. Our what we feel is important changed, because there are a lot of things that can automatically be done. Similarly, today also, the things that are very important to us today, the jobs which gives us which are very well paid today, may change drastically in the next few years, given that our machines are getting more and more intelligent, and a lot of things that seem to be very, very optimized usage of our time today may not be the same as we look a few years later. So that's very, very important to understand.
That's right. So basically talking more about this point, you said that some jobs, I mean, most of the jobs that we thought were productive way back in the time before the industrial revolution, after the industrial revolution, we realized that those jobs are perhaps not the most productive use of our time. Right? We can invest our time much better in some other jobs. So if you look at it from today's perspective, what kind of jobs do you think the AI revolution will take up? So the title of our video is, I mean, let's come back to the main topic that we're trying to address over here. That AI is guaranteed to take away some jobs, right? That is beyond question. AI will definitely take away some jobs. What kind of jobs will AI take up first? So yes, what do you think, Tarun, about that?
Right, Pragya. So the best way to look at this would be to look at the jobs that are already being taken away by AI, right? So the first thing that I would want to talk about is the warehouse jobs. So today we have the Amazons of the world delivering millions and billions of packages all throughout the globe. You would realize that warehousing those packages and then sorting those packages to make sure that you are delivering the right package to the right place, that involved before this fourth industrial revolution, that involved a lot of labor, a lot of manual labor. Today, if you look at the warehouses of these big organizations, you would see that 90% of the job is actually automated. There are humans, but most of them are just supervising, making sure that there are not some exceptions that happens, and how do you handle those exceptions, and also then doing some interface job. That is, a lot of work is done by the AI, by the machines, and you just act as an interface and get the things done, take them to completion. So of course, warehousing jobs are being replaced as we speak with artificial intelligence. The next kind of jobs that I would want to talk about is the jobs of, let's say, customer support. You calling somebody in a call center, trying to get your job done, asking them your doubts, telling them about, hey, why is this not working? How should I get this to work? This happened to be a very big employment opportunity for us. And this was a good use of your time, because you are now assisting others to use a product that you have created. But now this is a job which is being disrupted by AI at a very, very big pace. You would see a lot of companies out there in the world today trying to build these chatbots, trying to automate the experience of users, and automatically trying to figure out that, hey, what's the right resolution for this particular this particular use case. So all of us are using Swiggy, all of us are using Zomato. Today, if you order something on Swiggy and you realize that, hey, the order is not as per my requirement, the first thing that you do is you actually go to a chatbot. You don't actually get connected to a human immediately. You go and talk to a chatbot, and only in some exceptions you actually talk to a human, because most of your otherwise interactions can be handled by a machine itself. So yes, all the jobs, and if you try to understand the pattern behind these jobs, so I talked about two jobs right now: warehousing, I talked about, let's say, customer support. Let me also talk about one more job, because then the pattern will become much more evident. And Pragit, then maybe you can add your ideas on the same. The third job that I would want to talk about is the business of underwriting risk. So I will just talk a bit about what do I mean by underwriting risk. So whenever you buy an insurance policy, right, you go and you try to buy a life insurance policy, you try to buy a health insurance policy, the companies are trying to assess what kind of a risk profile do you belong to. And based on your risk profile, do you smoke, you don't smoke, how healthy is your liver right now, how healthy is your heart right now. Based on that, they will try to estimate how long are you going to live, and based on that, they will decide what kind of a premium they would want to charge you, so that they can balance this risk. Now, this is a job which requires you looking into lots and lots of data, trying to make sense out of the data, and trying to look at patterns in that data, and then figure out that, hey, what kind of a risk profile this particular individual belongs to. Now, this is also a job which I am pretty sure will be automated massively in the next few years. Already we are seeing companies emerging in this space which are trying to automate all this. Now, if you look at all these three things together and try to look at an underlying story, that what kinds of jobs are these, what is the underlying pattern amongst these jobs that AI is very easily being able to automate today, you will understand that all of these jobs are essentially you trying to make sense out of a bunch of data points, right? So you have rich data available. You earlier required a human person there to figure out this particular instance belongs to which part of my data landscape, and how can I solve this issue based on how this was solved in the past, or what does the FAQ document tell me to solve this based on. Now, this is basically you looking at data, you looking at an instance, trying to do pattern recognition, and then trying to answer how to do it. If you look at all three jobs, warehousing, that is how do you transport a packet from here to here, what is the best route here, and how can you use machines to transport data within the same warehouse, or let's say outside the warehouse as well. And similarly, if you look at underwriting risk jobs, or you look at these customer support jobs, you will realize that you required a human to look at an instance and trying to figure out where does this instance belong to, and then coming to a resolution, and now AI is very easily being able to remove these jobs and automate these jobs. So the idea being that if there are some repetitive jobs that we as a human race is doing, those jobs can be the first jobs that can be automated. Pragya, maybe what do you feel about this?
Cool, cool. So the repetition part that you spoke about in the last, that is perhaps the key point over here. So it is not about how skilled a job is. It is kind of a misconception amongst people that only the low skill jobs. I'm not really sure how do you really define a low skill job? What is a high skill job? I mean, there's no job which is unnecessary. However, people still kind of believe that low skill jobs are the first jobs that are going to be automated, which is not a job that is going to be automated. That is more likely to be automated is a job that has a lot of repetition involved. For example, let's imagine that, I mean, let's imagine 50 years before from now, if you wanted to send a postcard, if you wanted to send a mail to someone, then there had to be a human that had to read the description, that had to read the address on the postcard, and they had to basically route it to the correct person. That okay, this postcard must be filed in this particular cabinet because it is going in this direction. Right now, thanks to AI, this is kind of a repetitive job, right? You read something and you put it in the right place. Right? That job is very easily automatable. And if you see, almost all the postal mailings nowadays, almost all of these things are completely automated by technologies like OCR and basically handwriting recognition technologies. Right. Other than that, there are several other jobs. For example, the job of a cashier or the job of an attendant. Right. What is the major job of a cashier? Right? A person comes to you. You hear out what the problem of that person is. Right. Similarly, the job of a customer support executive is the same. A person comes to you, you hear out their problem, and you direct them to the correct resolution. Now, this is a very repetitive job that can be automated. So these are the kind of jobs that will be automated. Apart from that, in the job world where people see that okay, these kind of jobs, programming jobs, people believe are very high skill jobs. However, there is a lot of room for automation even in the programming jobs. For example, if you have seen if you become a machine learning engineer, one of the first things you learn is things like what is linear regression, right? And you try to learn things like that. Okay, if I have a data set like this, then what sort of model should I choose to basically get a good result on this data set? Right? Now that seems like a very high skill job, but in fact it is not. And if you see, most of the companies like Google, like Amazon, they are working on auto machine learning techniques. Right? They are launching solutions in which you simply upload the data to their servers, and the server the AI will choose the best model for your data. Right? So I mean, the point I want to stress over here is that is this repetition. It is the lack of creativity in a job that makes a job more or less susceptible to automation. Okay. Now, there is one more thing in there which is important that we talk about. So, even when we talk about artificial intelligence or lack of creative and repetitive jobs, there's a lot of spectrum in these things. Some jobs require only thinking. For example, routing a particular mail, that requires only thinking, reading something and making a decision. However, there are some jobs that require a lot of hands-on activity. For example, if you consider something like a surgeon or something like a hairdresser, the hairdresser is not really doing something very intelligent, right? However, the kind of skills that a hairdresser requires, those skills need very fine motor control, right? Very good eye-hand coordination, very high dexterity, basically with respect to with respect to the hands of the hairdresser. Now, even though the AI revolution is taking at a very fast pace, the revolution that is with respect to mechatronics, right, robotics and controlling things, moving things around, right, that is still lagging behind a lot. So these things will still take. I mean, the hairdresser job will be automated eventually, but it will take much more time to automate those kind of jobs than jobs like programming. So I mean, as Andrew Ng used to say, that I know how to basically how to automate a programming job, but I don't know how to take the job of my hairdresser. So
right.
Yes,
so that's a very, very interesting point that Pragya you raised. I would actually want to go back a bit on this point and actually hammer this point across, because this should be very, very interesting to our audience. Our audience is primarily programmers, and now what they have just heard is that the probability of AI replacing the job of a hairdresser is much lower than the probability of AI replacing a job of a software developer. Now,
Exactly.
this seems very interesting, and maybe also a bit depressive also, that maybe you should maybe become a plumber or a hairdresser today if you want to have a job in the future. But now let's talk a bit more about that. When Pragya said that, hey, the programming jobs can be automated, of course they can be, but it's very important to understand how can you sail through this transition without you personally getting hit. Now, in a programming job, there are multiple aspects, right? The first part is that, hey, what most of us actually usually do is we build some APIs, we build some CRUD applications, right? Now, building a very simple API where you would want to pull out data from one side and then show it in a view somewhere else. So basically building these basic APIs is a job, or a part of the job that you can also imagine is very repeatable in nature, right? You just need to repeat a few steps over and over again every single time. Now, this is a job which is perfect to be automated. AI can automate this very easily. But at the same time, there are some other parts of a software engineering job that will not be that easy to be automated. For, e- for example, a software engineer also needs to architect systems, right? You need to architect system. You need to figure out that, hey, how will my system handle scale? Where do I want to introduce what kind of a layer do I want to introduce? Do I want to cache some of this? Do I want to store this in what kind of a data store format? How do I want to retrieve it? And basically trying to build the architecture of a system. This part of the job is not very repeatable. You can't just look at a system, you just can't look at system design of YouTube and say, I'm just going to copy that verbatim while building a new application. You will have to make tweaks, you will have to come up with new designs with each and every problem that you are solving. This is not going to be very easily replaced by intelligence. And when I say this, please bear in mind that we are talking about the next 10, 12 years. We are not talking about the next 200 years. In the long run, all of us are dead, right? So let's not talk about what happens 200 years from now or 100 years from now, but let's talk about what happens in the near foreseeable future. Now, if you are a software developer and you want to make sure that your job is not going to be automated in the next 5 years, you should invest in upskilling yourself in the skills that are not very repeatable. So how do you design a system? And also, let me talk about one more aspect here. So a lot of us are product engineers, right? So we are the owners of a product, a small product, and we also code it, we also build it up. Now, building it up will require again two kinds of things. One thing which is very, very repeatable, most likely that will get automated. But then there's the other part, that is what to build, how to build, why to build, maybe talking to a bunch of hundreds of your customers, trying to figure out what exactly your product can help them solve. Now, this is a job which is not going to be automated by AI very soon. Of course, you have a technology, but how do you leverage that technology? What do you build using that technology? There is where human ingenuity, human intelligence is required, and you should ensure that you're upskilling yourself in these skills so that you don't become irrelevant in the next few years. So that is very important.
Fair enough. Fair enough. So, I mean, I usually give this analogy in my classes a lot. There are basically two types of programmers. One of the programmer is a typist, right? Their primary job is to take some specification and to convert that into code. The second type of programmer is a thinker, right? They take a problem and they figure out how to solve the problem. Now, what you have to do is you have to become the second kind of programmer, because the first kind of programmer is going to be automated in the next 5 to 10 years.
Absolutely.
Cool. Right. Now,
And
basically,
yeah,
please,
just
please.
to add a point, there is where upskilling becomes very, very important. Because if you look at the mix of software engineering jobs out there are millions of software engineers, right? But in reality, a lot of us are not doing the second aspect. A lot of us are just focusing on what Pragya called a typist job, that is just getting some things done, a very, very repeatable process. You know how to code this up, you just create a few APIs and get done with it. This is a typist kind of a role, and a lot of us are actually in this kind of a role. We need to transition from this and move up this skill ladder, so that we are not just doing this repeatable job, but you are actually bringing something more to the table. You are not just typing a few lines of code, but you are ideating what to build, how to build, and that becomes very important. That is when you become least replaceable. And just to add one more point, guys, even if you forget about AI for a minute, if you want to become a software engineer who is very much cared for by your organization, or very much so all the companies trying to hire you, the kind of software engineers that people would want to hire are the folks who are problem solvers. You can give them an abstract problem and they can solve that problem to you. So that is what you should ensure that you are defined by. You are a problem solver. You are not a coder. You are not here to just copy 5 lines from Stack Overflow, copy them, run them, solve a few bugs and get done with it. You essentially are a problem solver. If you make yourself a problem solver, you can be much more respected and wanted today, and also you will be at a much better place to overcome this tide of AI and artificial intelligence replacing jobs. You can still remain relevant. So that's the basic point here.
Cool. So basically, diving further into this, if you look at the kind of things that a software engineer is expected to know, right? The kind of subjects that a software engineer is expected to master. So subjects like learning about frameworks, learning different tech stacks like Python and Django, or Java and Spring Boot, or React and the Merge stack and things like that. There are other things that a software engineer is required to do, things like knowing data structures and algorithms, right? Knowing about system architecture. So Tarun, what do you think out of this spectrum of the kind of skills that a software engineer is required to do, what kind of skills are the most important? What kind of skills are the skills that people should invest learning in today, so that tomorrow their jobs are more future-proof, or tomorrow their skills are more future-proof?
Absolutely. So there's a question from Suraj. He says, which new software engineering roles related to AI will be in demand in the future? So this question has two parts. Pragya, if you would want to take a stab at it, but there are two parts. Let's just acknowledge two parts here. First of all, what are the skills that we see today are very important, and what are the evolving skills that may become very important as we move along? So that is, how can AI bring in a lot more skills that you should master? And and the other part is, what are the skills that are relevant today will become a lot more relevant in the future because of the advent of AI?
Right. So basically, if you look at AI jobs are basically you can dissect them into two major categories. Right. One of the jobs is kind of the research job, and the other job is kind of the implementation job. In the research kind of job, what you try to think is, you try to research the nature of artificial intelligence itself. You research different models, that okay, if this is the kind of data, then what kind of model performs best on that data, right? Coming up with things like neural networks, coming up with things like convolutional neural networks, right? Researching things like generative adversarial networks. All these things, they are part of the research of AI. On the other hand, we have the implementation aspect of AI. Right? The implementation aspect of AI deals with that, okay, I know that these models exist, but solving a real life problem is much more than simply talking about the theoretical perspective of things. Right? So I have to understand where I'm getting the data from, how do I clean that data, how do I make sure that the models that I'm applying, they actually are performing well in practice, and my customers are getting what they really want. Right? So there are two parts of this AI field. Now, in both the parts, there are some jobs which can be automated, and there are some jobs which are more difficult to be automated. So if you look at it from the research perspective, there's a lot of papers that are coming out nowadays which are not doing any innovation. They are simply saying that, okay, we have this kind of problem. Nobody has applied this model on this problem, so let's apply this model on this problem. Let's see what the result is, and let's publish that. Right? Let's just publish that. That is something that is highly automated. Right? So you can expect in the future that those kind of research activities, those kind of jobs, right, will be reduced in the near future. The new jobs that will come up in AI will be the jobs that research new models, right? Okay, what sort of new idea can I come up with that is going to help improve my model, right? So drawing analogies or drawing inspiration from the nature, just like we have convolutional neural networks, drawing inspiration from the way our basically visual cortex works, right? Jobs like this will be more in demand. Similarly, if you talk about the practical aspect of artificial intelligence, the jobs that will be in demand, the jobs that will be created in the near future, will be jobs that will be looking at, given a particular problem, what sort of model or what sort of decisions should I take? Right? The kind of problems that require you to architect the solution and not just code the solution. So you can expect that all these frameworks that you currently hear about, that, okay, should I learn TensorFlow? Should I learn something like PyTorch? All those jobs are going to very quickly become irrelevant. The jobs that are going to be relevant, that are going to remain relevant, are the jobs that require you to understand the basic principles behind artificial intelligence. What is linear regression? Right? What are neural networks? How do they actually work? The theoretical aspects, the understanding, the deep understanding of those things are going to be relevant in the future jobs. So I hope that answers the question. Is there something you would like to add to this, Sarun?
No, absolutely, Pragya. But I would just want to hammer across the points again. A couple of points here, which I would just want to highlight. But you covered exhaustively here, guys. As Pragya said, that in research. So, for example, AI. There are two aspects to AI, right? You would want to research new models, and then you would want to implement those existing models and tweak them to solve a real life problem. In both these directions, you have some jobs that are very repeatable and can be automated very easily. For example, if you look at the folks who call themselves, let's say, data scientists, or you look at and try to figure out that, hey, if you try searching LinkedIn and try to find out for jobs that are out there in the domain of machine learning, you would see a good proportion of them actually over indexing on you knowing a particular framework. Hey, can you build a model using TensorFlow for me? Can you implement this for me? Those kinds of jobs are going to be very easily replaced, very easily automated. On the other hand, the other side of implementation, where you actually figure out how to tweak this existing solution to solve for a real life problem. This is an abstract model. How do I tweak this? How do I configure this? Maybe how do I use multiple models in conjunction to solve this problem? That is where the architecting part is going to remain relevant for a long time. If you want to become a data science, if you want to become a machine learning engineer, you rather should focus on problem solving. That how do I use this to solve a problem, and not over indexing on a bunch of frameworks. That, hey, I know this framework, I can code this up. I will read a research paper. I will just recreate that model here and get and that's all about my job. That is very easily replaced. At the same time, there is a wrong notion in folks that, hey, the research aspect of machine learning, the research aspect of AI, you can't automate that. But as Pragya rightly pointed out, there is a good chunk of effort, of human effort, that actually goes in research, where you just try to explore multiple configurations of the same model. You actually try running it through different configurations, and then publish a paper that, hey, these are the results that I just got out of this configuration. Now, this is a very, very repeatable job. If you find yourself doing the same steps again and again and hoping for a new outcome that you can publish, these kinds of jobs can very easily be replaced. On the other hand, thinking from ground up, leveraging the basic fundamental mathematical machine learning principles, and coming up with a new model altogether, coming up with a new way of looking up for patterns, that is something which requires human ingenuity. That is something which requires human intelligence, and you can't just replace that very easily. So irrespective wherever you are, in what segment, in what vertical you are currently, try to ensure that you move towards more intelligent aspects of job rather than the repeatable aspects of jobs, because knowing and being good at those repeatable stuff is only going to help you for a few years at most. It will not build a strong career for you for the next 20 years. I am very certain for that. So that is what we should all keep in mind, that, hey, what are the skills that require intelligence, and what are the skills that what are the things that just require repeatability? Move towards the skills that require intelligence.
Now, basically, this question that was asked by the viewer, there's another aspect to it. So maybe what the viewer was trying to ask is, what is the future prospect of machine learning jobs? So one thing that I would also like to point out over here is that if you look at the global supply and demand of machine learning engineers, there's a huge shortage of machine learning engineers in the world right now. Right? If you look at places like Silicon Valley, if you look at places like Bangalore, the IT hub of the world, right? there's a huge demand of machine learning engineers, and the demand is so much that companies are struggling to meet that demand. They're struggling to hire good quality software, good quality machine learning engineers, and good quality software engineers that they actually want. So if you look at it from the perspective of the next 5 to 6 years, even though we are talking about AI automating a lot of jobs, AI taking away a lot of jobs, in the near future, in the next 4 to 5 years, you will only see an exponential increase in the number of machine learning jobs that are available in the industry. So keep that in mind. Okay, that investing in learning machine learning right now, that is still a very good endeavor. That is something that is going to secure your future, for a long time. However, while you are upskilling yourself in machine learning, just keep in mind that don't upskill yourself only in the frameworks. Upskill yourself in the problem solving part as well.
Absolutely, absolutely. And if you can, as Pragya rightly mentioned, as of today, there is a lot of demand even for people who just know a few frameworks, who can code things up. But what the right way to look at it would be that, hey, I can maybe use that opportunity to get a foot in the door. I can use that opportunity to get a relevant job, but then it becomes very, very important for you to upskill yourself in the right skills so that your job does not become irrelevant in the next 10 years. So, absolutely, it's very important to make sure that you don't get us wrong. It is not as if learning TensorFlow today is of no use. It will help you a lot. It will get you several job opportunities because there is a big shortage for companies trying to figure out people who know those skills. But if you use that, just use that to get a foot in the door. But then it becomes very, very important to make sure that you keep on upskilling yourself. If you feel that, hey, I got a job because I knew this framework and this is what is going to help me throughout, maybe you are mistaken. And if you are in the AI domain, maybe you know it best that, hey, that we are mistaken here. Just knowing this framework should not be enough. Similarly, I would just again talk about software engineering because there are so many people here who are software engineers. Guys, today there is a big dearth of software engineering talent, right? You talk to any startup founder, the single most important resource that they will talk about is that, hey, I have capital. There is because of the Fed, US Fed, you have so much capital out there in the world. Capital is very cheap, but the thing which is most difficult to find right now is tech talent. And a lot of that aspect is just knowing coding, that, hey man, this person is good in Java, he can code, I can tell him what to build, he can just build that for me. That's great, but don't assume that that is going to stay as it is for the next 20 years. You can use that opportunity to get into the door, get into a good organization, start contributing, but make sure you don't stop there, because if you stop there, then there is a very high probability that you will become irrelevant. But if you use that opportunity to then start tinkering with that, hey, how are products built, how is this architecture architected, maybe I should upskill myself in understanding that, hey, what's the best architecture for this problem, maybe I should contribute that, hey, you should change this caching layer, maybe you should introduce a new kind of a caching here, maybe that will help. Making sure that you move and do that transition is very important, and all of us should be cognizant of that.
True. And basically, there's one thing that I would like to mention over here. So you talked about upskilling, right? And this is going to be a very common thing that is going to be. Upskilling is going to be the common theme of the future. So if you look at jobs today, people don't really invest a lot in upskilling themselves, in learning new technologies, in learning new skills. We're not just talking about software engineering jobs. We're talking about new skills in general. So you are going to notice that in the near future, learning new things, being able to quickly change your domain, right? Basically, quickly be able to switch from doing something to doing something else, picking up new skills very quickly. That is going to be a central theme. That is going to be a central skill that people will need to acquire in the near future. So, we have another question from the viewer over here. Can you just take that, perhaps?
Right. So Mohit will do that. But before that, in the meanwhile, Mohit, if you can take Nitin's question. But in the meanwhile, let me add one thing to what Pragya just said. Of course, the agility of learning new skills is very important. You need to upskill yourself, keep on learning new skills. Another thing that I would want to point out is being at the edges of two domains. For example, that, hey, you are a great software engineer, but you also understand human psychology very well. Just an example. Similarly, let's say you are a great software engineer or you are a machine learning engineer, but you also understand finance very well. Being at the conjunction of multiple skills, this is, in my opinion, going to be a very, very highly rewarding journey to take. For example, if you are very good in one skill, do try to look at that, hey, what are the ancillary skills maybe in different industries that I can pick up, and then move to a very, very in important position where I know one domain very well, but at the same time I also know a few things about a different domain, and I can work at the very edges, the contours of those two domains, and do something great. That is going to be very, very respected and very, very required, in my opinion, guys.
True.
Okay, so now we have a question from Nitin. Pragya, if you would want to take that. What are the prerequisites in order to learn machine learning? What are the things that you should first of all focus on?
Cool. So machine learning, if you look at it from the academic perspective, machine learning is not a very difficult skill to pick up, right? If your aim is to go into the strict research part of machine learning, if you're saying that, okay, I want to perhaps do masters in machine learning, or I want to do PhD in machine learning, I want to basically end up in a research profile, basically in different companies, then the kind of skills you need are basically, you need very good skills at mathematics. Right? What kind of mathematics subjects I'm talking about? Subjects like linear algebra, right? Subjects like statistics and probability, right? These are some things that you definitely need a lot of skill in. And I mean, a lot of people, I understand, they're kind of afraid of maths. They're kind of shy of maths. However, if you basically build these foundations in a solid manner, that will help you a lot in basically preparing for machine learning, right? Then if you don't want to take a research kind of position, if you don't want to be a very skilled in things like probability or linear algebra, then you can also look at machine learning and AI from the perspective of a framework of solutions, right? Just like Lego blocks. So basically, when you are building a structure out of Lego, right? You all have played with those Lego blocks, right? You have bricks. Those bricks have something poking out of them, and you can basically fix one block on another. So you can treat AI in a very similar manner. You can take common solutions that are applied to problems, and you can use those common solutions to tackle a bigger problem, right? You can figure out, okay, what solutions or what kind of structure, what kind of organization do I put these different solutions in to solve my bigger, larger problem. So if you look at it from the academic perspective, you can take either of those channels. You can either become very good at things like linear algebra, mathematics, statistics, and probability, and then start learning about the basics of machine learning, things like linear regression, things like what SVMs are, right? Things like different kind of problems are, things like what probabilistic models are. Or you can take the other approach and you can start learning different ways that people are applying these different models to different problems. So
absolutely,
diving more into that, perhaps. So I mean, if you're interested, if you're truly interested in learning more about machine learning, in getting the foot into machine learning, then we also have this introduction to data science course. It's a free course that will be available on YouTube, and that will be starting from next week. So if you are interested in getting your foot into this, then I would strongly recommend that you try to do that. Right? There's nothing to lose. It's a free course, and I mean, we'll try to make sure that the skills that you learn in that course are the skills that are actually going to matter in the near future. Okay?
Absolutely,
So, yeah.
absolutely. Just to add one thing here, guys. So as Pragya said that, hey, linear algebra, understanding probabilistical models, these concepts of maths are very, very important for you to become a good machine learning engineer. And some of you, as he said, that are shying away from maths, that, hey, this is too abstract for me, I would not be able to understand this, maybe I should not pursue that. Let me tell you one thing, guys. There is a big static friction there, that it looks very difficult at the very beginning. When, for example, if you're starting with linear algebra for the first time, you will feel that it is very difficult. It is difficult, to be honest. But then if you spend enough time, actually this is true for almost all the skills, but for linear algebra I'm speaking from experience, after a couple of weeks or a month or a two, when you start appreciating things and when you are able to identify unstated patterns, then you're able to identify and understand things at a intuitive dimension, things become very simple. So if you are scared of linear algebra today, my advice would be, please try to invest, let's say, a month at least on it, And after that, there is a big probability that you will start finding it a lot more intuitive, and you will feel that, hey, you can do that. From the outset, it may look very difficult. For the first few weeks it will look difficult, but do give it a try. In my opinion, having a good grasp of these basic mathematical concepts is very, very important for a machine learning engineer, irrespective of what you want to do. Of course, the degree of your understanding may vary if you want to do research, or if you just want to play and play and tweak these things to build a solution to it. But I would say that understanding these things, in my opinion, is very, very important. So should not shy away from it. Invest time. You will be able to do a lot better with time. That's my suggestion.
In fact, I would like to say something even more stronger at this point. So, I truly believe this fact that if you are weak at mathematics, or if you are scared of mathematics, it is not your fault. The fault is of your teacher, whoever taught you that particular subject. Right? If you're weak at mathematics, if you're weak at logic, then most likely you have not had good teachers in your life. Now, it's okay, right? Not everyone is fortunate to have enjoyed the support of the best teachers. I personally, I have done my education from both a third tier college in India and the best college in India. So I'm speaking from experience. I have perspective of both the sides. The difference that a good teacher can make, like a teacher that really cares about your learning, the teacher that can intuitively explain a particular topic, the difference that a teacher can make in your understanding is huge. Okay? So if you are feeling shy of mathematics, what I would like to say is, don't give up just yet. Just try out some other resources. Just try out some better resources. There's a lot of resources, I mean, free open resources like ocw.mit.edu, right? MIT's open courseware, a lot of courses online that Stanford provides, and a lot of hands-on training that companies like Scalar, right, like we provide, which is coming up in the next week. So don't give up just yet. Even if you're shy, just give it another try, because we are very proud of our teaching skills, and we can assure you that once you are through our course, you will, I mean, your perspective on these things, on these difficult parts of mathematics, will change completely.
Right, right. And education is one domain that may be totally revolutionized with artificial intelligence. This has access to good teachers. This is a big, big problem today. But maybe in the next few decades, a decade or two, you will see that maybe this will be totally revolutionized. Okay.
If we have any
So
more questions, let's take those.
Yeah. Let's pick up a few more questions. There is a question from Sai Teja. He says, "Do you suggest to focus more on code optimization techniques and code design, or anything else?" Okay. So Sai Teja, maybe I will talk about this for a while, and Pragya, then you can add on it. So Sai, as we said that, hey, focus on code design is one part of it, but I would say focus on architectural design. That's something which is much more vivid. That, hey, how are you going to architect systems? How are you going to solve optimization problems? Of course, very, very important. I would say that in general, how do you optimize something is something where beyond which a pot of gold is hidden. If you try to optimize things, that can be, you can try to optimize your code solution, you can try to optimize a problem. In general, that is something which is very, very important, a very good skill to have. I would say that, hey, focus on understanding that, hey, how systems are built, how systems are architected, and focus on developing the problem solving aptitude, that, hey, how can I solve a real life problem using the technology that I have. This is the skill which is most important, in my opinion. When you say code design, to be honest, I totally appreciate that, hey, writing code the right way is very, very important. It is very, very important if you want to keep your code modular, if you want to keep your code extensible. The first thing which is very, very important of a good piece of software is how well is it written. If it is written in a, for example, I will borrow one example from Bhavin. So he happens to be the founder of Zeta. He always, if you go and look at all the talks that he gives, he always says one thing, which is that the present banks that we have, if they want to make a new product feature, if they want to start add a new product feature, they actually are going to take several years to just add a small feature. The only reason for that is the bad way they have architected their systems, or the bad coding principles that they might have used, because now adding features on top of it is very, very difficult. And this inefficiency has actually created $1 billion market for companies like Zeta, who can come in between there and try to create solutions where banks with their old technology can somehow leverage their solutions and interact with the newly changing world. So yes, code design is important, but I would still say that, hey, architecture design, in my opinion, is much more important than code design. Code design can be automated. You will see, as you move along, you will see that, hey, refactoring code will become more and more automated. But designing scalable systems, coming up with architectural solutions, is something which is going to be much more important and much harder to automate, in my opinion. Pragya, what do you feel about that, man?
Right, so I totally agree with that. But since Sai, I think Sai is one of our Scalar students, right? And Sai has been, Sai has recently been through the low-level design and high-level design courses. So my low-level design and your high-level design courses. So I suspect that his question is a little more involved. So once again, Sai, basically, as Tarun said, most of the refactoring things can be automated. However, in refactoring as well, there's a huge perspective, there's a huge spectrum, right? So things like indentation, things like variable naming. Nowadays, if you're using a modern IDE, you almost never care about indentation, right? The IDE automatically indents the code. So those are the skills that you're not supposed to learn. The skills that you're supposed to learn in design, in even low-level design, are breaking down a problem, right? Taking a problem, collecting the requirements, figuring out how to design the solution for that problem, right? Learning the design patterns, learning the large-scale architecture, or learning the different ways, looking at the different case studies of how different companies have implemented their architectures. Those are the kind of skills that you have to learn. Similarly, skills like understanding data structures and algorithms, right? Because those skills are central to your problem solving skills. Those skills are the things that are going to be important for you. Learning things like, okay, am I very good at Spring Boot? Am I very good at .NET? Am I very good at JavaScript? Those are the skills that are less relevant to you. And as time moves forwards, these things, these frameworks, these technologies, they are going to be phased out eventually, right? They are going to become irrelevant. The problem solving is going to remain forever, basically.
Absolutely, absolutely. Okay, so there is a question from Gaurav, and that happens to be a very, very interesting question. He says that he has read some articles which says that AI can be very dangerous as well. How companies are taking care of bad aspects of AI so that this awesome evolutionary change due to AI does not end up misusing the technology. So yeah, that's a very, very interesting point. Pragya, would you want to take lead on that?
Yes, definitely. So first of all, what I would like to say is that yes, the picture is not all rosy, right? We are not here to paint the utopia over here. AI, like with any technology, AI gives us a lot of benefits, but it also comes with very significant risks. And since AI has the potential of being one of the most powerful technologies, the risks are also very significant. Okay, so let's go back to the invention of AI, right? So perhaps the first artificial intelligence system that was theorized was by Claude Shannon, right? So I'm sure that all of you have heard of that person, the father of information technology. In his bachelor's thesis, he gave information technology, but very few people know that in his master's thesis, he created something called the Shannon's mouse, and that was the first artificially intelligent device, basically, right? And he used to believe that in the near future, basically 100 years or 200 years from now, what we will have is we will have robots take over the entire world, right? And basically, Shannon had that opinion. Now, I'm not saying that is going to happen, but a lot of very powerful, a lot of very knowledgeable people also share that opinion. So, if you take example of Stephen Hawking, people like Stephen Hawking, people like Elon Musk, people like Bill Gates have warned us about the very real risk of AI taking over the world, right? Now, there's a way to handle this. It's not like there's nothing that we can do about this. This, like most problems, is definitely a solvable problem. However, if you expect just large companies to solve this problem, that is not going to happen. The solution has to come from you, right? So what I would basically stress over here is that since you are the engineer, since you are the future of the world, it is your responsibility to take these things as a challenge, to upskill yourself in these fields, and to make sure that the AI in the future is safe here, right? So there's a lot of research that can be done about things like what safe AI is. There's a lot of research that can be done about basically making sure that the AI is not trained on biased data, right? So you might have heard cases in which Facebook's AI, right, that started tagging black people as animals, right, as orangutans, because it was trained only on the images of white people, right? So it is your responsibility as a machine learning engineer to take care of these things, to understand and come up with solutions for these things, right? Apart from that, there is also a lot of research that can be done in how to best apply AI in the large scale society. So as we understand that, if you look at any particular technology, whenever a new technology comes into the picture, it only increases the distance between the poor and the rich, right? So this income gap, this disparity between the powerful and the less powerful, this only increases because of a new technology, and that is a very real concern with AI as well, right? So if you look at billionaires, if you look at large scale companies that are using AI to basically remove out any competition, right, there's also a very real risk of AI being weaponized. So if you see nowadays, there's companies like Boston Dynamics, there's several other companies that are basically trying to automate killing machines, right? So that is a very, very real risk of AI. And the only way forward, the only way we can tackle those things is, first of all, to educate ourselves, right? To upskill ourselves in this field. And secondly, to be more vocal, right? To actually bring ourselves into these fields and basically shape the future ourselves. So yes, that is kind of what I think. Yes.
Right, Pragya, I would just want to add a couple of more points here, which I feel are which are very, very near term. Matlab, we can actually see those things happening in a very short duration of time, and maybe we are already seeing those things happening. And this is a very, very interesting conversation. So I will maybe just take 5 minutes to discuss a few things here. So first of all, guys, the point that Pragya said that, hey, with new technologies, one unintended consequence of a new technology may be that your bar to entry increases a lot. Let's talk about that a bit. For example, if you want to come up with a new Google Maps today, will you be able to do that easily? The answer is no. It's very, very difficult. The point is that the amount of data that Google has accumulated, it has set a very, very high bar of entry for new solutions to emerge or new competition to emerge. And to be honest, from a very structural point of view, any domain where there is no competition, we are headed in the wrong direction. Similarly, let's talk more about that. For example, Amazon today has so much information about what are the things that we really would want to buy, what are the things that the market wants. Now, if I come up with a new product today, which is very, very interesting, I would want to use Amazon's distribution to be able to reach out to the masses. Now, Amazon can very easily, and it is what it's actually doing, unfortunately, it is very easy for them to copy my idea to create a clone product and to use their distribution to now actually sell that at a much cheaper price now and just gobble me up so that there is no competition. For example, the companies like Swiggy, Zomato, they are valued so much. We have a Zomato IPO coming up in the next few months. Now, Zomato is not only valued because the deliveries that they are making, but a very, very important part there is that the data that they have aggregated. Zomato would know that, hey, if I want to sell curry chawal in Delhi, what's the best price to sell curry chawal in Delhi for? What is the best time where people are actually? What is the time where people are actually going to order a lot of curry chawals? What happens in different seasons? What happens in different parts of the city? What's happened in different times of the day? Now that data is invaluable, right? And this actually increases the bar to entry. For example, tomorrow, if I want to open my own restaurant, or if I don't want to open my restaurant, I already have a restaurant. Now it becomes very difficult for me to compete with a company like Zomato or Swiggy because they can actually use that data, leverage that, and come up with a new cloud kitchen tomorrow, which will perform much better than me because they have access to a lot more data. Now, what I'm trying to say here is that a very real risk is that the barrier to entry may increase significantly. The companies that are already powerful may become significantly more powerful, and the others may actually be left out of the possibility. They do not have the possibility of competing and coming up with ingenious ideas. That is one thing that I fear the most about And this is not only for AI, this is actually for any new technology that comes up. But this is one thing that I really fear about. Another thing that I would also want to talk about is the information warfare that is happening. So now, guys, if you appreciate, all of us have our own social media presence, right? And the main source of our news happens to be social media today. I hope everybody agrees to that. Nobody now, very few of us actually read newspapers today. Our news actually comes from our social media. Now, try to imagine, try to understand that what we are essentially doing, we are exposing ourselves to the possibility of an information warfare. Now, if in my echo chamber of my social media, I only see the news that somebody else wants me to see, do you understand that you can actually change the way a society thinks? You can change the way a group of people think and maybe hide the things that would have mattered to them and only show them the things that you would want to show them. So this information warfare, you would have heard about companies like Cambridge Analytica. So this is a company which actually helped different political parties throughout the world trying to tailor make their reach, their outreach to potential voters. Now this, what they do is they would want to hide all the negative things about a particular candidate that you would not want to show to a particular set of people, and only amplify the messages that are very heartening for that group of people to see. So what you can essentially do is, so essentially, just one more minute I will take, and then we can move to the next question here. So if you think about politics, in all honesty, politics or governance is a monkey balancing activity. There is no easy way out. You can't come up with a new scheme which is going to make every single person happy. Now, if you come up with a new bill, you come up with a new law, there is bound to be one segment of people who will be happy about it, and there is bound to be another segment of people who will not be happy about it. Politics is all about monkey balancing. Now, if you leverage this information warfare, what you can do is everybody will have you can put anybody on a spectrum and say that, hey, these are the things that I like about him, these are the things that I don't like about him. Now, what with information warfare you can do, you can only expose the things that somebody would like about you and just make them totally not, they would not even know about the possible downsides that you actually come up with. So this is very interesting and a very important field. The first thing that we should do is to make ourselves cognizant. That is, before making our very strong beliefs about something just because of a few articles that we read online, first thing that we need to do to fight this is to be cognizant of the fact that, hey, maybe our source of information is biased, maybe we don't have the full picture in front of us. So it's very important for us to first of all absorb everything and only then try to make opinions. So this is the first thing that we should do, be cognizant of the possible effects that technology can bring with itself. Yeah. Okay. So not very sure if that was very boring to a lot of you, but I just wanted to share that because that is very important for us to be cognizant of. Okay. So now there is a question from Suraj. He says, difference between a machine learning engineer and a data scientist. How do these two roles differ from each other?
Right. So, I mean, there's not a lot of difference between these two roles. And in fact, if you look at most companies, they don't really care about the title, right? They don't really care about the title either. So, from the, I mean, there's a lot of gray area in these things, and there's not a clear delineation. However, traditionally, if you look at the data science role is more about looking at data and simply making inferences manually from the data. So, for example, imagine that you are part of a fintech company, right? You're dealing with a company like DE Shaw, and what DE Shaw does is basically takes investments from different investors, from large scale investors, and DE Shaw figures out that, okay, what are the best companies to invest into, right? Best equity companies, best different types of stocks to invest into to give the best return to the investors. Now, if you're an analyst, if you're a data analyst with DE Shaw, your job is mostly looking at a lot of data about these companies, looking at the past performances of these companies, and coming up with predictions that, okay, this is how the company is going to perform, right? That is the job of a data scientist, looking at data yourself and coming up with inferences. The job of a machine learning engineer is primarily to take this and automate this completely. Okay, the job of a machine learning engineer is not to say that, okay, given this data, what are the inferences I can make. The job of the machine learning engineer is to say that, okay, given this data, what algorithm can I apply on it, right? So that the algorithm does the job of the data scientist for me. Okay. Now, as you can imagine, both these jobs have a lot of overlap between them. Right? If you are a good data scientist, it is very likely that you are also a good machine learning engineer. Similarly, if you're a good machine learning engineer, it is very likely that you are good at making those data inferences yourself. Right? So there's a lot of overlap, and mostly the companies don't really care about whether you are diving into a data science profile or whether you are diving into a machine learning profile. So what you should focus on is learning the basics of machine learning and data science. You should learn the basics of probability, the basics of this machine learning theory. You should not really focus on what the exact job title is, because those job titles are very meaningless and they are very flexible in the current world. Cool. So yeah.
Yeah, just one thing there, Pragya. Of course, there is a lot of overlap between these two job titles. But one thing that I've noticed after looking at multiple job openings and multiple job offerings, I have noticed that companies usually give the title machine learning engineer to folks who are much more heavier on implementation. They would be much more, their job role will involve a lot more implementation, versus people who actually call themselves data scientists are usually folks who would want to just build models and then give those models to somebody else to actually implement. But as Pragya said, if you want to become a good machine learning engineer or a good data scientist, then you will notice that there is a lot of overlap, a lot of skill overlap between the roles. But one thing that I would just want you guys to be wary of, that I have seen a lot of machine learning engineers who do not necessarily have a very good grasp over the fundamentals of machine learning. That is something that you should personally avoid. If you want yourself to call a machine learning engineer, that's great, but make sure that you're not somebody who does not have a very strong grasp over the basics, the basic understanding of data science, the basic understanding of machine learning models. This is something which is necessary if you want to have a good career ahead of yourself. That's it. Okay, so there is a question from Shreyas. He says, is there a demand for people who have both the skills? They have data science skills and they're also good software developers. The short answer is, of course, yes. There are lots and lots of companies who would love to hire people who are good software engineers. At the same time, they have a good understanding of data science as well. So if you are somebody who has both these boxes checked, I can assure you, you are going to be in great demand. That is a very you should actually, if you are a software developer and you are figuring that, hey, maybe what's the next one skill that I should add to my understanding that will maybe help me grow a lot, you can think about data science machine learning. If you understand the principles of data science machine learning, maybe you will get a lot more doors will open up for you. Similarly, if you are somebody who is very good at theoretical data science, you know how machine learning works, you know how different models work, and you are good at understanding models, trying to figure out that, hey, what model to apply in what problem. If you also pick up the skills of implementation, if you also pick up the skills that are important for a software developer, that is, you pick up the skills of architecting systems, then you can increase your value by a lot. You can also increase the kind of impact that you can make by a lot. So that's my short answer. Yes, there is a big demand for people who have both these skills.
Right. And in general, Tarun, I think, pointed this out earlier in the conversation as well. The most important and the most impactful jobs that are there in the world are the jobs that are interdisciplinary, right? The jobs that are at the edge of two different skills, right? So it is always a good idea to be a kind of a T-shaped person, right? You should have a broad perspective. You should try to make sure that even though you have mastery on one skill, you should try to expand your horizon, because the true innovation that happens at those boundaries. True innovation happens when you mix two ideas and you come up with a new idea, right? So yeah, that is basically it.
Hey Avik, hi. It's so nice to see you also again after some time. Will ML be the road ahead in tech? Okay, so will machine learning be the road ahead in tech? Maybe. So just to summarize what we have been talking all about, that yes, in my opinion, machine learning or data science or artificial intelligence will become the dominant player or the dominant theme in the next industrial revolution, the industrial revolution 4.0 that we talked about. So yes, it is going to be a very, very dominant theme, in my opinion. You are going to see lots and lots of new companies and ideas mushrooming, where you are going to leverage data science and build a lot more impactful products. So you think about anything in general. For example, if you think, pick up any domain whatsoever, pick up, for example, education. Now you will have a lot of great companies emerging in the domain of edtech, but you can see that in the future, data science, artificial intelligence is going to be a big part of the story in education also. You pick up any other domain. For example, you think about getting people to move from one place to another, right? So we already have airplanes which are almost automated. The pilots come into play only for very short durations of time, and also for very some of the exceptions that actually can arise. But a lot of flying the airplanes is totally automated. Similarly, you are going to see in the future that, hey, a lot of trucking industry, actually interstate traveling over highways, where you have a truck trying to move some goods from one part of the country to another part of the country, you are going to see that this will become automated in no time. There are some very, very interesting organizations, some very, very interesting companies that are trying to automate a big portion of the trucking industry. Of course, there will be a truck driver, but that person will just be there to handle exceptions, and majority of the boring truck driving on highways at the constant speed will be automated. Similarly, if you look at, let's say, driving, self-driving cars is going to be a reality in our cities also, maybe in the next 15-20 years. So yes, machine learning, data science is going to play a big role there as well. To talk about Uber, you talk about Ola. These are big organizations today, right? And these are you see that, hey, they have utilized tech in a very, very ingenious way and solved a real life problem. But now, what is the major problem that Uber faces today? The major problem that Uber faces today is the driver side of things. If they want to maximize their profits, the first thing that they would want to get away with is drivers, unfortunately. That is what decides in different geographies, different kinds of profits that a company like Uber can make. So now, if you have a scenario where you can use machine learning, you can use data science to actually automate this intra-city driving as well, then these companies can actually become much bigger, and you can have a scenario where tech and data science, being a very important part there, can actually revolutionize industries altogether. Similarly, let's talk about just one last example, and then I will hand over to Pragya to add his ideas. If, for example, your driving becomes automated, you have the, artificial intelligence driving your cars. Now, it's very important for us to understand that this will have a big implication on, for example, the insurance industry. Now, if there are no humans driving cars, the probability of you requiring car insurance, most of the accidents actually happen because of human error. If humans are thrown out of the picture, now the probability of you getting into accidents is very less. Why are you going to pay hefty premiums on your cars to insurance companies and just to keep your car insured? If the probability of accidents reduce, then this entire industry ceases to exist. Similarly, you can imagine that yes, the next wave of revolution will have data science, artificial intelligence at its very heart, and you are going to see lots and lots of ramifications, and we as humanity moving to a much more optimized version of ourselves. That's what I feel. So yes, Abhik, if you want to learn machine learning, go ahead, do that. Right time to learn this new skill. You are going to notice that, hey, it has helped you a lot in your longer career.
Cool. So one thing that I would like to point about here is that machine learning is like a spice, right? With any technology, it spices things up. It adds on new capabilities to what you can already do. So it is not going to be the case that machine learning is going to be everything in the world, right? It is going to be at the center of everything, but it is not going to be everything. What you have to understand is that the future is going to be, everything in the world is going to involve a bit of machine learning. However, the domains are still going to remain valid, right? So what you should focus on is learning how to apply these skills of machine learning, right? This technology of machine learning in different domains. And that is true with any emerging technology, be it machine learning, be it something like blockchain, be it something like quantum computing. What you have to understand is how these technologies work, and you have to get that understanding so that you can know how to apply these technologies in different problem domains. Okay, so the point over here is that machine learning is a theme. It is going to spice up everything. It is not the entirety of the world. Okay, cool. So yes, let's take the next question, Tarun.
Right. So do we need a good infrastructure to study machine learning? By infrastructure, I mean hardware resources. A very, very important question by Nitin. Pragya, so Pragya, he's basically asking that, hey, what are the bare minimum hardware requirements that are required for me to do something meaningful in machine learning?
That's a great question. Now, if you look at most of the sciences, if you look at something like physics, right, there's an amount of physics that you can do studying. I mean, there's an amount of physics that you can learn via the books or via videos, right? So anything up till class 12th level, you can fairly do. However, as you move higher, you have this requirement of really amazing machines, right? You require laboratory equipment. You require large scale machines, be those particle accelerators, be those CNC machines, be those a lot of different things. You require a lot of expensive equipment to grow further, right? Now, traditionally, computer science has luckily been, has avoided this problem, because all you need to be a good computer scientist is bare minimum laptop, and you just need your brain to think about things and basically come up with new solutions. Okay. However, with the advent of machine learning, especially with the advent of big data, this scenario is changing. For example, if you consider something like OpenAI's GPT-3, right? It is estimated that training that GPT-3, right, coming up with the architecture is different, but just training that GPT-3 on the data required a person to invest $16 million. So if you don't have $16 million, there is no way you can train GPT-3, right? So that is true. That is true that because of AI and because of machine learning, you cannot train large models unless you have access to those expensive resources. However, that is only a very small part of machine learning. Okay, if you still want to do very core research, right? If you still want to contribute meaningfully to the domain of machine learning, it is still possible to do that, and it will remain possible to do that for the next, 10 to 20 years. You can still meaningfully contribute to machine learning without having fancy equipment. Okay, so don't try to think that if I want to become a machine learning engineer, that I definitely have to have a RTX 3070, I have to have a top of the line CPU, I have to have a top of the line machine. That is not true. In fact, with companies like Google, right, I'm sure you have heard of tools like Google Colab, right? So a lot of these companies, what they're doing is they're providing free resources for students, for researchers, for startups, free resources in the cloud. So you don't have to have a powerful machine on your system. You can have a very, very basic laptop. You can connect to Google Colab, and Google Colab will provide you the necessary GPUs, the necessary computation power that you need to basically grow in this field and to do important research in this field. Yes.
Absolutely, guys. So if you want to start, Google Colab is the answer. That how do you start, right? So if you want to train any of your models, go ahead and use Google Colab. Pragya, if I'm not wrong, for normal accounts, you get what kinds of configurations do you get in a normal Google Colab account?
I'm not well aware of that either. But I mean, you will not run out of resources anytime soon, right? You can learn most of the machine learning, almost all of the machine learning. You can learn on the systems. You require fancy equipment only when you are dealing with industrial level problems. Only when you're saying that, okay, I have data of millions or billions of users. Now I have to train a model on that. That is the only case when you actually require those large machines, those large clusters. For learning machine learning, you can simply have a basic laptop and use Google Colab completely, right? That is going to be more than enough for you.
Okay, guys. So it's 6:30. We will just pick up one more question now, and then we'll end the session. Let's look at the last question. Do we have any more questions? Okay, there's a question from Hari. He says, what are the chances of a bot gonna have emotions and become biased? Okay, so what is the probability of your AI become biased? We have talked a bit about that already, but yeah. Hey Pragya, would you want to add on to that?
Yes. So I mean, there's a lot of debate around this area. Frankly, from my perspective, I am a firm believer in the fact that everything that humans do, it can be automated, right? So you can totally have a bot which shows emotions. Now, I'm not talking about the big picture. I'm not talking about the philosophical things over here. I'm not talking about whether the bot will have free will or whether the bot will actually be conscious. I don't care about any of those things. What I am saying that the bot will at least be able to mimic human emotions. Right? That is a very real possibility, and that is going to come soon enough. Right? 20 years down the line, that is going to be a reality. Okay. Now, what are you going to do with this bot? Are you going to take a bot like that, and are you going to put that bot in charge of important decisions? Right? That is not likely a scenario, right? Why would you do that? We already have seen that humans make a lot of errors, so it is not a very big. It is not a very. I mean, it is not a very likely scenario that we will have an emotional bot be in charge of important decisions, right? Be in charge of important governance or political decisions. So, I mean, once again, taking your question, having a bot that has emotions is a very real situation, but that is not going to be a big problem for us because you won't have that bot in important decision making places. Okay.
Right. So of course your artificial intelligence can become biased because just by the kind of model you build, your models can always be biased. Pragya gave an example where some machine learning model of Facebook was not identifying people of one particular color as people, which is of course your systems can be biased because of the kind of data you feed that to. Emotions, as Pragya rightly pointed out, you can mimic emotions, but to be honest, I personally am not very worried about AI actually being consciousness of its own. It's a very big topic. There are very strong arguments on both sides, but let's not go there, discuss that right now. But yeah, I would say that, hey, of course your systems can be biased. You can also mimic emotions to some extent, but that's not the most worrisome aspect here. But yes, how to make sure that your systems are not biased, that is important, and we should be cognizant of that, and we should take efforts to ensure that the systems do not get biased, because it's very easy, right? So you can always have a sampling bias, and your the patterns that you show can always be biased, and your machine as a result will always end up being biased. But yeah,
and basically the only way of making sure that that does not happen is to take action, right? Don't let your future be dependent on what other people do. Upskill yourself in these areas, right? Be vocal about these things, learn these things, and take action yourself. Shape your own future. That is kind of the summary of this talk, basically.
Make sense. Make sure that you have a seat on the table, and to get the seat on the table, make sure that you are upskilled enough. So yeah, that's a very nice way to summarize this session. That yes, it's important to maybe try to upskill yourself in these domains, and then so that you can also have a say in what happens with your future. Just one reminder, guys, we are starting with a course on machine learning and data science at Scalar Academy YouTube channel from next week. If you are interested, feel free to join us in that course. It's going to be a totally free course where we are going to take you through the basics and help you become better at machine learning data science. And if you have any questions, feel free to write to us. You can also connect to us on LinkedIn. My name is Tan Malhotra. Pragya was there with me. Thanks a lot, everybody, for joining in. Hope to see you guys again pretty soon. Bye-bye.
Have a nice day, guys. Bye-bye.